dip IC. Screen. So one thing we're doing with this, we're trying to make it so it's still connectable using 0.1 inch soldered connectors if you need it. So the things we're retaining are the prop plug connection, 2 pins for power in, 5 volts in, and 1 parallax accessory header down the bottom. Left over from that, there's 1 user pin, 1 single user pin, which is to keep Brian happy. He always likes to be able to have just a single pin which you can at least get a result out of. We're also putting a user LED which sits on P56 on the module. So super compact. Those who are familiar with the US dime coin, which is sort of I think the smallest coin, is that correct? 0.7 of an inch is the same width as a dime.
That's right.
Yeah, so it's compact. Just for a trivia question, does anyone know how many serrations there are on the outer edge of a dime? Anyone know? Want to have a guess?
I'd say 150.
That's a good guess. It's 118. So what it means is that what do you reckon's got the greater pitch, the P2 pins or a dime serrations around the radius, around the edge?
Oh.
Yeah, the dime is only marginally, like the serrations and the pitch around the edge of the P2 are about the same. So that's the top side view. Where it gets interesting is looking at what we've sort of crammed underneath. And so all this is sort of hiding underneath where the ground pad of the P2 is. And so it's got some inherent shielding because you've got, this is hiding underneath the ground, the metallic ground pad. So in the top left corner there, the blue square is a flash chip. We're still looking at what final size that will be. It'll either be a 64 or 128 meg. Depending on supply chain issues at the moment, really. Top right corner, the green square is a 1.8 volt switching regulator. We're looking to use most likely the same regulator that Pete used on the P2D2 board. It's a Torx part, and it's also now seemingly made or second supplied by Murata. In the middle, let's go, bottom left is a 3.3 volt switching regulator, and that is likely to be a TI part at this stage. And we've got an alternative with the Murata second source. And in the bottom right, we've got a 20 megahertz crystal, a standard 20 megahertz crystal. All those parts have to be super thin because we want to stack this onto a breakout circuit board. And so they're all less than 1 millimeter high. The dark blue circles are standoffs for getting both doing a solid grounding operation, providing mechanical rigidity, and they're a threaded standoff. They take a screw and they allow us to screw the board down to a carrier board for, if you had some high G applications or you're worried about vibration. They provide that, but they also get heat out of this little circuit board. Obviously, there's not a lot of area, so that's how we're dealing with the heat issue. Not that there's a lot of heat, but it just provides a pathway. And then finally, in the middle there, that sort of orangey yellow coloured long rectangle is the high density connector, which we break out almost all the signals out to the breakout board below. It's, I think we're probably on the next slide. Oh no, we go back. So this is the accessory header on top of the board. We've just got one accessory header, which takes a standard parallax accessory. And that's over at the, it can be soldered a few different ways. We can go down to the baseboard, or we can have header pins coming up to the top. So you can plug in from the top. For those who remember, we were doing a MicroPython sampler. We had an encoder, USB and VGA on one one single board. That's what we're intending to be able to demonstrate this, so we can demonstrate MicroPython running also featuring the 1-pin encoding, where we bring the whole encoder and its LEDs onto one single P2 pin to demonstrate what the P2 pin can do, while still having VGA and keyboard accessible. This is designed for both cascadability and stackability. Brian, who's online, Ozprop, he's been working hard on multi-loading, like multiple propellers where you've got more than one in a stack or in a row. And so we have two ways. We can either cascade the boards end to end and provide, a jumper link or a little link board to connect them together, or we can stack them vertically using the 0.1 or 0.05 inch headers, or we can also make stacking boards using the 60-pin high-density connector to have both a plug and a receptacle on opposite sides of the boards, and you could then keep stacking up vertically. The best way I think to describe that is it's a bit like a skyscraper with a big lift shaft in the middle, where you've got all your I/O and communications running up the lift shaft, and you've got your peripheral connections out around the edge. Are there any questions so far on stackability? Or
I'm curious, you probably have a picture of the back with that high density connector, right?
I don't. I haven't taken actually, no, I don't. Sorry, I don't have a picture of the back, but I don't know if you can see that. I can't tell if I can't see if that's in focus. Oh, here we go. So that's, let's check, let's use this.
That connector is really tiny.
Yeah, it's super tiny. The pitch on the connector pins are 0.35 millimeter pitch. And so it's I think it's as compact as they go, and this interesting thing happens as you go smaller and smaller. Things initially are more expensive, and then you get to the far end where you're doing the ultra small stuff, and they become cheap again. It's about 1 cent per pin. So it's around the cheapest form of connector you can find out there. I think it should be cheaper than the 80-pin connector used with the edge and things like that. But it needs, obviously, you just need to have a pretty fine PCB process to deal with it, and really good eyes to look for any faults. And we're going to be challenged, but the reward is good. It's super compact. One observation is that the size of that connector is pretty much the size of the end of a prop plug. So it's about 10 by 2 millimeters, which is pretty much what the area of a prop plug end is. But instead of having 4 pins, you've got 60 pins and 2 pins for power. I'm just looking to see if I had a. Yeah, so one other aspect I haven't highlighted there, but I haven't mentioned it, but there's also 2 pins, the +2, so 60 + 2 means 60 signal pins, which are rated at 300 milliamps, but also it has 2 power, what they call nail pins on the end, and those are rated at 3 amps each. So you can have, like your battery or whatever connected through the same connections. Which is plenty for what we want to do. Obviously, we're looking at taking 5 volts in, so we're not at the same sort of current level as the 1.8 volt regulator puts out. So a little bit about the standoffs, which are underneath. They're again, all these components are about the smallest ones we can find. So the standoffs are they're a 3 millimeter standoff. And 3 millimeter OD standoff. They have a 1.6 millimeter thread on the inside, which is pretty much like your laptop screws. Those little fine screws that they use on laptops. They're around 2 or 1.6 millimeters. So it's a threaded standoff. As mentioned before, they're good for grounding. They're good for heat transfer. They're good for mechanical rigidity, sort of easing the ability, the pressure on the high density connector. And just 1 millimeter high. which happens to be the same thickness as the P2 chip. If you want to get heat out in a sort of a crude way, you can also solder to them. So you could solder like a copper heat spreader or something like that if you really wanted to. So there's a few different ways to work. Those are tucked underneath the P2's 10mm exposed pad. So they directly bond, or they're very super close to that pad area. They're right on that 10mm square ground pad.
Now, how will you affix those to the PCB? Will you just press fit them or reflow them into place?
They reflow. They're tin plated, so they reflow. They
you
have
probably. What part would you reflow? Like the first one?
They provide it's almost like a donut shape of solder paste which sits under the ring. So they recommend a paste pattern, and it just sort of sits underneath there. Obviously, some's going to go down into the pin, into the hole, I should say.
So it doesn't get on the threads or anything.
No, it won't get on the thread, other than, you know, something if you put too much paste or a paste in the wrong area. So that's one of the challenges we've got, just to make sure that they don't get too much paste. But if we have to, we can always put like an isolation barrier to stop the paste flowing across like a moat.
Yeah.
If we need to, but I don't think we're going to.
No, sure.
I don't think we'll. Yeah, I don't think they're going to come up the thread. And the other thing is, sometimes we put solder inside holes to actually provide a thread. So, you know, the screw, when it goes in, just kind of eats its way into the solder, which is soft anyway, on some other products here. But
hey, JMD was just asking, what happens if the screw is too long? I think he has visions of it like pushing the chip off the circuit board.
You see far ahead, JMG. It's fortunate that as long as we set up the board thickness correctly, and as long as the boards are to spec, we have 0.2 of a millimeter of extra space. But you're right. If you got a longer screw, like these screws go up in 2mm, or some of them 1mm increments in length, and so if you did have the wrong length screw, you could theoretically push it off. But you'd have to get an awful lot of torque to move a 10mm pad with through-hole vias with vias on it as well, to shift that off the thing. We can do a test, I guess, and just see how far you have to screw it to lift it off. But it's going to be a really major effort to need that, and I'm guessing you're not going to be able to get the torque on the screwdriver in the first place. But we can try. You can get cap head screws with Allen key, which enable you to get a bit more torque than you would with the average screwdriver, Phillips head screwdriver.
Lachlan.
Yes, Enrique.
Please, in case you need, can you use a kind of washer that exerts some pressure against the over tighten of the screw in the other side?
Yeah, you can. You could use a washer. We're going to look at that, because it's going to be worse for heat transfer, but it might be good for protecting the mating circuit board and things like that. So you're quite right. You could change the spacing. The way we do it, as long as we use 1.6mm circuit boards, we're fine. A 4mm long screw combined with that 1mm gap gives a 4.2mm overall thing. And these screws, the shortest length they come in is 4mm, that I believe. So so we'll look at it. But you're quite right. You could have a washer on the far side, and that would provide some kind of spring. I think the connectors are meant to be 1.0mm plus or minus 0.1, so they'll probably slide a little bit if you need to.
If I remember right, we have at least 4 kinds of pressure washers, so we can choose the best type to use in that case, from ones that are able to exert some pinpoint pressure to enhance the electrical contact, towards the ones that are very, very tiny so they can be stacked more than one piece and exert as much pressure as needed. Okay, okay, thank you.
No problem. Yeah. So here we go. Talking about the connector underneath. So this there's about 4 different brands of companies who make this size or this pitch of connector. This is a Molex brand connector, and that's mainly because of the mated height being 1 millimeter. It's a little bit more than the other brands, and that works out well with our standoffs and also our switching regulators. So as mentioned before, these have got a 3 amp rating for the 2 end nails, which are the solid metal, the silver solid things at the end. They're rated at 3 amps, and all the other pins are rated at 300 milliamps each. We were able to break out 60 pins, which obviously we'd love to have a 70 pin version of this, but they just don't seem to make, although it's on the data sheet, they don't seem to make that size. So, you know, if we can get volume up to maybe 100,000 of these things, then maybe they'll consider making the 70 pin version where we can break out all the pins. So the pins we don't break out are the pins which are on the parallax accessory header, the 8 pins P24 through to 31. Those are accessible, obviously, for the accessory header. So they're the ones we dropped off the connector. We bring in the crystal, the XI thing, in case we want to synchronize clocks from multiple modules. And we have an inline isolating resistor so that we can disable or enable that connection. So we don't, you know, radiate out the, you know, the sensitive XI node. They're rated for 30 mating cycles. So one possibility, or one thing we hope with this board, it's going to be an expensive board in some ways, because, you know, by the time you have the P2 and its supporting components and all that kind of thing, you're up to, you know, a few decades of dollars. And then but the good thing is all the breakouts after you do that, you know, on the mating boards, you literally have one of these connectors, which are about, you know, 75 cents each roughly, and the circuit board. And because the P2 is so good at having all its passives inside, you know, for driving video and other things, and pull-up resistors and current sources and everything, a lot of the breakout boards are just going to be, you know, one of these high-density connectors and a circuit board, and that's pretty much it. And so the actual breakout boards are going to be dirt cheap. And what we'll likely do is sell this thing in a pack which comes with some breakouts, some useful breakout boards. And that way it kind of makes it an overall good value kind of thing. But the other upside to that is that you can just move, you know, if you want to move this from one board to another, you can do that. And so in effect, you'll be able to have multiple proto boards or something similar. And, you know, you might not have as many of these P2 plug-in boards, but you can freely move things between them and therefore preserve value. But also future-proof, you know, if somebody comes out with some new, you know, Raspberry Pi to a different connector format or a different kind of board outline, then you can easily kind of then quickly match that and just have a breakout, a low-cost breakout to match that. So in many ways, this kind of becomes a future-proof solution.
That's pretty amazing how small they can make connectors these days. I mean, that is like the edge of the prop plug, isn't it?
Yeah.
0.1 by 0.4. I think you meant to say 60 pins in about the same footprint as, oh yeah, 4 times 0.1 spaced. Yep.
Yeah, it is. It literally, I think it's 10.2 millimeters by, it's very much the same. In fact, the 60 pin connector is slightly narrower. It's 2 millimeters wide, and the prop plug is, you know, 2.5, so, or 0.1 of an inch wide.
I wonder if the adhesion in those connectors is good enough. So what if you just put 2 of those on at offsets, right? So they're spread out a little bit, so they straddle, and then you just have these like replaceable modules that do you think have like enough seating force to keep it locked in with thermal cycling and all that?
Yeah, they have the part of the inspiration for this was the MicroPython. Like Damien makes a PyBoard D, which has 2 of these connectors on board. They're a different connector, different type of connector and a different pitch. But he has 2 of those, and you can plug in the things. I'd be kind of worried about having 2 of them just because your alignment becomes quite critical. But I believe, like, if you look at the connector here, this is the connector of the mating, like the breakout circuit board, and every single connection has like a U-shaped folded bit of metal, and so that U can move slightly. And the other side,
it would be a function of how accurately the pick and place put the parts on, right, and then refloat them into position.
Yeah, it's probably also related to the accuracy of the pads, because the solder tension is going to pull it. Like if your pads are kind of, so
it could self-correct.
Yeah, and look, we're not interested in, like, we'd rather sacrifice those 8 pins and still have the other 60 than put a second plug on there and deal with the alignment issues. But if other people do it, presumably, it works or can be done. So,
well, I'm thinking with enough pins also, you could have a lot of power and ground stuff. And it might even be a good way to pull heat off the chip and get it down onto the board that the mating connector's on.
Yeah, you're right. It's an alternative heat transfer thing. At least where your ground is, it would be easy to do that, to soak up the heat and get it through the ground nail. The only trouble is it comes down to, although these are rated at 5 amps and there's a lot of metal at the end, that the pads where that hits the circuit board are really similar to the pins. There's a real narrowing where the current goes through. So even though they're rated at 3 amps, at one point you're just going through something which is maybe 0.2 of a millimeter wide. Like an 8 mil track almost, and it's kind of obviously that's what they're rated at, but it's ambitious, I think, to get a lot of heat through there. The standoffs, by contrast, although they're not like the same as a copper plane, they've got both the standoff, which is made from steel, and they've also got a screw running up the middle of them to also work. So you've kind of got a fairly solid 3 millimeter post, which is also only is only 1 millimeter long. So you kind of, I don't think we'll see a lot of heat resistance, or we'll be able to measure this and see how much temperature rise we get for current or watts put in. But,
it kind of makes me want to make a board with like maybe a 4x4 array of P2 chips. With it, we wouldn't need any of this stuff really, but that'd be another problem or another solution looking for a problem.
It'd help us, Chip, if you make it.
It would?
Yeah. No, it's
the trouble is, it would take a lot of juice to run that thing, right? If you had 16 chips and they're each drawing 2 amps, that's like 32 amps at 1.8 volts. But
USB can now power more chips than it used to. You can sort of take 2.5 amps or even up to 5 amps with the USB-C kind of technique. So that's like 10 P2 chips at least. The P2 seems to sit comfortably under 500 milliamps at 5 volts. So you could have 10 or something like that. When we get these pick and placed, there'll be likely 15 or up to 15 of them on the board, on the panel which gets made, and we might just leave some connections there for testing, so that we can just power up the thing after all. Because Brian's written like a party line loader kind of thing, so we can just fire up each P2 in turn and make sure it's responding and talking. And who knows, maybe some of those boards we won't separate. We can just leave them complete, and there'll be some kind of application.
Yeah, for those kinds of apps, what you do is just download this. You could download the same program to everybody, every single chip in parallel, and then have them differentiate their functions at runtime.
Right.
The overall program is probably not going to be that random and different that you needed to load a different one on every chip.
Yeah, and Brian's verified that all that works. The pin A and pin B encoding kind of stuff with the prop check that you do for addressing things, that works okay. Yeah. So some breakout examples. This one here, this breakout in the photo is a P1 DIP 40 breakout. So the flip module, for instance, is around 0.7 of an inch wide. And this module, although the one in the photo is 0.8, the final one will be 0.7. And so that sits nicely on top. One thing we do is we keep component free around, like on the underneath the board. We're component free along where the P1 pins are. So that enables us to do the breakout. In fact, I might just skip forward a slide and we'll come back. So this is like a sort of an elevation drawing from the end of the P2, showing how the pins and the screws work. The red, starting in the middle, I guess, the red box there is the high density mating connector, which is quite tiny. You can see it compared to the 0.1 inch pins. So that's the breakout connector. You've got your cyan coloured screws, and the breakout board is coloured green. The P2O board up the top there is coloured blue, and there's a sort of a brown. It's kind of hard to see, but there's a brown ground plane underneath the P2 die, which is your exposed pad, and that kind of shows just where the white coloured threaded spaces are relative to the P2 chip and its ground plane, exposed pad, I should say. So that's the kind of the secret sauce to what we're doing. But we keep those edges like above the gold pins, free of components, out at least as far as that tiny white box. That's kind of in the way. So that enables us to match those 0.6 inch spacings, which are relevant for the P. If we want to break out to a P1 size board. But we can also break out to a, like a basic stamp. This thing would be smaller than a basic stamp footprint. But importantly, also things like the Adafruit feather, which are 0.9 of an inch wide and need us to, we need to run or fan out some connections in order to work with the Adafruit feather and SparkFun Thing Plus kind of footprints. Those and also the Itsy Bitsy from Adafruit, those products are all around that 0.6 inch pitch, so you can use it with a standard socket. So this enables us to break out to any of those kind of common formats, including things like the Arduino Pro Minis and things like that. Some of the WeMOS products, and if you're narrower, then you can always kind of form your structure of your pins going out. And so it was really important to us to get this down to 0.7 of an inch, so we could tackle that same size. And you can just use standard 0.6 inch sockets then, and as Chip and Ken would know well, that buys you a lot of flexibility with where you go from there. So
interesting way to get the chip to fit on a 0.6 inch module.
Yeah. So yeah, it's from our application point of view, we just want the narrowest possible thing so we can have the highest linear density that we can get. We're not so worried about the 1 inch direction. So any questions about that, about the breakout sizes and how we do it?
That blue, the blue is the circuit board, right?
Yeah, the dark blue is the plug-in OEM circuit board. And
so it's only like 62 mils thick or 63. So it really has an aspect ratio of like 7:1 or something, huh?
Yeah. Yeah, about
no, it'd be
10 to 1.
A little more than 10:1.
Yeah, so the wires running through that, they run all the way through that whole stack. Yeah, these samples, like we initially made these are thinner, these circuit boards that we got made, but then we realized, like JMG was pointing out, the screw, you need to mate up with what screws you can get, and the screws. So we actually needed to make it thicker again. To keep in check with the standard lengths of screws. Otherwise, you do end up with an issue where you'd have to have a washer, and you'd be in trouble if you didn't have the washer. So.
Well, that's really nice because you could swap out a board if you blew out the chip or something.
Yeah, there's that, and also because the flash chip is on there, you can also send out, like if you've got a customer, some of our customers are in remote places in the world, and if you can just send out a module which has both got the chip and the program, like an updated program in there, you know, it's needs there'll be a little bit of work to unscrew it and get the thing out, but that's something you can ask a lot of, you know, vaguely technical people to do. Whereas getting a laptop to program with Propeller tool in the field, you know, is more of a challenge. So, you know, we can just post out these modules. They're compact enough to fit through a standard postage envelope, and yeah, that might actually happen. I wouldn't be surprised if we do that more than once.
So Lachlan, I think I missed way back on slide, let's see here, 5. Programming interface, that's not really the intent, is to have a programming interface. It's a very low cost module that you can put in equipment, right?
Yeah, that's right. There's no, when you say programming interface, there's a prop plug header. So you can just use a standard prop plug in there. If you look at what's in that purple rectangle, there's 7 pins sort of there, and the bigger pins are the ones for the prop plug, and the ones in between are actually like the SPI flash or a micro SD kind of breakout kind of pins if you need those. So you can just attach a prop plug on like this header here. So there are 7.1 inch pins along the top, and the prop plug just goes on, you know, the last 4. You've got power in on the other end, and then got just one user pin in the middle between the 2 sides. So you can use a prop plug, or you can also program the thing via the 60-pin connector, you know, and break out to some kind of thing. So it's kind of a, you know, these things are just a bus. You can connect on either way.
This could be the absolute lowest cost way of getting somebody started with the P2.
Well, it may not be the lowest cost because we've got standoffs, we've got high density connectors, but it's certainly flexible. And if you look at the total value of, once you get out to the breakout board side of it and you provide them as something which is a bit more future proof, I think it's a good value package, but it's not necessarily, it's not going to be the lowest cost way of doing this. You know, the standoffs cost about the same as the 60-pin connector. So, you know, they're a kind of a luxury item. But look, we could do a version of this which is more economical, which omits the standoffs and omits the 3.3 volt regulator, maybe. You know, and you could have a kind of a slightly cheaper version, but I'm not sure that it's going to be the.
Well, I like where you're going. I don't think meeting the lowest cost audience is our goal here, because you want to provide capability and features, and you're serving these industrial uses very well here.
The P2 can't really compete in that same crazy world at this point anyway.
Not if we want to exist.
When components start getting short, it might change, but the current climate and all that kind of thing, you know, everyone wants the lowest cost on every part. But if you look at the overall cost and, you know, what the P2 brings on board, you've got that as a starting point, and you've got to pay for that as a starting point. So, you know, I don't think that's a big problem, but it does mean you've got to, I was talking to Roger about this, you know, just how do you provide enough value where this thing starts looking attractive? And really the only way to do it is to add, you know, a variety of breakout boards, which are dirt cheap to make, you know, and that way you at least capture a value proposition for the end users. So, you know, we've got probably half a dozen or so breakout boards that we're working on at the moment in different forms. There's a connection, I won't, you know, go into detail on this, but that's a photocopy of our circuit boards we're currently working with. And so they're all running through kind of in development in parallel. And, you know, the more interesting ones, I guess, for the P2 is, you know, breaking it out to a P1 or a stamp or an Adafruit Feather kind of footprint. But obviously it's easy to do like an Arduino or Arduino Mega footprint as well. You've got plenty of space, and Raspberry Pi kind of things. All these ones become quite straightforward to do, these little breakouts, and we'll just sort of package up what makes sense. Maybe you sell it in a pack with 3, you know, choose any 3 kind of idea or something like that. Yeah,
And you're going to get
it's-
us to the click boards and to an adapter for the accessories on the 2x header.
Yep. Yep. We're going to. Yep. So maybe we could talk about this one next week or sometime soon. I've shown Ken this, but this is a click breakout board with 6 click sockets, and currently this takes our previous, like our dual in line, like 80 pin kind of module, which plugs in above where 3 and 4 are here. But we'll make it so that you'll be able to put this module. We just have the 60 pin connector on there, so you can put that on there and break out as well, and then still have 3 and 4 above the module. So
thanks for showing that. I obviously had the advantage of seeing this yesterday.
Yeah, it's that's in progress. The click module is super important. They're up to 1,000 different modules now. So, and what I hope is that the P2 can offer some unique features with the click modules. We can talk about it maybe next week, but yeah, I think breaking out to click, breaking out to Arduino for those people who are in the Arduino world still, and breaking out to Raspberry Pi sort of form factors. That's kind of the area that needs to happen at the moment, and this provides a really fast way to get there. I'm sure you can do cheaper dedicated boards, but this will be the flexible way to do it.
And for schedule, people want to know about schedule. Will we see these by end of summer?
We're working on an online store behind the scenes. I found recently the government will pay you to do an online store if you do it before June 30th, and so we're putting that together, and we'll put it online sometime in July. Won't be the start of July, might be the middle or late July when that goes live. If anyone's interested in this and wants to get in the queue, because we don't actually know what the demand will be, just put a note in chat and reserve your name, just so that we'll come back and check in and see what you might be interested in. There's no obligation at this stage, but if you're interested, just put your name in the chat window so we can hold your place in the queue, because obviously this is a world exclusive that we're doing here, and we'd hate you to miss out if the first batch sell out or whatever. So yeah.
Lachlan?
Yes, Enrique.
Another question. The diameter of the vias that transfer the pinout of the propeller from one side of the board to the other side. How many millimeters or decimals of millimeters diameter the vias are? The stub.
Yeah, the core of them is 10 mil, so 0.25 of a millimeter.
Fantastic. The nearest to 0.3 decimals of a millimeter, it's better to transfer high frequency signals from one face of the board to the other. So the nearer it can to 0.3 is better. Okay. Okay. Thank you.
Yeah, we didn't have a lot of choice, with what size vias. It really just, we just had to go with the smallest everything on this. And it wasn't really how we set out, but it just became apparent that was the only way to make all this work. So. I think we got some more slides at the end. Where are we up to? So we haven't thought of names for this. We're just calling it P2O because it seems to a sort of working name. But one thing we've got to work out is what to call the breakouts, because at the moment, the only P2 breakout that I know of is really called the Johnny Mac, and it's a bit long, or it's a bit tied to Johnny's Johnny Mac's ecosystem. But obviously we need to sort of work out some kind of name if we can for these breakouts, and thought we'd open this up, put it on the forum, and solicit some suggestions about what we should call the breakouts, which might kind of catch on. So there's a few suggestions which have been throwing around internally here, which I put up there. Obviously Ray's doing his blades already with the P2 blade board which he's produced, the round blade 2, I think it is. So,
well, let's see
anyone
if
have
we
any-
can get that figured out for you. And we'll definitely sweeten the deal with a free BME 680 environmental sensor for somebody that gives us a winning name over the next
and
couple
obviously
days.
some OEM breakouts and some OEM modules and breakouts. So
We know how these
yeah,
names stick.
that's it. We need to know what's gonna run for a while. We just don't mind what it's called. So happy to throw that out or hand it over to you, Ken, and you can come back to us with a result if you like. Or
Sure, I'll take it to the forums and get some interest here.
yeah. So that's it on this presentation.
Maybe some kind of, I was just thinking, Lachlan, maybe some departure from all these things that are indicate some kind of peace. Maybe that's where the break needs to be made.
Is it not part of a propeller?
I don't know.
Yeah, it doesn't need to be aeronautical necessarily. It seems we shouldn't, as I think Ken mentioned previously, it's a fertile ground. Aeronautical engineering has got plenty of names for all sorts of things that we could probably borrow from, but it doesn't necessarily have to be, it can really be genuinely anything. It just the priority is more about piquing an interest, or things that make you smile tend to make you memorize it. So I tend to lean more towards something which is a bit more fun rather than something which is maybe technically correct, but it can be anything, and we don't really mind. It doesn't really worry us for our application. So
Some interesting names now in the chat.
yeah, that's a good way to do it. Put it in chat. So we're gonna, at least.
We'll draw the line at names like the Con Carne, the SX52 Con Carne.
Yeah, what was the story behind that, Ken? Ken was describing it's like a longer board.
48-pin dip module, and it had on it, let me think, an SX52, some power regulation, and a bunch of pins, and it was a big SX52 that was ready to be prototyped very easily, but we didn't know what to call it, so we called it With Meat. And really resent that decision for a long time. That was an engineer created name.
Yeah, well, I made a suggestion to Ken, and he came back with what its kind of street use is, and I don't think we'll be going there on that one. So.
This name for our emulator for PIC series once. It was called Thias. Nobody understood what that was about, but there was this Charlton Heston movie called The Omega Man. Maybe you guys saw it. It was like made in the early 70s. And he was the last guy, one of the last people on Earth, and he was in Los Angeles. And there were these people that were metamorphosing into these night creatures, and they were led by this ex-journalist named Matthias. And Matthias was like this cult leader, and he had like white eyes, and it was real weird. And he would always say, "The family is one, the family is one." And he hated science and technology and art. And we called the emulator Matthias, and it said the family is one. And then we had all the different modules you could plug in to support all the different chips. But hardly anybody even asked about what that name was. But Omega Man was a good movie.
Well, no, it seemed like a good movie at the time, but today it's viewed as a very poor movie.
No, it's still a good movie. That movie Legend was a redo of the whole thing.
Well, Lachlan, this is great. Thanks for sharing this, and come back with more.
Will do. Yep.
Yeah, it's really neat.
We're glad you're going into winter because you'll be very productive down there.
Mm-hmm. Yeah, if the power stays on, we're into winter and the thing's blowing a gale. I had to avoid a few trees on the way here, and so yeah, it's we just need to keep the power on and we'll keep productive. But, yeah, we're running these in parallel. We're doing the breakouts. You know, we're doing maybe a dozen at a time or something to try and get the things through the pipeline. So if there's any requests, if anyone's got a particular breakout they're interested in, let us know as well, because it's pretty straightforward to, you know, to add it into the mix.
Good stuff. Well,
You know,
Chip.
Ken, if our die is about 9 millimeters by 9 millimeters.
mhm.
Package.
back,
I know
Chip.
you hated QFNs in the Prop 1. What?
Oh,
Can you hear
No.
me?
yes.
Oh. Okay. We could put our die into a much smaller QFN package with the heat pad on the bottom, and it would handily fit into smaller things. But the trouble is we'd have to get on semi to go along with it. And to them, it would be like a whole nother part that would have to re-go through all these qualifications. And
Yeah, I kind of think what
Yeah.
Lachlan has is the P2 Edge before it became a little bit bigger and feature rich. This is the miniest module. Well, should we move on? Floating point, P2 cube. Any topics, tech support questions for Chip?
With Chip's connectivity problems, it's going to be hard to do that.
And I think Chip signed up for Starlink too, so he should have a little better bandwidth. See if he comes back. He's in a very rural location.
Yeah, he's now switching to a cell phone.
We need to get Chip his own satellite dish.
Well, while Chip returns, anyone else want to share anything they're working on? Stephen, not to overshare what you're working on, but you showed me something kind of interesting earlier today.
Yeah, not ready for prime time though.
Okay, looking forward to it.
Yeah. The subject was how do you do repeatable testing with when the unit under test is a IMU.
I was thinking of the other item, the
the boards.
logic analyzer. Yeah.
Yeah. I just did a PCB layout. I don't have the information on this machine, so I can't show it. But the boards are arriving today. It's basically a little bit wider click module adapter. And the reason for being a lot wider is that it has headers outboard of the click module, so we can just instrument the click modules while we're developing the drivers with logic analysis and stuff. So it helps Johnny Mac and myself. Just something simpler there. If
Well,
that
I'll
makes
share.
sense.
I'll share one of the things I'm working on, which John Titus influenced. Haven't made much progress yet, but he's here today. So he pointed me to this article that he wrote because I'm very interested in seeing the first P2 IoT type project. Actually, I think Stephen has some, but one that could be shared and published. And this looks like a simple effort that I could copy and port to the P2 using MQTT. And in fact, as I looked at it, it even uses an object that we already have for the P2 with this humidity and temperature sensor. So I'm working on that this summer, and I'll paste a link in here if anyone else wants to get involved. So I'll put that in the chat. And you can use these ESP8266 modules, which are so cheap. I felt guilty pressing the order button because you get 5 of them for $12. Look like that. So I know all of you are very familiar with this and have probably used it, but I haven't actually done anything useful with IoT myself, and I don't have a lot of time to do this kind of thing. So I'm trying to pick just a simple project where I could learn a little bit more. So thanks, John, for sharing that idea.
Happy to do it. Glad to do it.
Ken, I pasted a link to you privately also about that.
Oh, okay. And Chip, have you returned?
Yeah,
Oh, okay.
my internet's really poor here. We're
Are you
waiting for
using
this.
Starlink?
No, not yet.
How's the progress on the floating point going?
Good, good. I can show you what I've got. Hopefully my connection holds up. Let's see here. Let me see if I can share the screen. All right. There's a part of the screen. And let me grab this other thing here. So there, you see this here. These are some things I'm adding right now into the interpreter. Because we don't have types, we just have 32-bit values. Floating point operations will have little periods after that. This will allow, as you construct your expressions. And so I have here just some basic things: add, subtract, multiply, divide, and then force greater than equal, force less than equal. And then these comparisons. Turns out we don't need special ones for equal and not equal, because you're just comparing two packed, floating point values. They're either equal or not equal. So you don't need a special floating point operator to handle that. You just do the same thing you do in integer. And then here's the one that says, return negative.
Chip?
And we lost him.
I think we lost him again.
Sunspots.
Sorry about that. This is really poor here because of the internet. Let me see if I can share my screen again. All right, now. There, can you guys see that?
Yep.
For a few seconds?
You were
Okay,
showing
so-
the operators before too. That's when we lost you.
Okay, all right. Well, anyway, I had some realizations about you don't always need to go through the longhand packing and unpacking of floating point, because there's some funny things about the floating point value. You see, this is a 32-bit value, right? But that should be a percent, right? So you have the sign bit up on top, and then you have 8 exponent bits, and then you have 23 mantissa bits, which have an implied leading 1 that doesn't need to be expressed, except when the exponent is 0, then you might actually have, then what happens is the full mantissa is expressed here. There is no implied leading 1, because you might have all zeros and then a 1 right here at the end. Anyway, what's cool about this is it's monotonic. This makes it a little odd, right? But in the case of a positive number, say the sign is 0, so it's positive. Any incrementing value amid all this creates an incrementing number. Now, when the number is negative and this is 1, if you were to turn that 1 to 0 and then actually, yeah, just go like this, turn this to 0, and then negate the entire thing, now you're back to monotonicity, but you're in like 2's complement, you know, a negative signed number. So if you can use like compare signed operators like that guy, you can actually do magnitude comparisons on floating points without having to pack and unpack them. Does that make sense? So it saves a heck of a lot of time because when you multiply, divide, add, subtract, or do any real math, you have to break it all apart. And ironically, you know, adds and subtracts are more complicated than multiplies and divides because you're no longer just adding and subtracting exponents, but you're having to position the relative bit fields before you can perform the operation. Anyway, so these two instructions here, what that'll do is it'll clear the top bit of the floating point number, and then remember in carry whether it was 0 or 1. So before negation or for a positive, you always want that's going to be 0. But what this does is it clears it to 0, clears the sign bit to 0, remembers what it was in the C flag, and then I don't know why I don't need that Z there, I think. But anyway, those two operations will turn any floating point number into a giant integer that you can do magnitude comparisons on. So I do that to both terms. First the W, then the X, and then here I just based on what our opcode is, right? Bit 0 will have that. I either do a compare S, either W comma X or X comma W, and then that gives me something in C, and then I XOR C with what the other bit of the operation code is, and then I just I mux it in here to get a true or false. That's going to be all 0. It's going to be true or false. Whereas this one here, this is the this operation here has to return -1 floating point 0 or +1 floating point. So it's able to do that with the compare, which checks for 0 as well. And then here is the 0 case, in which case they're equal. If it's not Z, it then moves, this is floating point 1, and then it finally like sets the sign bit if it was less than. So that returns -1, 0, or 1 floating point based on whether you are above, equal, or below in your comparison. So this little bit of code here handles all these float relational operations. It wasn't, I was thinking it was going to be something really big and bad and slow, but it turned out to be pretty small and fast. Then here I have the pack and unpack routines. So that when you start, before you can do a floating point operation, you have to break apart the sign, the exponent, and the mantissa. And you have to get those things all justified. We bit justify them to bit 29. And then when you return from the unpack, bit 29 is always set. Then the exponent holds what you're, where you are on the floating point. And so the top bit of the mantissa is always kind of 1 justified. Anyway, this is the unpack, and then here's the pack. The pack was a little more complicated, but I got it kind of small. This down here is the pack. So when you want to do like an add or a multiply, you got to unpack your floats, then you do the operation, then you repack the result. And here's one that just unpacks 2 of them in a row, because for A plus B, you've got to do it twice. Now here's like the division routine right here. It unpacks 2 of them. It XORs the signs because the the quotient is going to have the XORed sign of the numerator and denominator. So it does. So here it XORs the signs. Here it subtracts the exponents. And then here I do this to make sure that MA is less than MB, so that down here I can use the frac instruction in the Cordic, and that will give me a huge fraction. And then in the end, I do this to re-justify it to bit 29. And then I call the pack routine to repack it. So that's how you do a floating point divide. And then a multiply is a little bit simpler. Again, you unpack 2, then you XOR the signs. But now instead of subtract exponents, you just add them. And then you do the multiply. And then you return the high long of the result. And then shift it back down. Now, why did I do shift it? Why did I shift it? Oh, because, why did I shift it by 3? 31, 30, 29. I don't know why I justified it down that way. Seems like off the top of my head, that should be 2. But I think I worked it all out, and that's how it's supposed to be. Then here's the add and subtract. It's more complicated because you've got to optionally negate the mantisses. Then you figure out who has the higher exponent, shift the smaller guy down. Then you finally wind up doing the add, and then you make the absolute result, and then you set the sign. And then you repack it. And then here's a square root, and then stuff to go between integers. You know, you got to be able to take an integer, convert it to a float. That's what this thing does here. Kind of builds the sign, the exponent, and the mantissa, and then packs it, and that's done. And then here it rounds or doesn't round based on what the low bit of the opcode is. If it's C, then it will go ahead and increment, which will cause it to round. And then it comes out of here. Now let's see, why is it not? Oh, because it's returning an integer. There's no reason to pack at the end. So anyway, all this stuff adds up to about, I think, 180 bytes. Or no, 180 hex bytes. That's like 372 bytes of code. It'll grow the interpreter by about maybe 10% or so, but it will provide floating point. And then we can augment this later and put in stuff like transcendentals and powers and logs and exponents and these kinds of things.
I have 2 questions, Chip.
Yeah.
What's it going to look like from the spin 2 side, or is that already apparent to everybody from looking at the assembly?
Well, what I was going over before is this stuff here, right? So let me make this a little smaller. So what you would do from the spin 2 side, if you had a variable, let's say you have A, comma, B, comma, C, and these are floats. In a routine, you know, here's some routine, and then inside that routine, you could say A, if you wanted to add those 2 things together, or wait, let's do this. Let's make, well, let's not do that because that gets us back to looking like what we used to look like. But let's say in here you wanted to add A and B. You'd say A colon equals B plus dot C, right? And that would put B and C floating point into A. And then you could, you know, do more of these things. But see, now what you have is you have order of operation, right? Where this multiply is going to be done before this add. So you get to be able to write normal looking expressions. And then of course you can put, you know, parentheses in if you want this done first. So it allows you to write sensible looking floating point expressions. And the key is this little dot here. That means that because we don't know type, right? So we have to make the operator different. So as it operates on these 32-bit values, the dot indicates that we're doing a floating point operation.
Thanks.
Chip,
What's that?
sorry, while you're there, what would initialization of, say, A to a floating point value look like?
Oh, okay. You just say, well, you could just say like this, you know?
Nice. Okay. And so you're,
Yeah. That'll the compiler actually already does that.
but it's going to result in A containing the new float binary format.
Right. But if you wanted to say A is, let's say it's some variable, you would say float X, right? If X is an integer and you wanted to convert that integer, you'd have to do this.
Nice. Nice. And this is where float comes out of the constant field now and arrives in the
Yeah.
source.
Yeah, I
Okay.
mean, this could be like an integer variable or a symbol or something that, is some value, some integer value.
Does
Now-
that mean you also are providing an int operator as well, so we can get back out of it?
Yeah, we have, if you want to say like int, like let's say you have I as an integer, you could say like round A.
Okay, so you're going to use round and trunk to return back to an
Right.
integer domain.
Right.
Okay.
Yeah, trunk is the other one. Trunk simply doesn't round up. It just truncates the stuff.
Right, removes the remainder. And round is the traditional round. We don't have any control of.
They're in the compiler right now, but they're only compile time operators. They're going to become also live operators.
Runtime operators, right?
Yeah.
A round, we don't have control over precision. It's just 0.5.
Yeah. It rounds up or down to the next. Well, it possibly rounds up to the next integer if what was right at the decimal point is greater than 0.5.
Yes, good. Okay.
Or equal.
Okay.
Chip, will you be able to use the float function within an equation, or do you have to convert it first?
No, you can do all at runtime. You can convert between,
Okay.
floats and rounds, or floats and integers. So these are the three operators that will do that kind of thing. But if you just specify something like this, the compiler knows that obviously that's a floating point value, so it will generate a floating
Right.
point.
Right.
Hey Chip, why can't, since the compiler knows that 1.0, for instance, is a floating point value, why do you need the new operators?
For runtime stuff. So if you have a variable that you want to convert to a float, it's not known at compile time, right?
Okay.
To state that another way, if
That
you look
makes
at A and I, they have different formats internally, binary formats. And now you can't mix those two when you use operators on them, right? And so the new operators
Well,
require you to
you
think
could
through
do
that you have to have
you could do stuff like
float.
you could do things like this or this. You just better make sure there's agreement on the terms. Like if I is an integer, you'd want to say float, right? So you could do this, or you could do like right. So here is this is going to generate a floating point result, and this generates an integer result.
Yeah, the question was, why do you need the float operators? I mean, I understand. I was just echoing the question.
because the variables are not typed.
So internally, it's just 32 bits. And,
Just 32 bits, but I don't know what it means.
okay. So you can get away with stuff that you can't do in heavily typed systems.
Yes. Yeah, the bane of Delphi is just typecasts. There's so many typecasts needed to move between things. It's like every time I think of it, I just cringe. I got to slow down to granny gear and figure out which typecast I need. Whereas this is like, look, it's 32 bits, and that's the normal data size unless you're dealing with a byte or a word or a bit field. And so what we're doing here, instead of having separate types, we have separate operators, like the star dot instead of just star for multiply.
And that does bring up an interesting, if I have a variable typed as word and I start doing float operations against it, can you recognize that as a failure?
No, we don't know.
Yep. So we're going to have to be very careful with that.
Yeah, I mean, you kind of have to. They're like dogs and cats, you know, and you got to know if you're dealing with a dog or a cat.
So if we're thinking in the float realm, we got to make sure all our variables stay longs.
Yes, yeah, you can't use a byte. If you try to use a byte to store a float, you're going to wind up with a very small number because it'll be a positive number with an exponent of 0, and it'll just be basically the real tiny number. So it won't work. Yeah, you got to have 32 bits if you're using these floats. Now I could trap for that, but that's like just addressing one small aspect of the problem for a lot of coding. I mean, for a lot of coding effort on my part, it doesn't really address the real type problem. It's just the identifiable cases. Like if they're using a byte in a float expression, that's an obvious thing. And I might put that in there. But I mean, the much higher risk is that people aren't thinking about what's what, and they just start jumbling up, you know, floats and integers and integer operators with float operators. And so you have to keep those things, you have to keep them straight in your head. You have to remember what's what. And you could come up with some kind of like casing convention or start variables with a lowercase f that are floats, you know, to remind you there's other ways to deal with it.
Yeah, that's probably an excellent idea. That's something I've done in the past quite routinely.
Yeah.
Yeah, just put, like we use, some of us will use P's for pointers. We can use S for floats, and life will stay real sane that way, or B's for bools. Yeah, we do all sorts of things like that.
Yes. Yeah. That's probably a good practice, I think.
We'd like a lot of examples, Chip.
Mm-hmm.
And Chip, will we be able to claim IEEE 754 compatibility?
Yeah,
fully?
that's what this uses. I mean, IEEE 754 is let's see, it is this, you know, where this is the sign. Whoops. That's IEEE 754 right there. Sine, exponent, mantissa.
fraction.
Yep.
You sure shortened that Wikipedia article for me then.
Oh,
Thank you.
on IEEE,
Yeah.
Yeah, it's funny that when this gets to be 0, that means you have a very small number. Then there is, and that's a special case, there is no leading one that gets attached to the mantissa. So the mantissa is in totality whatever these bits are. There is no one that gets appended to it, to the front of it. It's just straight that.
Chip, John was asking, could you use a general rule that if a calculation uses a float, the answer always yields a float?
Well, if we know what a float is, I mean, if we like look at, you have to use, I mean, how would we know here? Okay, I see. So if we have this, then we can assume that everything else is float and enforce that. Then we wouldn't even really need the period. But it's then the rules start to get very complicated because they become really contextual. What we have now is just simple. It's like if you want a float multiply, you use that. You know, or a float divide would be this. And you just use the appropriate operators. Or this could be like plus. I kind of wish this isn't really very verbose, but it's too bad that we don't have like some extra dimension beyond the 7-bit ASCII where we could express in some other mode, like maybe color or shape, what kind of a plus that is. And then it would be more visual. But for just, you know, textual programming, This isn't bad, but you are going to have little periods after your float operations.
Chip, one of the things you could do in the documentation is as you're working through this, you're identifying cases in your mind that will be problematic. So actually taking notes and then citing that in the manual as you're showing examples, please do. That will really help us.
Yeah. Yeah, I will, yeah, I'll expand the documentation to cover this with a section that talks about, how you're going to need to intermingle things.
I would just start establishing a naming convention and just be absolutely consistent in all your examples and documentation. So either use a first letter or a final letter or something like that to indicate that you're in integer or float realm.
Yeah, yeah, that could help. I mean, it could be like, yeah, that looks kind of ugly. And that looks strange.
It's going to look
Okay,
ugly. Single.
is that more ugly or adding types to your language?
Say that again, David.
I said what you really should do is declare your variables as either floats or integers, and so your compiler and runtime can do the right thing. And you got to tell me whether that's more ugly or enforcing a discipline.
Well, here's the trouble with that. I mean, we can do that for variables, but then when they start like indirectly pointing to things, then it becomes complicated. Then we get into the typecast zone where we start having to have typecasts to give types to what were ambiguous things, like, longs that were pointed to by, unless I just said long, instead of like long, if there was some other thing, some four-letter thing like FLOT, they would be kind of like a long, but with a type of float, then that could do it. But then it's a funny thing. It's one of these things I've worked through a few times, and it always seems like I begin on this course and then I get so far and then I realize, oh, this was the problem with doing that. There are these deeper things. So by keeping it just kind of shallow, like, plus dot, it actually simplifies things. And then, well, I don't know, I'm just my opinion at this moment, but I know that when I'm programming in Delphi and you can say plus or minus or multiply, divide, and you're using floats, integers in different contexts, I have to slow, okay, I don't want the compiler to trick me because now it's become ambiguous and it's like type centric, not operator centric. So I have to slow down. So it's a bit of brain work to have. I mean, it sounds like it would be simple. And if you're teaching someone something that was either all integer or all float or a minus, then it starts to get it's very contextual, and you have to slow down and think about it real carefully. I always have to do that in my code. I mean, when I get into a thing where I've got some floats and some integers, I have to like really scrutinize it. Whereas if I had like a naming convention that would say F for floats, and then I had special float operators, like say that, then it would actually be coming into something without having like current familiarity with it. It's easier to figure out what's going on because there's no mystery, or there's nothing veiled that you have to determine before you can think about it. It is, I mean, it says what it is the first time you look at it.
I have a nice idea, Tim.
So there might be.
I have a nice idea. You allow the dot in names and symbols. So the float variable would be Z dot or period. Like plus period, you have Z period as name.
Yeah.
So if the name, the symbol name,
I wonder if that,
dot, then it's a float.
if it could be parsed, that could work. But there's some things that you couldn't say, like we're doing plus dot, you couldn't say dot plus, for example, because if you had a constant and then a dot plus, it might think that you're expressing a floating point value that was incomplete because it expected another digit and it hit a plus. Whatever we do has to be parsable.
I see. You don't.
It has to be parsable.
Yeah. Okay.
Just prefix with F underscore.
Should
Oh,
be.
F underscore. Yeah. Now that would be like, so X. Yeah. Float. Now that really differentiates it. So you're never going to see F as like some phonetic start to some variable name.
I think the issue for you, Chip, is that I never use single character variable names. And so a lowercase f and camel case always works for me. F underscore is just additional space in that case, right? And so camel case with a leading F or F underscore, I guess both work, but I would stick with just a single letter. But then I also don't use single letter variable names.
You don't use single letter variable names, you're saying?
Never do. They're not descriptive enough, right?
Right.
And so
Yes.
it looks more normal with words to have a lowercase f in front of it with just an uppercase first letter. But with single letter variable names, it looks really odd. I agree with you.
Yeah. Yeah. Now, what could we call, what come up with a variable name? I mean, this is one of the hardest things in programming is coming up with names, right?
I don't know. I always think of, what does the variable contain? Is it height? So F with height, right?
Yeah,
It looks
that's
just
pretty
normal.
obvious.
Yeah. And so that's why I say single camel case with single letter prefixes for pointer or float works very easily. I even do that for bool, but bool's not necessary. But it reminds me that I'm going to have zeros or Fs in the value, right?
Yes. There's for Michael.
Yeah, that's good. And so, yeah. So what we're suggesting here is in the examples in your documentation, then just stay true with the F and the to remind us that that's what you're doing.
Yes.
And that way you're forming the pattern for us as new learners. We'll continue the pattern we're seeing.
Yeah. Yeah, that's probably a necessary way. But you know what? It would be nice to come up upon code you haven't looked at in a while and see stuff like this, which looks a little odd at first, but it tells you what's going on, And so you don't have to wonder like,
Agreed.
well, wait a minute, what kind of types are these? And, go back, and it just kind of in a way keeps things simple because you don't have to keep referencing yet other stuff to know what's happening. It's just right there.
Yep. Yeah, one of the things you're reacting to is the typecasting. Over the years, we use the single letter prefixes to help us understand what the storage format was behind that variable name. And therefore, we could always eyeball through the single letter prefixes of our variable names whether or not we needed to typecast and whether the compiler was going to, because the letters were different between our variables. And so we always use that in our mind's eye, always for keeping our code sane. And
Yeah.
I'm speaking for million line code bases like our logic analyzer software. We did that there so that all of us were using the same convention and all of us were controlling of how much extra code the compilers generated and things like that.
Yep. Yeah, that's certainly good practice.
And so I'd be a fan of you using F here and camel case variable names, and that'd be just great.
Yeah.
You just have to provide a purpose to your example, right?
Right.
We used height because our purpose might have been we were measuring distances or sizes or something like this. And so you have to go a little bit further in the examples to put yourself in a context where names would make sense.
Yep.
What's your timing on this, Chip, for early adopters
Oh,
with
I
Peanut?
hope to have this thing done by maybe over the weekend or so.
Another note, Chip, you were questioning whether that should be in that code you were showing. You were questioning whether you should have a 3 or a 2. You said you tested it, so you think it was correct. Those two routines side by side, one did have a 3 and one did have a 2. So you might want to just re-verify everything.
Yeah, I can't remember that was in the multiply here.
I think
And
so.
what does this mean for flex spin? Will Eric have any challenges here?
Okay, wait, I know what it is now.
Good.
It's here's the thing. When you multiply two 29-bit numbers, you get a 58-bit product, right?
Yes.
And we have 64 bits. And we're taking the top 32. So 58 minus 64, or no, 64 minus 58 is 6. And so I think it's half of 6.
So then your divide down below is using a 2.
Yeah,
If I
because
remember
it comes out, it's a quotient that's bit 31 justified. We need to knock it back to bit 29. Once I get it running, I'll suss all that stuff out and make sure it's right.
Nice, nice.
You know,
Yeah.
the thing about, oh, go ahead.
Nope, go ahead.
The thing about floating point is before you can really like get a feel for it and use it, you have to have things that can go between, you have to be able to simply print the floating point number. And it takes a lot of code to print a floating point number.
Curious.
I mean, if you look at my, let me see if I can pull up this thing here.
I was going to say, have you modified Johnny Mac's string parser to do that then?
No, I'll have to look at it, but I know in the compiler here, let's see, where are they?
Wouldn't take long to add a formatter for it.
No, but see, I think I have to have a lot of, unless I compute these, you know, during the number printing, you have to have these bases set up, which are all decimal, right?
Jeez, yeah.
And I don't know. I don't remember how this works. I got to get back into it. But printing decimal numbers is not trivial. I mean, excuse me, printing decimal from floating point is not trivial. And then there's a lot of preferential stuff in there. Like, do you show it always in scientific notation, or do you have some rules that it's fixed point, you know, or you resort to scientific notation at some point?
Over certain widths or something. Yeah.
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 It's a complicated thing.
There are
question from YouTube viewers. All this packing and unpacking, does it slow things down using floating point?
It's slower than integer, because with integers you just do an add if you want to have two numbers added. But with floating point, yeah, you have to unpack them, you have to justify them, then you have to add them and then repack them. And you need to round them too. After the add, you round and then you repack.
So resource-wise, it's running in the main cog.
Yes.
And clock cycles are added.
Oh yeah, yeah. I mean, it's probably like, well, instead of one instruction to do an add, you're talking maybe, you know, maybe 50 instructions to do the pack, the add, or excuse me, the unpack, the add, and then the repack.
And so it's a lot. Compare that to integer math.
One instruction, 2 clocks.
Ooh.
So it's like 100 times slower. Well, 50 times slower maybe. But you want to use it conservatively. You don't want to make everything floats. You only want to use floats in a few places where you really need the flexibility. You know, otherwise integer math is what you're going to want to use.
Don't you also have to deal with floating point errors, like the 0.00000001 showing up?
Yeah, no, I mean, a proper floating point, well, a floating point implementation that tracks errors. Here's our trouble. What do we do in an embedded system if they have a, you know, some kind of overflow? What we do, if we get an overflow, we simply return 0. The option would be to saturate, right, and just hold a really huge number. But there's nobody to give an error to in an embedded system. So you really have to design it so that it won't do those things, and that's not hard to do. You just have to make the effort.
Chip, there's a traditional constant that is being mentioned in chat by David Butler right now. Not a number is a constant
NAN.
value that you return.
Yeah, an NAN could be like the sign bit set with everything else 0. It's like
Yeah.
a -0. I think that's like the one oddball.
No,
case.
IEEE has a specific definition. So IEEE is not just the format of the 32 bits. It is rounding and your errors and your not a numbers and exceptions, a whole bunch of stuff.
Right. Right, like divide by 0.
And they also show you what happens if one of the floats contains the not a number value, how the operator should work. And so there's actually, in the wiki pages, there's definitions for that. So being able to test for not a number is probably the way we would at runtime want to check. David, does that make sense?
I think it's interesting. I was actually just looking at the Elevate controller code, and there's this beautiful streaming floating point piece that's in the P1 Elevate. And then, of course, we have the beautiful floating point, the F32 math for the P1. I'm surprised you just can't use pieces of that because it's very concise and actually seems to be very well done.
That was in the C compiler too.
No, it's not C compiler. It's all in PASM.
Oh.
Yeah, the float
Jason Dory's
32A
code.
object that's already in our, just go look in your standard code. It's very complete, very concise, very well done.
All right, so this is, yeah.
It looks like the floating point NAN is the exponent. Is that right? It's a sign bit and the exponent all set to 1s? Or just the exponent?
Well, it would have to be the exponent. Well, I think a -0, which would be the sign bit set, and then everything else 0, which means you have the 0 number. So a -0 would be a NAN. But I don't know, there might be another way or two to make them, but that's the only one that occurs to me.
I just put a link in the chat that identifies it.
Okay, let's see. Wiki NAN, okay. Let's see.
And so rather than trying to indicate that you have an error, you just return that value.
Oh, okay. Yeah, we could certainly do that. What is NAN? Let's see, signaling NAN. So let's see, using some placeholder.
Chip, not to interrupt your thinking, but another question. Is it using the same implementation as used in the P1 compiler? I think the comment was asking about
when
the
you say,
lowest. It's asked
you
in the
mean
context
the
of
P1
the
floating
lowest
point math object.
Yeah.
Well, I kind of wrote this code from what was called float math. dot spin. That was my reference.
Yeah, the float math object is spin. The float 32A object is PASM. It actually launches a separate
Okay.
cog and has all the float operations, and then it actually will launch a second cog and have the arc tangent and arc cosine and all that stuff, and it's all in PASM.
This is
It's
probably
all in
what
assembler.
Cam Thompson wrote that, right?
And it actually is quite good.
I'll have to look at that. Does
And
anyone
if
have
you
a
want
link
to,
to
and
that?
if you want to see something really interestingly performant, is look at the way they used it in the Elevate in your drone. Because what they do is they adapted that PASM code into a stream calculator, and it actually streams the requests and the answers out through a cog very, very innovatively.
Okay. So they kind of made like a floating point processor that you could hand.
That's exactly what that code does. It actually takes a cog and makes it a floating point coprocessor.
And where are you seeing that code, the Elevate code?
Here, I'll get you a link.
Is it one of the Parallax GitHub?
Yeah, I believe the Float 32 library is in the Parallax GitHub library already.
Chip, to claim IEEE 754, you really are going to have to make sure it does exactly IEEE 754.
Maybe it's IEEE 754 compatible.
Yeah. Well, there is a way to do it exactly.
Well, again, the code, the PASM code does the IEEE, and it does all the not a number stuff, everything properly. And it's already written in P1 assembler. It cannot be hard to adapt.
Right. I wonder where the float 32A spin is. Is it in our distribution for the P1 stuff?
Yeah, it was in the it used to be in the thing that was on the website there, the libraries. I think it's in, I'm pretty sure it's still in the GitHub repositories.
It's called float 32A dot spin. I see a float 32 spin. Yeah, some stuff from our site.
David, maybe you could find that for Chip.
It might be here. Here's
I'm looking, give me a second.
Oh, thanks. No rush.
I found it. If I can figure out how to send
Here,
it.
I've got it. I've got
there
it.
we go. Pulled up the PDF for it.
I think it's F32.
I think this is it. If I'm still sharing my screen, right?
Yes.
I think this is it. This is a PDF I got off of the forum. So here are all the functions that he had.
David also dropped a link in chat, Chip.
Okay.
Oh, nice. Oh, interesting source.
And
Oh,
again,
okay.
if you look at the Elevate code uses this piece in a cog, it's just, it's pretty innovative.
That developer, Jason Dory, is very innovative. And he's now writing laser cutter software that's, forget the name of it, but I'll look it up for you.
Why do I get this? It's like Chinese characters, but I think it's just not.
That's what I was wondering.
That's the
If
Unicode.
you look at your the Propeller repo, Git repo, there's a set of shell scripts that do conversion. And what this is this is what's called UTF-16. So you have to convert the UTF-16 spin file into a UTF-8 file.
Okay.
And so if you look at your GitHub repo called just the Propeller, it's the standard stuff. So not the props GCC, you have to go to the other repo, which is your standard Propeller library stuff. You'll notice at the very top of that repo is your conversion scripts. So go to Parallax Inc. up at the very top of your browser.
I just posted a link directly to the GitHub repo where it's
and
at.
then you go to go down there. It says Propeller, just right there. And see, these are your conversion. No, let's go to the Propeller one. You're in P1, F2 concise. There you go. That's another way of doing it. These have been converted. So if you click one of these, you'll be able to see it. No, it's still not converted.
Mm-hmm.
Anyway, it seems the Propeller tool likes to use the Windows convention of UTF-16.
Correct. And then GitHub doesn't display them correctly.
And almost nobody uses UTF-16 except for Windows and some
On my
Java
Mac,
stuff.
it displays fine.
So you got to convert it to UTF-8.
Okay, so, but how?
Once you bring these down to your machine to Chip.
Yeah, just check it out, Chip, from GitHub, and it'll probably convert it for you. You'll be able to read it.
Yep.
Oh, okay, all right. You know, I only use GitHub. Jeff showed me how one day. If I go here and say,
There's a tool. It's like Git Tortoise or Tortoise Git or something like that. You can use. It's a GUI interface that works pretty well.
I don't really use Git, so I'm kind of not familiar with it. I mean, I use it to back up my stuff, but I don't just grab things off the GitHub and then, you know, load them in. I only use my own files. So how would I do this? I'd say Git.
There's a lot of.
It'd be easier to just get the whole library.
And that's this. Can I say go to file? Will it give me like a zip? Or something?
If you go up to the library,
let's see.
all the way out to like.
So here I am.
So if you up there on library, see where it says Propeller Libraries, down one, down, just a little.
Right here, right.
Yeah, click that.
You're going to have to still go up one. You're looking for the
master.
Propeller. Now
Go
the
one more,
propeller-
one more. I'm sorry. Click on propeller. One more.
You'll see a green button on the top right once you get.
Yeah,
to
you'll
the
get a green button in a
notification.
second. There you go.
Right up here.
Click that, and then you can just grab a zip file of the whole thing. Click the green button.
Oh, okay. All right,
Download
I
zip.
got- I
Very
did that.
bottom.
Download zip. Okay. Whoops. Okay. All right. Here we go. So this has everything, huh?
Right. It's going to be
That'll be the whole library.
reasonably large, but it's there.
Okay. All right. Then I'll be able to go through that and look. Okay.
Yeah, your prop tool will open it just no problem without any conversion.
Let's see here.
What's the difference between float 32a.spin and float 32 full.spin?
Full includes the ability, it launches 2 cores, which includes all of the capability. Float 32A is just the 1 core subset. And
Yeah,
float
just-
math
just
is
multiply and
the
divide.
spin version, very small spin version.
Oh, wait. Let's see here. Okay, so I guess it's still downloading. It says it'll open when complete. All right, well, I'll look through that and see how he did it.
Yeah, but isn't it kind of a sign that we still need an OBEX if you can't find GitHub?
Yeah, I think the OBEX worked well. Ken, why did we get rid of it?
Oh, we can't go over all that right now. Sorry.
I
But
would
we didn't
imagine on
actually
your
get rid of
side,
it.
It was a management nightmare.
Well, yeah, it became loaded with spam and we couldn't unload it quick enough.
Yeah.
Basically, we were designing a service which exists out there already, which a lot of developers use, and it's GitHub and tools like it. So
Yeah.
it was absolutely not sustainable for us. But if you go into parallax.com and then you click on Propeller 2 Object Exchange,
Yeah.
you can access it.
Yeah.
And then between that and Quick Bytes is all most of the commonly used objects that I'm aware of.
Well, the other nice thing about it too is that somebody can clone your repo, make a change and send you a pull request, and then you can integrate it right in with just a couple of mouse clicks.
Yeah, exactly. Yeah. And the OBEX really did not allow all those features that we were being asked to design in.
Yeah.
They're just standard in GitHub.
Yep.
And basically we could have one staff do that, but then we can't have any Propeller documentation. So if you had to choose like we do, you would probably choose documentation and then use GitHub. It's painful sometimes.
I've been using Git for years.
Well, I think
There are other Git hosters out there as well that are more trustworthy than Microsoft.
yes, we do hear that once in a while, but I think for many users like Chip and even myself, especially myself, more so than Chip, it would be nice if there were a simple graphical tool that we could use overlaying on GitHub. I know there is.
There is. There's a thing, it's called Tortoise Git or Git Tortoise. On the Mac, I use something called Tower, but I've been using the command line for so long, the GUIs just tend to slow me down.
On the Mac, Xcode integrates GitHub directly. I'm sure that Visual Studio does too.
Yep. But the Tortoise Git, will give you like a right-click mouse menu from anywhere. So you can like right-click on your desktop and do a checkout from anywhere.
Yeah, as far as GitHub's concerned, if you don't have one of those add-ons, if you find yourself ended up like on the .spin file that has the Chinese characters, just above that you have a raw button, you hit that raw and it'll open up into like a text file. And then you could copy and paste that text file, rename it as spin. I mean, that's a workaround for without the those add-ons.
Yeah,
So
the challenge was the UTF-16 files, right?
Yeah.
yeah, but if you open up it as raw in GitHub, it's just basically text, which you select, copy, and then paste into Prop Tool. That's a go around, fast go around.
Chip, if you're pausing on math, I think Ray has something to show
All right.
down under. I don't know if he's ready.
Yep. Yeah, I've been working on a simple as possible computer, but emulating it in the Propeller. So basically, I've basically got the display section working, and I'm using a 4-inch LCD display. So can I get to the camera?
There it is.
Try and get this in. Oh, I'm upside down. So this is, I'll zoom up a little bit. So it's my retro board plugged into a SPI 4-inch LCD. Now, can you read? And I can't tell whether you can read the writing. I don't know whether I can go it on. Ken, can I get my camera onto full screen if I share the screen?
Yeah, I can spot it for you.
Okay.
Just a minute, and looks like everyone's seeing it right now anyway.
Right. So basically what I've done here is, yeah, that text is the right way around. Just something looks wrong. Looks like it's inverted or something.
You hold still.
It's a little blurry.
Okay, so tell us what we're looking at.
Okay, so what you're looking at, from what I can see, along the bottom row is the state machine. It looks like, but that's supposed to be at the top. Well, my writing is supposed to be on the right, so there's some sort of inversion with the camera going on. But basically, what it's doing is I've got a set of states in there. So as you execute an instruction, it executes a state. So there's 6 states, 0 to 5. So that's what the T states are for. On the same line, I've got 2 more LEDs that are not related. One's carry and one's 0. Then going down, which means you're going from the bottom up, I've got the PC address, which is just 8 bits. I've got a memory address, memory data. There's the opcode that will get fetched. And there's an A register, a B register, the result from the ALU, which effectively does the A and the B registers and puts them together and does some operation, and you'll see the result come out on the ALU. And then the bottom 2 is an out and an in instruction. So what I'm intending to do is to have a set of switches, which I can do the input. I'll have a push button that will then copy that across to the memory address register, and then another push of a different button will store it into data so that I can actually feed code in. Now, if I flip back to, I'll go back to VSC. Where's my VSC? There. And I'll go to share screen on my VSC. Now where did that go? Somewhere or other it's lost my VSC. Yeah, right. Now I've got it on the top. Can you see the Visual Studio Code?
Yep.
Okay. So where my mouse is, I presume you can see the mouse. They're the instructions that I'm intending to implement. So no load A, add, which adds a data value into plus A into the ALU and then stores it back in the A register. A sub, a store which stores it back into memory. Load immediate, a jump on carry, a jump on 0, 4 unused instructions, an input, an output, and a halt. Now, normally what people would do is they build this up in 7.4 gate logic, typically with a 74181 or a pair of 74181 ALU chips. Some people have implemented it with EPROMs only. Some people have even implemented it with just transistors and FETs. I've had a look at all those different designs and thought about doing one of my own with all sorts of gates. I decided that what I'd actually do was implement it just with a P1 or a P2. And P2 is what I'm working on, so I'm implementing it with a P2. When you start to look at cost of things, I'm using a 4-inch LCD. It's a 480 wide by 320 high color LCD, and I'm just emulating a whole pile of LEDs. I intend to, as the states go, I intend on the left-hand side to put little arrows and dotted lines that show where it moves the data from one register to another across a bus. Just so you can see how a simple computer works. And once people get used to that, then they can go on and use some other functions of the processor, which means that they've already got a computer to do various things. I mean, obviously I can do a Z80 emulation, which I've done. But the intention here was just to demonstrate how a basic computer works, and then to be able to, for the user to be able to input very simple set of instructions just to see how it works, and they're able to single step it or run it just to see how it works. And I was intending to send that out to all my grandkids and try and get them interested. So that's about it. If there's any questions.
This is like a Z80 or something, right?
No, it's a very, very basic computer. There's
oh, these are all the instructions. There's 16 instructions.
Yeah, well, there was a guy by the name of Malvino. Now, whether that's his surname or Christian name, back in the late 70s, early 80s, who designed a simplest possible computer for his probably university students, I would think. And it implemented about 4 instructions, and it was only a 16-bit, 16 register, 16 memory registers, plus an A and a B an A register and an ALU. And basically, you only had add and subtract. And it was very, very simple. Just designed to show how a computer works. This is just taking that step a little bit further and adding a few more instructions so you can do something a little bit more meaningful. I planned on having 256 memory addresses. So just so you can write something a little bit bigger. Remember, you're feeding this in, originally you're feeding this in using an 8-bit set of switches, and you're storing each instruction into memory, and then you can run it. And you can single step it and see what it does.
Okay, this is what this is the screen that you first showed that shows the internal state of this whole thing, right?
That's right. That's right.
Okay,
so you're looking,
I wasn't putting it together. Got it now.
Yeah. Yeah. So you're looking at what the internals of a computer are. And if you go back to very, very early days of the PDP-8s, I'm presuming the IBM, certainly the Univacs, the ICLs, we all had little either test panels or front panels that showed the internal state of the machine. And if you had an error, if the hardware failed, you could actually step through and watch an instruction being executed to find out where it was failing, to know what board to swap. So this is taking it down at the real grassroots level so that someone can understand the basics of a computer without getting confused with Z80 instruction set or 6800 instruction set, which have 200 plus instructions. You want to get down to something really simple and basic.
Yeah, I see.
So that was the intention, and I ended up going away from soldering a whole pile of things together. I'll probably put the board that needs to add to this needs to have the 8-bit switches to feed it in, and about another 5, I think, switches I worked out to be able to load the code in and single step it or run it. So that's where I'm up to, and I'm starting to verify that it steps the PC instruction through. So then I've got to check the next bits. And of course, then there'll be the higher level. Someone can have a look at it. It's written in spin. So someone can actually have a look and see what's happening if they want to go further.
That's pretty neat. The way to make this go in education would be to have like little things that could be done competitively among students, like little programming assignments, goals.
Yeah. When you've got the couple of instructions there, I looked at what instruction you'd need to be able to do something. You need an in instruction, you need an out instruction. You need to be able to test for carry and zero, and
Right.
add, subtract, load and store. And that's all you really need to do something fairly basic. Then you might want to do an and or an or, but I think initially you just want to do something really primitive. Once you get past that, then you can say, well, you've actually got a computer there, you've got a P2, it will execute these instructions. Now you can actually do something proper with it.
Let us know what happens when you put this in front of the grandkids.
Yeah, I'll do that.
Yeah, Ray, you keep mentioning your grandkids. How old are they and what do they do?
Range from 12 down to, what's the youngest one? I think the youngest one's 3. I've got 8 of them.
We're trying to start them early.
Trying to. Well, my older ones are not interested, but I've got two that unfortunately live in the UK that are set twin boys. They're 7, and they're interested. We got them one of these kits each that you clip the boards together, so clip components together. So they've got resistors and capacitors and a pot and a speaker and a sound module. So they've made a little radio and flashing lights and turning a little motor with a fan on it and things like that. And they love that. They're keen. We've got a little line follower kit that they're in the middle of soldering. So my daughter's teaching them to solder. She used to work for us soldering boards when she was in high school as part of we employed 120, mostly ladies, that used to do the hand soldering section of a contract assembly plant. And my 3 kids all worked there, soldering, testing, etc.
Wow.
So they've all been brought up with electronics. They've all been brought up with computers, and not the computers you guys are probably familiar with. My first computer at home was, apart from a D2 Motorola kit, D1 and D2 kits, I had a mini computer in my garage, and it was literally the length of my garage in 1977. So they used to the big computers. They used to know when I had the terminal, which is we call them VDUs, visual display units, big monstrous desktop unit with a keyboard and 80 by 20 character display. And they used to know when they played on that whether I had the computer in the garage connected to it. Because I used to let them just play on the terminal for a while, and then they got to realize it wasn't actually connected. Yeah. So
let me know if you need me to send you a robot, depending on the interest level and reception.
I'll do that. Thanks, Ken. Yeah. Yeah, it's a hard thing at the moment. We haven't been able. We normally go over and visit my daughter and family once every year in August, and of course last year was canned. This year, of course, there's no chance. Maybe next year. And she used to try and get out here every second year as well, but that's not happening either.
Hey, should we go over the schematic for the motor control board?
Oh, yeah. And Chip, in fact, Chip, I have to get off to UPS right now to get out to a teacher. So I'm just going to let my system run here. So we don't have to worry about passing recording, but I made you host. Okay.
Okay.
So I'm going to ride my bicycle. I'll be back in a bit.
Let's see here. Where did it go?
Now you should be in total control, and I'm going to let it keep streaming on YouTube because there are people watching it there. So the YouTubers, I won't be able to relay your questions anymore.
All right. Let's see. Here we go. Okay, let me get this thing loaded. Oh, wait a minute. 7 hours ago. Where'd this file go?
That's it. I can give you a link to it. I pasted it in the very beginning of the chat.
Oh, here it is. Here it is. All right. I've got it.
I'll tell you a funny story while you're looking for that. My granddaughter turns 2 next month, she's super curious about her mom and dad's phones and their Surface pads. So her mom was on travel last week and her dad was in the shower, and she climbed up on the buffet and pulled out their emergency pad and summoned the police department to the house.
Oh, why?
Because it was a pad and she was playing on it like her mom and dad plays on it.
Oh boy.
Her dad came out of the shower with the fire department out front knocking on the door.
So she just got into some sort of thing that signaled 911 or something.
Yeah, it was an emergency pad. They're supposed to hang it on the wall, but they put it under some papers, and she's very curious, and she saw them do that. So she got up there and dug into those papers and found that pad and started pushing buttons on it.
Huh.
So it's hanging up on the wall now where she can't reach it.
Interesting.
No, it works.
Yep.
Oh, watch out for the chairs and everything else because they can reach pretty high.
Oh yeah, she climbs on everything, man. They got to watch her all the time.
Do you guys see this schematic?
Yes, sir.
Yep.
Okay, so this is just the first page. So here we have, over here are the 8 connectors, or excuse me, the 2 8-signal connectors, because this is a board which will straddle 2 of those 12-pin headers, like on one of the breakout boards that we have. So it takes 16 IOs. And let's see, it's probably too small. Let me see if I can make this thing a little bigger. There we go. Okay, this should be more readable. Hold on. All right, so what we have is on these connectors up here, we have, this is like 4 half bridges, or, you know, so it can control like a 4-wire stepper, or a brushless DC motor, or 2 brush DC motors. There are 4 outputs, right? They can go from 0 to 40 volts, and they can PWM. So what we have here in this top section, if you can see, like, I don't know if I can highlight this. I don't seem to be able to, but you can see my cursor. We've called the motor wires UV, W, and X for the 4th one. X is a little non-standard, but it's the next letter in the alphabet. So we have, over on the first header, we have the low and the high switch signals for each UV, W, and X. So there's 8 pins that control those half bridges. Then on the next connector down here, we have the wire feedback voltages for each of those 4 wires. And I'll show you that in a bit. And then we have the motor current, and then we have 3 signals that are the Hall effect sensor. So if you look over where it says Hall sensor header here, you see there's this 5-pin header, and there are some pull-up resistors and then some series resistors. So this is how we read the Hall effect sensor. And then down here, if you look at this, I can't highlight, but if you can see my little cursor here, we have a 50 ohm shunt resistor for measuring low side current on the motor. And why is this called motor U, I wonder? That should be a general, that should accumulate all 3 or all 4. Anyway, there's like, we might have a problem here. But anyway, here's what the actual driver circuits look like. Whoops. Hold on, let me go down and I'll move my window. So this board takes in 40 volts, so we can run quite high voltage and high current motors on this thing. We use these microchip MC4604 high and low side NFET driver chips. And they're great because you can select an NFET for both your high and your low switch. And then we're feeding this thing 10 volts. So it can swing each gate relative to the source. It can go to the source voltage or source plus 10 volts, which is quite a good turn on voltage. And you can see over here where it says V in 40 volts, how we have one of these half bridges here. And then we have that goes out to motor U, and down here is motor V. And then on each one of these, we have a resistor divider, which takes that voltage. So if you figure if it's 30 volts peak or 40 volts peak, this will roughly divide it by a 13th. So 40 divided by 13 is like, it'll go about 3.07 volts out on one of these signals. So we have the means to switch each motor leg from ground or to 40 volts. We can use PWM for that. This thing should switch very quickly. And we've picked some low gate capacitance FETs for this job, or a FET for this job. And we have these voltage dividers. So this page repeats actually kind of twice. If I go down here, that was the UV, here's W and X, right? Now this thing down here, oh yeah, motor voltage spike suppression. So this should be what's called a transorb. And this goes between, it looks like he's actually got one on UV, let's see. Oh, interesting. He put the varistor on the motor, on each motor's U, V, W, or X signal. I think what Reza was saying in our last meeting is that we just need one of these devices, a big one, and then we need it to go from ground to the power supply. Do you guys remember him saying that? So I think what we have here right now is not quite right. Just like the shunt resistor is not quite right. Anyway, we have these 4 half bridges. There's 2 pages of 2 half bridges. And then the last part of this is this here. We figured that to run those 10 volt FET controller chips, as if they're switching at high frequency, the data sheet was saying those things can be drawing 100 milliamps each. So 100 milliamps each at 10 volts, and there's 4 of them. We were going to need a pretty decent 10 volt supply to drive those things. So we put a switcher on here. That's this top circuit up here. So this will generate, I don't know, probably like an amp or something at 10 volts. And this will be enough to power all 4 of those gate driver chips. And we wanted to do it, we didn't want to use like the 5 volts on the headers because they're possibly, that 5 volts may not be there, if you recall, because of the way things are evolving. And it's kind of it's not really adequate to switch the gates on those FETs anyway. 10 volts, a lot of them, they have their milliohm ratings at 10 volts, not 5. So this will give them good turn on. So this little 10 volt supply here is regulated from whatever the VN is, which could be up to 40. And this gives us our control voltage for the gates. And then we have the Hall sensor. We regulate 5 volts from this 10 volts just for feeding it to the Hall effect sensor. And then we have in down where it says screw terminal headers, these are our power input, right? 2 screw terminals, ground and V in, which could be up to 40 volts. So what's mainly different is we put a switcher on here to supply those gate drivers. So we've got enough oomph to really do the job and good high voltage. And then if we go to here, you can see down here where it says screw terminal headers. We have one of those for each of the 4, or for each one. So we're going to have 6 screw terminals. We have U, V, W, and X that go to the motors, and then we have ground and power and VN. And so we've got to fix up the shunt. It seems like he only has a motor current sense on U. And my understanding was that we were going to group all of the low side switches and run them through a single shunt resistor. So anyway, that's kind of where we're at with this. And Michael's going to be laying this out in the next few days. Do you guys have any comments on this?
On the,
Does it need to be?
I saw a couple things on the schematic. I don't see any mapping of 5-volt A and B to the 5-volt. I'm suspecting that you're only going to use A or B because the twin connectors,
yeah,
some of the connectors don't provide both. And
right. So we're not relying on any power from any of those, not the 3.3 volts, not the 5 volts, because our current requirements are potentially kind of high.
Okay, so you're just pulling 5 volts from your own internal source then, from the 40 volt.
Yeah, we regulate using a switcher. We regulate 10 volts from whatever comes in, and that's to run those high side, low side switching chips. And then we use a linear regulator to take that 10 volts down to 5 volts for the purpose of running the Hall sensor, which is, you can see kind of, you know, in the middle of upper part of.
Right, right. The other thing I didn't see was he indicates there are 2 separate grounds. Are you showing the 2 grounds differently on these schematics?
Well, you know, no, he has everything in one ground here. And if you look down there where it says motor current sense, he only has a sense on U, not on V, W, X, or Y. Whereas my understanding was we're going to have all the bottom side, like if we look at the switches here. Can you see my pointer here?
Yes.
That was going to be, that wouldn't be ground, but that would be common with all of the low side FETs, all 4 low side FETs. They would be grouped together, go through a 50 milliohm shunt resistor, and then to ground.
So I was expecting a schematic to see a different symbol for ground then, so that they would, on PCB layout, they'd show. But is that me just being naive, or?
No, this part of the, we have 2 problems that I see here. This is not ground. This should just be common to all the low side switches, and it should go through that 50 milliohm shunt resistor to ground. And then the other thing is these varistors here don't go on each leg. There's one of them that goes on the power supply. So rather than going to like motor V, we should just have one big one that goes to V in. Because it really doesn't matter what happens out here. This is where we start to get things destroyed, I think.
Okay.
But I mean, I don't know. I think these transorbs are also maybe not super fast. Does anyone know what their reaction time is? You basically want them to clamp the voltage before it starts happening in places where it shouldn't and things overheat and pop. So we should only, my understanding was we're going to have one varistor that went from ground to V in, 40 volts. But he's got one on each leg. Does anyone know, I mean, is it better to do it that way, or should we just do one? If we put them the way he has them, then we're protecting the drain and source of the 2 switch transistors. You have any opinion about that, Clouseau?
From my recollection, they operate pretty quick. We used to use transorbs for protecting our modems. But the catch is if you put it on your motor, you're really trying to protect your FETs, because further up, and to protect your FETs, you need to have one on, like if you look at your motor V, for instance, the bottom half of that, then you'd have a transorb going to your 40 volts and you have a transorb going down to ground, or effectively just above ground.
Right.
Because you need to protect both ways. I mean, a transorb will protect, a transorb's like a Zener back to back. So if you look at the two anodes pointing together, that's
Okay.
effectively what a transorb is in equivalent. And what you're trying to do is you're trying to protect anything that goes above or below your supply rail, because that's what's going to take out your FETs. Now
the FETs have those actually quite powerful, or high capability diodes in them.
Yeah.
So if the motor ever goes below ground, it'll shunt to ground. If it ever goes above VN 40 volts, it'll shunt to VN 40 volts.
Well, if you actually look at those diodes, if it goes above, it'll shunt straight into your power supply via the top one, but it will not go shunt around the bottom one because your diode's facing up. Because you're using a pair of N channels.
Yeah, that one will protect negative. That'll clamp negative spikes, but not positive. But the positive spikes will get trapped by the top device back to the VN 40 volts.
Yeah.
And those are very high current diodes that are fast too. So I think the varistor should go between VN 40 and ground, right? One big one.
Well, one big one's going to protect your power supply, in case your power supply is not protected.
Right.
Whether you're lower, so you're not protecting that lower FET
right here
with the diode, because the diode's not going to.
Well, okay, so that he'll
negative.
protect
Hang on.
himself for negative spikes. Yeah, see, these FETs protect each other by clamping to the rails that they're connected to. Right?
Yeah. Yeah.
So I think Reza was saying we just needed one.
Yeah, you're right. You're right. The diode is going around the right way. Yep.
Yeah, so I think Reza had said that we need one big transorb right across the power supply.
Yeah, that'll protect your power supply. If you're not trying to protect your FETs, you think they're protected enough, then yes, you need one between your power supply, just to make sure you don't feed it back up the power supply line.
Yeah.
Because if you've got a big spike and it went back up, what's going to fail? You've got a switching regulator that could then pass the high voltage straight through. That would then pump it through your 5 volt, and you could end up getting back in through your MC 4604 back into your prop, and that's what you don't want to happen.
Yep. Yeah. Okay.
Yes. So yes, you need one across your power supply.
Okay, and that's the only one we need, I think.
Yeah, if you're happy that these days, I mean, these days the FETs are pretty well protected, but
yeah, okay, so we have two problems here. We need to group all the low side switches, and then instead of connecting them directly to ground, we want to send the group through the 50 milliohm shunt resistor to ground.
Yeah.
And then we need one single transorb to go between ground and the VN 40 volts.
Yeah.
Which then says you're going to have the protected 40 and VN 40. And you want the motors off of the protected 40.
Wait, say that again, Stephen?
I'm kind of thinking for your naming. Your VN 40 suggests that it's right from the connector. And you really want to be, you want the drivers being run from your protected 40 instead.
Yeah, okay. So
how are you isolating the two, Stephen?
Well, I'm just, the VN 40 is the name for the entry point for the board. Is that correct?
Yep, that's where the power comes in.
Yep. And so you said you wanted a single larger varistor on that?
Yes, because the FETs will clamp to ground or to VN 40. So the only vulnerability, I think, is VN 40.
Right.
Yeah, it's straight across the input. So you've got a VN 40 and ground to it, and you've just got a transorb across that.
Oh, okay.
Right.
And so,
But it's still VN 40.
oh, it is still
There's
VN.
nothing isolating it.
Okay.
But Chip, can I suggest you've got a couple of issues. One, this type of PC the schematic is terrible because you can't see what's going on. You've got to jump between pages. What you've got there up on the right top, let's look at that section of schematic. You've got a nice resistor divider. You've got the EMF-U. That's great. You've got motor U, but you're going straight to a terminal, which is shown down the bottom corner. You could go straight to your little terminal shown there, and that gets labeled motor U. Your terminal block also wants to be a pair of pins, because if you go into a motor, you want to take a pair out. You don't want a common ground. You want to take so you want to line your pairs up, because you don't really want all your grounds going to one connector. You don't want them going to one set of four. You want to take, when you're wiring something up, you want to take the pair to the motor. So you need to have those two, and then your motor EMF can come from a separate section, but you can't see how the schematic's all sitting together because there's a bit of it on every page. It's the same as the P2 layout. The P2 eval. You can't follow a schematic because you can't see where it goes. It's just
right.
It's just a fundamental layout problem. You don't lay schematics out that way.
Yeah, I know this is just how Michael's been doing it for a while.
Yeah, I've said it a few times, and a few other people have said it. It's terrible.
Yeah, I kind of like things on one page too, but
well, you can't fit everything on one page, but what you can do, you've got all this stuff on the left-hand side. It just needs to be laid out different, where you can see exactly what's going on right through from one side right through to the motor on the other side.
Right. Let me show you something else if I can get.
I didn't see any bypass caps there either.
Oh yeah, there. I'll show you. They're on the left. Hold on. So see, he has an electrolytic.
Oh, okay.
And then, oh yeah, so this is for the high side, right?
Well, in that case, your 50 volts isn't high enough.
Well, he's got,
this is for
the 40 volt.
Yeah, you've got a 40 volt input and you've got a 50 volt cap. That's nowhere near enough.
Well, how high should the cap be? Because they start to get much bigger quickly.
Yeah, I know. But rule of thumb is always double.
Oh, okay. I didn't know that. All right, I'll write that down. So we need like an 80 volts or something.
Well, you don't get 80, you'll get 100.
Right. Okay, so you
and
know
what I'm also missing is, didn't Retso said you need also one nano or pico small one directly at the FETs? It's not just the trans orb. You also said you need small capacitors down
yes,
there.
that's right here. See, can you see my pointer?
Ah, okay.
Yeah, that's a 1 microfarad 0663 cap.
Okay, okay.
That's it. So that would be what he was talking about for the high frequency suppression. And then we have a big electrolytic cap for the bulk. But you know, the funny thing about this is that why don't we just, it's like we have one of these for every leg, but these legs are only separated by, you know, maybe a centimeter of copper. So it's not like they're really that isolated. There's nothing between them but a centimeter of copper. So it really is like one big common power bus with capacitors, you know, distributed in close proximity, but not really on separate circuit legs or anything. I was going to show you also, let's see.
Another question is why you come on 40 volts instead of say 48.
I don't know, 40 volts seems to be kind of a stopping point for a lot of components. And those are 40 volt, 25 amp. That's like a kilowatt, those switches are. But you know, where they get, I realize with those FET switches, their power dissipation, they can move, they can conduct a kilowatt without getting very warm at all. But when you're turning off and on all the time, and you've got that back EMF getting trapped by the diode, right? Because you think, what's 3 milliohms turn on with 25 amps? It's nothing, right? There's like almost no voltage drop. There's no self-heating. But that flyback diode, that catch diode that's built into the part, that thing drops like one whole, 1.1, 1.2 volts. That's what generates heat, is the back EMF getting trapped through that diode that's in the same FET. That's where your device heat's coming from, not from conducting the current out to the motor, but it's the off and on and the flyback it's being trapped by that diode that's getting all the heat. Okay, let me see here. Doug, where do you put that thing? Let's see. Let me just search. So I'll show you where Doug's, let's see. Actually, let's see, Doug sent this. No. Hold on. Doug had sent me a, oh, here we go, okay. Okay, let's see, this will probably be up here. No, wait, not this. Where did Doug send that layout to? I don't see it here. Should be right here, but these are older dates. No, I don't see it. Anyway, he sent me a picture, but he has this stuff laid out. So he has like these really thick, like here's the low side trace. Then above that is the high side, the V and 40 volt trace. I mean, they're super thick, they run underneath all the components. And then he's got the legs that come down for each one. So he's got it laid out really well. But Michael's redoing the layout now because we have a different schematic. Yeah, I don't think we're going to get any. Let me just see if it's. No, these are all. I don't think he has any pictures in here. Just Gerbers, which are changing. Anyway, I'll stop sharing this. So that's where the motor board is.
Yeah, the only motor controllers I'm working with or had to repair were from a small company named Corbin, which has those three-wheelers. And they run a 480 volts or something. But all the motor controllers I saw had kind of very big copper lines for power supply and not just traces. I mean,
yeah, you got to make big fat traces and probably try to get like 2-ounce copper or something. I've even seen them just melt solder all over the top of the trace.
Yeah, in that case, but I saw they have basically small copper bars on top of the trace and soldered them on, which I found a little bit overkill, but okay, 480 volts.
They used to do that in the little bus bars in in the mini computers of the 70s and 80s. They had little, I don't have a sample of it. Yeah, they were like a little tin strip with little spikes, so it was cut along like that, and then a little V that went down to a pin, and they used to solder them all the way through and make a little bus bar, and that was just straight with 7400 logic. So you know, you could be running 80 amps at 5 volts, but you know, per board, you know, probably, you know, you might have a few amps per board, but not all that many.
I wonder if we should just leave some big soldered spaces open where we can lay just big unshielded copper wires down and just solder them at a few different points.
Depends on what motors you're really, what current the motors are really trying to drive.
Yeah. This thing
Yeah,
is,
when you offer kind of, you can provide 25 amps at 40 volts, let's say, 4 times. I think it is kind of a lot of amperage. It's 200 watts or something. I mean, 200 amps. That's
it's 1,000 watts, right? 40 volts at 25 amps.
Yeah, it's 1,000 watts.
And that's going out to the motor. I mean, that's enough to run any hoverboard, I think, with the person on it.
Yeah, remember how big Americans are lately.
Well,
why that thing is not moving?
If my memory serves me correct, I've got a 35-foot catamaran, and when they were talking about powering them with electric motors, they were talking about 10 kilowatt motors. So you're talking about, you know, a 10 kilowatt for a 35-foot cat in water. What are you going to drive that's a kilowatt? We're not talking about a Mars rover here.
Why not?
No, I know, but we just want to make him do some good like a broad range of experimentation with it.
Mm.
You could run very small motors. I mean, you don't have to plug 40 volts into that. You could plug 6 volts into that, and it should regulate.
You make an electric revival of the quad rover.
Chip's gone again. Watley comes back. Some of those big robots they've got parallax. There's some big motors there, but I'm sure they're not kilowatt motors.
No, they had that quad rover with a Honda engine. I think they didn't sold very good because they were quite expensive.
Yeah.
I tried to fetch one of the last ones. They kind of sold out too fast for me. But that thing was basically nice. You could pull cars with it. And
yeah, the trouble is you're trying to build that, and all of a sudden your motor controller board that they're trying to sell into the hobbyist market becomes hundreds and hundreds of dollars.
Yeah, those things are expensive. The controllers here for the, I think, $500-600 for basically just the controller. They are called Merlins, or electric 3-wheelers, built in, I don't know, 2000 until 2004 or something. Nice little cars, completely useless, 1 seat. Yeah, somehow I'm got into the group of people who fix them for other people who have them. Kind of nostalgic, keeping them running. replacing all the lead acid batteries against Nissan Leaf batteries. And oh, we got a good deal with Nissan. We get basically all crashed Nissans, we get the batteries. And this
Chip's back.
Chip's back. Yeah, Chip, we need an electric version of the quad rover. So there you can maybe use.
Oh, yeah. Yeah,
How
the
big
quad
was-
rover could pull a car, but so could this thing.
Yeah.
So how many watts were those motors, Chip?
Oh, it was like, I don't know, 3 horsepower or something.
Yeah, hydraulic system.
Yeah. They used a motor with a hydraulic pump feeding hydraulic motors.
I think you need to look at what your market is, because you're going to end up with, if you really want to drive a kilowatt motor out of this thing, or even 4 250 watt motors.
And think about that transport, your heavy load transport thing. They have those little 2-wheeler, 4-wheelers that put under a load, and then 20 of them or 30 of them, and can steer each of them and get around with big loads around small corners and stuff like that. They are all electric.
Well, even diesel trains are electric.
So yeah, I can provide you with batteries if you set up a quad rover, electric quad rover. Friend of mine I'm working with, be getting all those Nissan Leaf battery packs after crashes, dismantle them and use those battery packs for solar systems and other electric cars. And we have, I don't know, truckload of it right now.
Wow.
Nice kind of size like this. Wait, I have one here.
Well, Michael's gone. If you make these things work at 1,000 degrees, Chip, you could sell it to NASA for going to Venus.
Yeah, oh yeah.
Those suckers look like this here. Look.
Only trouble, of course, is solder melts.
Right.
Yeah, we have some battery packs.
Is that
this one replaces a 1 by 1 by 1 foot lead acid battery of my forklift, and the forklift runs of this instead.
Is that lithium polymer?
Lithium iron.
Lithium ion. Wow.
Well, that's probably lithium ferric phosphate. I presume we'll ask when he comes back.
I mean, we had to leave the lead batteries in the forklift because they are used as weight, counterweight. So we still have the lead acid batteries in there, but not connected to anything.
Michael, is that are they lithium ferric phosphates?
I don't actually know really. It's what Nissan Leaf is using. They have kind of CAN bus for temperature control of the cells when you are loading them, and standard plugs. So you basically can connect them in different stack sizes. So we are filling up those Merlins.
Michael, how old are those batteries?
Depends. Some of them probably since 2 years we are getting them, and they are out of Nissan Leafs, which has had crashes.
So you didn't get them with those electric cars that you guys bought, right?
Yeah.
That's how they came?
No, that's where we put them. That's where we put them. We are replacing the old batteries against those. No, there are sometimes we even get pretty new ones. Last week we got 4 new ones from Nissan because they were wrong delivered to some dealership and they didn't want them sent back. So we got them for, instead of 30 per piece, 10-ish. I mean, it's the whole plate under the car, you know, it's a huge amount of batteries. I don't know, 200 kilowatt or something. No, they cost, normally a battery pack costs 30,000 and we got 4 of them for 40. Brand new. Yeah.
And so they replace what used to go in your forklift, but they're much smaller.
Yeah, the forklift battery, the back of the forklift is about 3 feet by 3 feet by 3 feet, 12-volt lead batteries.
Oh, wow. And that formed a counterweight.
And that forms a counterweight. That's the reason why they are still there. No, but that little pack, I can run that forklift for at least 4 or 5 hours with that little pack.
Wow.
Unbelievable.
You just need to mount that battery on an sticking way out the back of the forklift.
Yeah. Outrigger.
Tow a semi.
An outrigger, like on a sailboat.
I want to see if I can find a picture here.
Was machst du, Monster, denn schon wieder hier, ey?
Here we go. I'll share my screen real quick. I bought this horn, I don't know, like 10 years ago. It's a foghorn off a cruise ship. And I had this thing I had it next to this pressure tank on the floor with this big ID hose. By folding the hose to get it to loop around, that's how I got it all kinked up. But when it's pressurized, the kinks go out. But anyway, this is like a World War II era pressure tank. And it's like 1/4-inch steel. So the other weekend I made some brackets. I TIG welded this up here. And but this is the first thing I ever stick welded. I stick welded this thing onto here. And now it used to be that this tank was a headache because I'd go to pick it up with the forklift or the pallet jack and it would roll around like a big sausage. Well, now I got these flats on it with this angle iron and these feet, so I can pick it up with the forklift or the pallet jack. And then I've mounted the horn on top of it. The horn used to be on these rickety wheels that the guy put on that I got the horn from. So now it's like one monolithic piece. So you can charge it up right here, plug the air compressor into it, takes about, I don't know, 5 minutes or so, pumps this thing up to about 120 pounds. And then you close this valve, open up this valve, and then there's like a solenoid valve you can press up here. And it blows about 64 hertz. When you were here, Michael, I should have blown this for you, but this is super loud. It takes the bones in your ears and just bangs them end to end, even if you're like 100 feet away.
Chip.
Yes.
Extremely important, please listen carefully. You made a bomb. And I need to warn you because I worked too many years in the, not exactly in the air compressor industry, but in the metallurgical industry in Brazil, just in the design department, accounting for all the computer activities and running all the calculations, including, I don't remember the name, but you need to unsolder, then take some X-ray examinations over the tank, then put a pad of steel, a square pad or oval pad, at least twice the diameter of the area you are to be soldered. The largest dimension, you need to be at least 1.5, and better if you go twice the diameter of the pad over the tank formed under a press. Then you solder the steel pieces that hold the fog generator or something over the pad. Then weld the pad to the tank surface, because the amount of stress concentration onto those welds is enough to completely destroy the integrity of the shape of the cylindrical tank. Moreover, near the tops, the top ends, the left end in that view. So you can explode the tank and injure you and your family very, very fast. How is the pressure that tank can hold?
I think it's like for 250 PSI at 200
enough to blast everything about 10 meters in the vicinity, including people and furniture and the roof and the walls, because the amount of air inside the tank.
Oh yeah, yeah. If that air were to escape, it would probably like blow the roof off the shop.
Yes, and the people and your eyes and everything. Please don't do that. You can consult a mechanical engineer if you don't believe me, but
no, I believe what you're saying, but
I need to warn you. It's truly severe. It's better to kiss a man with the Indian variation of COVID and with the black fungus into his face, and you will incur in less risk of damage than having that kind of solder over that cylindrical shape. Moreover, near the caps, the left cap is the worst part. The first, when you have a diameter of say 50 centimeters, the first 15 centimeters near the cap, 1/3 of the diameter, is the worst part for explosion, because of the concentration of stress due to the shape change from the cylindrical to the cap. Yes, that part, that a little lower, left lower, lower your lower,
right here.
yes. No, near the solder, yes, exactly. That line is the worst one. Is here where the explosions begin, not in the center of the tank, because of when you fill that tank with air, it will extend his length. He will inflate like a ball, and you cannot observe that. So you need to avoid that kind of solder at any cost. Even if you need to scrap your tank to the trash can, you'll be far secure to you and your family. Please don't do that. Never, 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 never. It's totally forbidden. You have better chances running your car at 200 kilometers an hour against a huge concrete wall, and the airbags and the belts will help save your life. But with that bomb, you have no chance.
Yeah, I bet when he blows it, it vibrates those struts as well.
Yeah. Yeah, when I finished the welding, these two things, this one and the one on the other side, had gotten a 1/4 inch closer, because you know when you weld things, the stress will pull things in. I tack welded at first, but it pulled in. I didn't know what to do. I had to spread these things apart by another 1/4 inch. So I got a little bottle jack and put it between them and then jacked them apart, and then over jacked it so that when I relaxed it, it went back to where it should be. Then I was able to put the horn on. But go ahead.
And it was welded to the tank when you were jacking it like that?
Yeah, it wasn't pressurized, but it was welded to the tank. So I probably, might have deformed maybe this area more so than like this.
I hadn't thought about
my understanding.
I hadn't thought about the vibration, but just welding to a tank, I would have thought could have reduced its integrity.
You'll remember though, one thing, I would not have done this with a normal cheap modern tank, but this is made it's like Whit-Prattney from like 1942. It's at least a 1/4 inch thick. It's very thick metal.
Oh, you don't have chance with solder. The solder distracts the grain of the metal due to the melting temperature. So what you are doing is having abnormal distribution of metal particles in that region. The grain is distracted because of the temperature cycle. You need also to after soldering doing the right solder, you need to stress relief the tank. And you need to, before you start soldering, you need to avoid any dimensional changes into the bolting of that horn structure. That horn bolted to the structure gives a lot of mechanical integrity to the top. So when the tank tries to breathe, he extends. When you are filling the tank with air, he starts to change its diameter. And when the tank is being exhausted, the diameter shrinks back.
Right.
So yeah, this is what caused the comet planes to explode in the air back in the 40s or the beginning of the 50s. The bridge project of the comet planes, the wings were soldered very tightly to the fuselage. And when the fuselage breathes because of the pressurized cabin, the wings simply fractured the solder due to stress and due to the change in diameter and due to the stress induced by the flight. Then the wings were peeled off from the fuselage and blow the jets during flights, and many people died.
Yeah,
this is a simple example.
I wonder though, I mean, if this tank were to rupture, it would probably, you think I don't know if it would really air a little bit and then exhaust quickly. I mean, a bomb is thousands of PSI, right? This is about 120.
No. I'm sure you can test it inside a pool, at least 10 meters deep. And after too many cycles, it will explode inside the pool. So you need to film that and stay far from the site. And then you can believe me. Just consult the ASME code. I used to have all the codes pertaining to that subject inside my head, but it was 40 years ago. I quitted working with that kind of calculation in 1980. I did it in 6 years almost, and it's enough in my head up to now.
The other thing, have you inspected inside it? Because those things, because compressors hold water, because they extract water.
Oh yeah, it's kind of rusty on the inside.
They test it filling with water at the maximum pressure, 1.5 times the design pressure, to look for defects. And
Right,
this is enough. This is enough to show all the defects. 1.5 times the design pressure filled with water. There is a water pump that slowly fills the tank and then pressurizes it until the test point. And you can see the cracks developing around that solder joints by inspection. Yeah. And then you can do an X-ray or use radioactive testing through gamma rays, and you will see the fracture is being developed from the inside to the outside.
You think if I did a water pressure test at because the water is safe because it doesn't expand, it doesn't compress. So if it got overpressured with water and broke, it would simply just spray water for a little bit, then it would be over with, right?
The test can be done if the construction is right. But when you do the construction wrong like that, the test is no guarantee that you have a good behavior along the lifetime because of the fatigue. The metal suffers from fatigue. The more the difference of strain, of the capacity of absorbing strain, the L-shaped metal is very strong as compared to the surface of the cylinder. So the fractures will be always developed into the cylinder walls, never over the L-shaped, I don't know the name, I don't remember the name of those
right angle.
Please?
Right angle?
Yeah, yes, right angle or angle iron?
Or angle iron. Mm.
Yes, those L-angled shapes of metal that you solder over the cylinder are very, very stiff as compared to the
tank wall.
Yes. Even submarines, I did a lot of calculations using von Mises equations by the time to be sure that even under external pressure, the surface of the shells will not fracture. Because some of the shells we have designed things like 22-meter diameter spheres for Petrobras, for the oil plants in Brazil, or with oxygen inside for the foundries. So I have a lot of experience. Please don't do that, my dear. If I did saw it before, I will warn before you waste, because when you try to desolder, you will be using some kind of a special electrode to remove the older solder. And this also causes the stress over the surface of the tank. So if I was a mechanical engineer, I will advise you to scrap the tank, just to scrap it to the, and please ask for someone to cut it in pieces so it cannot be used again, because it will eventually explode in the future.
You know, for it to explode, the metal would have to be brittle somewhere, right? I mean, it would have to be
Because
strained.
of the solder. Because of the solder, the metal structure turns brittle. Because including the fact that you didn't do stress relief into a furnace. We used very big furnaces to stress relieve such kind of equipment, blasted with oil and make with silicon bricks around, with temperatures reaching almost 800 Celsius degree or more, to only to relieve the stress of the parts before putting them in the test, after the solder and before putting them on the test. You use a MIG or TIG?
Well, I used a TIG to solder these, and I used a stick welder to solder these.
What is a stick welder as compared to a MIG welder?
A stick welder has a metal stick that's coated with flux, and you just touch it and it starts arcing.
Oh yes, it's not TIG. It's near MIG. MIG is worse. Yeah. MIG is worse because it left as many particles of oxygen and carbon and other contaminants into the region of the weld. It's very, very, very dangerous. You don't believe in the extent of damage such things can cause until you see the result of an explosion. We have a lot of gas. We have a lot of cars driving with gas in Brazil. And when such of a thing explodes, it's not because of the tank, it's because of the leaks, and really distracts the car. But when a tank explodes, it's devastating. The whole gas station, include the roofs and the windows and the doors and the walls, everything in the radius of 10 meters will be blasted.
Yeah. I wonder, okay, let's say that thing is at 120 pounds and it has the volume that it has. If that is at relative 0 pounds, like atmospheric pressure, how much more air is in that tank? Like when that thing's at 120 pounds, how many tanks worth of air would that be at 0 pounds at sea level? You think that holds like 4 times as much air?
No. If you, the sea level is 15 pounds, if I remember right.
Right.
So what's the pressure of the tank?
120.
120, almost 8 times the volume.
Okay,
but
so it's linear.
Yes, but you have a problem. The rate of escape is not linear. If you have a little hole, it will escape very slowly. But when a surface rips, there is a sudden failure, a very large failure, and some brittle pieces of metal will escape in pieces like a grenade. It's not only like a can of worms being opened by a can opener. is ripping like a grenade.
Right.
That is the
Yeah, I
where.
should have put.
Please go ahead.
I should have mounted the horn down all the way to that leg that I bolted onto the tank. I should have had the iron go all the way down the side of the tank and then mount to that flat angle iron that I can use to pick it up with.
Yeah. But you also need to check the rust inside too. Very important to make sure you haven't got the integrity, particularly down the bottom where the water will sit.
Yeah.
Yes.
Well, this is an old tank. I mean, my friend who has a prune dryer up the road just brought it down one day for me because I had this horn. It was made in 1942. I think it's made by Westinghouse, not Pratt Whitney.
The main problem with air tanks is because people forget to put dryers and filters before the pump that fills the tank. So the tank is filled with water, with moisture, with any kind of contaminants that are in the air. When you fuel an air tank, the best way is use filters like the ones used by people that dive, because the filters are very good and not too expensive.
Okay.
But you need to adapt the size of the filter to the amount of air your pump is able to dislocate. I don't remember all the terms. Oh my God. You need to fit the filters to the pump to be sure they will work properly.
Right.
At beginning, I believe it was construction a motor like the one for the V1 bombs from Germany during the World War II. Is a kind of jet engine we use it, but I cannot see the front side of the motor, so I don't. It's a pulse jet.
Oh,
At first, yes. At first, I think I thought you were construction a pulse jet.
Oh, this looks like one, huh? Yep. Well, do you think this would it be safe if I sold it to Michael Summer in Clear Lake?
Mounted on my LeBaron, yeah, on the roof of the Baron.
You can hear this for like 5 miles.
With all this discussion about a bomb, you're going to have ATF and Homeland Security showing up at your barn tomorrow.
You can say you are doing the jet motor for experiments.
Right. I've pressured it up a few times to 120 pounds, and it didn't. I mean, I didn't notice anything.
Fatigue, metal fatigue is a thing unavoidable, but it can take a little time to develop enough fractures to show up into a real problem, but it will happen.
Yeah, the Tesla guy, the Elon, he had kind of words for it. It's a rapid, unplanned deconstruction.
Decompression, probably.
Deconstruction. That happens to his rockets lately when they land. Rapid, unplanned deconstruction.
Huh.
Hi, Jim.
Yes.
Back in February, you got into a discussion about what might be the next thing in computing. You got off
Oh,
on a
yeah.
tangent about the things that are about to happen that we don't know anything about yet.
Yes. I have, let's see, I have that thing open. Where'd I put it?
Did you get it?
Right here.
To think that they can use light to hold memory. That, I don't know. Sounded close to what you was grasping for, though.
Yeah, I'll read this. It's interesting. It doesn't look like anything we'd be able to work on directly because it's probably kind of complicated, but requires some special stuff to operate. But
yeah, they've only been able to carry it in the millimeters at this point, but they wrap it in some kind of I can't remember what it is. It's in an article, but they wrap it in something and they sent it so many millimeters, and then they were able to unwrap it and using light to transport data memory. It's not fiber optics. Anyway, I wanted to tell you that before I slide out of here. Y'all have a good night.
okay, yeah, I'll read this thing and try to absorb it.
Oh, I don't know. It looks like maybe 10 years after we're gone before they get that one coming.
Yeah.
Y'all have a good night.
Okay, good night, Brian. Thanks.
Yeah, what I think is that MRAM is kind of interesting because it's almost as fast as RAM, and you switch it off and it's still there. And combine that with the principle of force, where you can just load some dictionary into your system with those programs you need and the stuff, and you switch it off and switch it on, it's still there. Yeah, I find that pretty fascinating. And the other thing is, which I think you really should plan in your behind in your mind, maybe not the whole. I mean, if you do development on the P2 HyperRAM combination, then don't use any web browser but because they are back to the computer. Bullshit.
Yeah.
It has to be self-contained with keyboard and mouse, or screen, or serial, or what. That serial you already need,
Mm-hmm.
What I think, what you should kind of think about how to use it would be some extended drop clock, which you can communicate with a PC if you need to, but you have kind of a small keyboard, small screen, and can basically program or HDMI, I mean, whatever you have as screen. I think in opposite to Johnny Mac, and I usually share his opinions, but I think that self-development thing is valuable. But he is right in not alone. You have to have both. And in this case, I think FlexSpin, now Würfel is putting in the bytecode interpreter into FlexSpin. I mean, for P1 currently just. But pretty soon, FlexSpin can also compile to bytecode. No, this is, you have an open community here which is doing wonderful work, and Würfel is also she is a good, really good programmer. I looked at some of the stuff she did. Wow. Yeah. And I think really having a development system on the P1 was what brought me into it, because of mParks, Spinix, and editor, and everything on a P1 I put on a breadboard. That hooked me completely now since 10 years, whatever. Because it was back to the time where you had that Commodore or Atari or TRS-80 booting it up, and you are in some basic, you have instant results, you know. And I think what most important would be, and what is something you could start now already, is putting a P2 on a VGA monitor and display all your debug and a serial terminal. Kind of the external debug and serial prop tool and debug on the P2. And I mean, you can use another pin for debug and have still your program using USB and serial or whatever, but you can send out all the debug on another pin to a second P2 displaying it. And that would be kind of, then we have the fast reaction time and all that delays out of window, letting a P2 display the debug. That would be a product I guess a lot of people would buy. Even, I mean.
Yeah, I'm always thinking about these things. I feel like I don't have quite the right idea yet. I'm just waiting for it to form and snap to grid, and then I'll do it.
I mean, Arglo did that video driver, which is a bomb in itself, because it supports almost everything. You can display something on it. And he has regions. It's just kind of just horizontal. You can't do windows. You can just do stripes. But you can put stripes in different, in text, in graphic, in different resolutions, in different font color, whatever, and do that dynamically. He has something like display lists where you kind of point to different buffers. I mean, it's very pretty thought out, his mailbox and driver system. And you can put basically stripes on the screen with text or graphic or whatever, you know. And that would be something in my, and each region can get data from a different buffer. It has not to be the same buffer. It's very flexible. That driver then Gary's USB, and you have to figure out how to do all your debug displays on a P2.
Yeah, that's not bad. We'll need floating point for some stuff.
Yeah, but floating point looks good already, in my opinion. You basically need to check for that valid none thing. What is, but I think it is -0. I remember it is that, I think, because it's not number.
-0 is the only non-numerical representation of those 32 bits.
Richtig. And that is the reason why that is, in my opinion, and it might be that the exponent also has something, but I don't think so. But at -0 makes sense because that is not a number.
Yeah, and they say you would switch to NaN if you had an underflow or an overflow, which really means your number became so big, either in the positive or negative direction, that you couldn't track it anymore. I mean, you can roll off and go to 0 and you just have 0 left. So those kinds of, those are not considered underflows. It's only, I think, when you exceed the maximum and minimum, or the most positive and the most negative number that can be represented, that
Right.
you have a
I
NAND
think
situation.
the other rule was that if in one calculation is one none, then basically everything else will get none also, because it can't be computed anymore.
Yeah.
So you
That could be that.
can always check your result of for being none, and then you know something went completely wrong. You don't know what, but basically then you have to dissect it. You know.
Right.
I like that implementation with the dot behind the whatever plus minus divide. It's logical, it's understandable, and I don't think you need really. I mean, if you do floating point, you should know that you are doing floating point, and you have to accept that you have to track your variables with kind of whatever. If f in front, f on the end. I like that f underscore because I like the way Johnny Make is coding, and he is constantly using that p underscore if he has a pointer. And f underscore would kind of fit nice into that scheme, but yeah, you can also use f and then whatever, you know. But I think if you name the variables, you can keep track of them, and then it's not a problem to know that you can't use integer and float together. I mean, it's if you can't understand that, then you shouldn't program. Yeah.
I'm looking at pictures of exploded air tanks. What they do, they just rip open. They just tear open like a big gash. And they're usually rusted inside. I know this one's rusted.
Hey, Chip, if you want to feel more comfortable in that tank, what you do is you do a little hydrostatic test on it. You fill it with water, then put a squeeze on it with some, you know, more liquid, maybe even hydraulic oil or whatever you can take to push it up to that rated working pressure. Plus, I think it's 130%. It's on the tag on the on that receiver right there. It's probably been painted over, but it's got its working pressure. Then you do like 1.5 over that. So if it's 100-pound allowable working pressure, then you take it to 150 for a hydro. And if it does leak, since it's full of water, it won't explode. It'll just leak. It won't be catastrophic. And then you're good. You have to fill it with something incompressible like water, so that when you put a squeeze on it and it fractures, you're not taking out your barn.
Yeah.
That's how they do it, you know, like in the gas bottles, the places that sell oxyacetylene. And there's a ASTM code for all the pressure vessels and hydro dates and, you know, time periods between hydros. But yeah, you know, you don't have to do an internal inspection. You just do a squeeze on it, and if it's thin wall, you'll take it out with 150% hydro.
Kevin.
Yeah.
Those tests are for static pressure. They don't account for fatigue. Air tanks for compressor are well known for suffering from fatigue because of the cycling of the pressure. So a tank designed to be steady under pressure during all the operational cycle doesn't experiment too many cycles of expansion and shrink due to the air intake or exhaust during the process. But yeah, when you use air like a lung to inflate something and then exhaust under control, you have the changes in dimensions like length and diameter that cause a lot of stress into the metal.
Yeah, I agree. I think the industry standard there would be the magnetic particle test on welds and connections on a pressure vessel. I'm not really sure on that, but the integrity of the receiver is generally, you know, hydroed. It's not, you're right, it's not dynamic, it's static. The worst thing on that whole setup is probably that hose, that rubber hose has got a hydro date too. And that's got to be stamped on it, the length of it.
I think I lost some part of the explanation because your voice, as I heard, your voice did vary the level.
Oh, okay, sorry about that. You know,
Yes, during your transmission, your voice varied the level, so I cannot heard all the explanation.
yeah. No, I was just saying that there are regulatory on pressure vessels. And if you're talking about a dynamic flow, then you're looking at piping, and that would be the magnetic particle test, followed with a hydro, of course, and then or X-ray. Then the weak link in that whole picture is that rubber hose. You know, the reinforced rubber hose has a life, and I'm sorry, just a life expectancy, and there should be a hydro stamp on it if it's, you know, conforms to ASTM regs. But that's, you know, home built stuff is exempt from that, right?
Okay. The last tank I did calculated in my work was an oxygen tank that stands under the seat of jet pilots for the first jet fighter made in Brazil with a consortium with an Italian industry. And then we tested those tanks inside a tunnel using a 0.5 machine gun against the tank, and everything was controlled by a distance. And many tanks exploded as we are looking for, but we don't matter if the tank explodes. We only measure the length of the damage, the area of damage, to be sure the pilot will survive. So there is if there is a puncture in the tank due to an accident with a tool like a hammer or a sledgehammer, or a car crashing in the tank, or even a hard wood rolling and hitting the tank, the amount of damage will be very, very large compared to the normal small leaks that will start before the tank collapses.
Yeah, that must be a composite tank, some sort of a fiberglass or carbon fiber wrapped, maybe aluminum shell tank, or yeah, something like that. That would be a composite tank, I believe, to contain a rupture.
I saw many things. I don't remember all the scenarios we had during test. Even the static filling with water was very carefully done to be sure no one single bubble of air remains inside the tanks. So I did put 2 links into the chat. One we using showing calculation due to the ASTM code, and the other one is when air tank is standing vertically, because it's easier to craft a saddle into the caps The caps are some way spherical, so they can withstand twice the pressure the cylindrical surface stands for the same diameter due to the stress. So when you look at those green, I believe they were green, those green tanks, no, blue tank of air standing vertically, it's being supported by a circular saddle soldered to the cap. And this is a very good place to solder something because of the strength of the hemispherical cap is very, very high as compared to the cylindrical surface. But when you put a tank in the horizontal and place as many saddles as you like, the surface of the joints will be very prone to fatigue problems due to the expansion.
Okay, super. Okay. Okay, very good. Yeah, for
Another thing that adds up,
Brazil.
those tanks are for
This guy talking.
1942, well before
These guys are from all over the world.
Were
They're using our chip.
perfected.
Yeah.
The codes start to be
And we have these
perfected around
meetings
the
once a week.
70s, almost 30 years after the
Bud,
date
yes.
of
Yep.
build of those
Yeah, what a
tanks.
project. Yeah. Oh yeah, he said I should get you one of those. I got to go get some more shirts. Okay, thanks, Marco.
You were talking with Marco Ship, and I said that your tank was designed and made in 1942, at least 30 years, 3 times 10 years before the codes were perfected by ASME codes. So I'm sure they were not made according to any special precautions because it was wartime and everything was made with a hurry because they need to fight the war.
What is?
Yeah, very good, fantastic. It blasts. Can you imagine the amount of this is from a poor linear solder joint made on the tube. Do you can see how much it can affect the whole surface of the tank?
Yeah, that first tank looked like it exploded because of a failure of the weld, and the blue one here is general thinning, rust inside. The first tank had bright steel. You know, it's a relatively new tank. I think the weld failed on it, or they overpressurized it.
Or a bad weld. I remember a guy, I hope it was in the 60s, that was paid to inspect tubes to be used in nuclear plants. And he was expected to take X-ray from each solder according to the codes. What he did was replicate the X-rays without taking new ones. So when the joints start to fail, many damage with leaking of contaminated water from the nuclear plants were popping in every place because of the bad job of that guy, that inspector. And he was arrested, if I remember, and the company was sued by a huge amount because they don't check the work, and they didn't check also the x-rays were not replicated because they were compared by hand. There were, at the time there was not computer program able to digitize and compare the welds one against other.
Yeah.
Wow.
That air tank comes in kit form, looks like. All the pieces right there.
Ein Hoverboard. Huh.
Yeah.
Ja, also Chip is now doing floating point. I think Eric will follow with that too, because he is pretty much following Spin 2. And I like the way it is planned right now, because I never liked that method card with F sub F at thing. It was barking to read. Now it reads like a normal expression. Oh,
and you yet to see the way a submarine collapses. It's very weird because the cylinder got shrunk longitudinally and formed at least 3 or 4 lobes of the formation into the cylindrical shape near the caps, both sides, before collapsing. Independent of the thickness of the steel. You can use 4 inches of steel, you can use 10 inches of steel. It will collapse if the external pressure is enough. Wow. As you can see, the cap region is very stiff as compared to the cylindrical region. So the solder joint fractured along the joint, but leaves the cap intact.
Yeah.
If you look, there's a nice little piece of metal gone out of the left-hand top corner of that opened, flattened piece.
It's due to the violence of the explosion. He was upheld by the soil or something, because I believe that tank was not in the horizontal position when it explodes. It must be, had exploded vertically, and when it falls over the floor, the damage was contained in one direction.
Yeah, it probably just dropped, fell down, and broke then. Yeah.
That distortion in the cylindrical shape near the top of the air failure area almost tells that the tank was hit or by the soil or by another instrument during the fall.
Yeah. It's dented in on top, yeah, on the top of the picture, yeah.
I should have worked to the FAA to control not to look for causes of plane crashes. Yes, it's fantastic the way they have construct planes that exploded in the air to every piece, almost every piece got in place with glue to discover what was the cause of the explosion.
Mhm. That wouldn't be a job for me. Too painstaking. Kind of puzzling things. No. Yeah, Chip. You said floating point until the weekend.
I believe the chip did, the connection did had a problem. While Lachlan and, no, Chip is there. Lachlan and Michael are in the same screen. Michael, you were looking for a way to connect to 2P2 to transfer data between them. I'm right? Michael.
They are not listening anymore. Tubular.
All right, sorry, found the unmute button. Yes, we are connecting multiple P2s together.
But how do you do that with the reset line? That is my kind of current blocking there. You basically need to reset each of them instead of all of them to load one in the chain.
Yeah, the reset line resets them all simultaneously, but when they're booting or when you're loading them, you're using the ID, like, you know, when you do a prop check and it's normally 0, 0, 0, 0, you change those values instead of being 0 to match a pin mask. So you know which one you're talking to, and you can load them individually. And only the one whose pin mask matches what you're sending will load in that code. And so you have to load them up sequentially.
So, okay, I see. Yeah.
Yeah, you have to load some microcode sequentially, but you can then run, and each one does know its own ID from that pin mask.
So basically, you are flashing all of them one after the other, and every time you reset all of them, they come. Some of them load out of the flash, the other one takes the serial stream with the mask.
Right, but they know their own ID from that process or from the pin mask. Yeah. I think we showed this is this works with Ray's board. Ray's what do we call this, Ray, again? It's a Blade 2 board. And so we've had 16 of these, 8 of these on a long board. Mm-hmm. If you look at the top corner there, you'll see that this is like a 16-way encoder.
Okay, yeah.
And so you can turn it, and it's got some LEDs and a couple of buttons for testing with. These are up on like P40 through to 47. And so we plug that in. This is, you know, on top of Ray's normal board. And then on the back of the board, we've got this header. That's it's like a there, but that's the P2. Ray's CP2102 style header. So it's got 5 volts on there, as well as the DTR and the TX and RX, or serial in, serial out. Yeah, what Ray's holding up right now. So what we've proven, what we know we can do, is load up the multiple boards on here, but there's a few tricks and traps along the way as to what serial rate you can get and how fast you can go, how many boards you can load. You might have to trade that off a little bit. One thing we're looking forward to, though, is when we have this tiny little board, like, we'll just stack this so there won't be much bus capacitance between all this. And so we're hoping we can go faster with a stack of these. And of course, with that high density connector, the stack height is only 2.6 millimeters, you know, so having
very nice.
10 of them in an inch or thereabouts. So hopefully it'll we'll get some results.
And what you do about electrical protection of them pins, or do you just wire TX and RX together of all of them? Do you put diamonds in there or
we put series resistors in to protect TX, you know, so that each one can have some insulation, but it tends to just get in the way, to be honest. It slows things down. And as Chip will tell you, you don't really do a whole lot of damage, or we don't seem to when you drive one pin against another. If you drive one pin into a hard short, maybe you get a bit more current flowing, but you know, if one P2 pin with a 19 ohm drive is pushing against another pin with a 19 ohm drive, not a massive current flows, maybe 60, 70 milliamps, I think, somewhere around there.
I mean, it's just for the time when they are coming out of reset, they are all in kind of 5 volt or 9.3.5.
When they're in reset, that when they first Chip programmed it in so that if that prop check is not 0000, then they don't drive the pin coming out of reset. They go into a float mode. So they initially, like when you do that initial prop check, like when you're checking what's out there, as soon as they hear that 0000, they float instead of driving the TX.
So you are running a prop check first for all 8 boards, and then they are floating, and then you can program them.
Yeah, I guess it works mostly as designed. There was some minor issue with, I think you can't use P0 and P1 for the pin mask because of the way that's used in the loader or something like that.
Then the loader there gets set to something, yeah.
Yeah, but if you just use higher numbers for your pin mask, you know, pretty much any other pins, then you can work with it. So yeah, I mean, Brian's more of an expert on this. He's been doing the hard work on it, but he has it operating, and we're just experimenting with different serial chipsets, I guess, to see what rate and how many boards we can load simultaneously.
Well, I find that massively interesting.
Hey Ray,
nice.
there's a opportunity for that board that you designed without any connectors or any outputs on it. I'm sure Tubular could use those even better.
Yeah, we need it. We need we need multiple P2s for what we want to do, and we want to be able to just scale up. So we need it narrow, and we need lots of them.
What's the problem that you're trying to solve?
It's just mass sensing, data collection kind of thing. So just we just want a lot of flexible I/O pins, and the P2 seems to be best in class for doing that.
Did you see the board that Ray designed that doesn't have the VGA and the other stuff on it? It's just basically a P2 with his excellent bypass and stuff on it.
Yeah, I'm sort of, I talk to Ray regularly about these things, and there's no question, like, Ray's got the the tightest, that what he's done with the bypass caps and keeping the crystal close and all that kind of thing, it all pays off. We don't have the luxury. Our real estate really needs to be smaller than what Ray's got, and also we need to get faster data transfer, and so having something which is this spread out, we really need to get it down tight, and hence we're not using as many bypass caps as Ray does and things like that, but we're still, I mean, on this board you've got regulators right against where the bus is, where it's going out, and they've got capacitors on there. So it's not quite your traditional design where you might have a regulator and then like 1 inch of traces and then chips. The regulators are literally underneath the chip. So
that little board that you held up had a P2 on it?
Yeah, it's got it. I've got 2 versions. This one here has just got headers, and there's another one here which has just got the chip. And because it's so small, I've lost it already on my desk. But yeah, the presentation this morning, it's on this board. This board is 0.7, or it's the same size as a US dime. Here you go. This has got a P2 on the top, and it's got memory and regulators and crystal and connector on the bottom, tucked underneath, and pins broken out.
Wow, that's tiny.
Yeah,
but
it's really tight. It's we for our criteria is really the narrowest possible width between the two pins. And for comparison, this is like a US dime coin. So
if your need is for lots of I/O and bandwidth between the chips, why not run parallel?
we can run, as in break it out in parallel. Is that what you mean, or sideways, or
run a parallel bus, or like mailboxes between adjacent chips, or I'm not exactly sure what you're.
Yeah, so we'll be stacking these this direction. Like we need the 0.7 inch narrow that direction, and we'll just have like a array of those, so I can pick up connections coming in this direction and from the top. So there's plenty of space. But for us, I mean, one thing is this achieves one 32-bit core every 0.1 of an inch. So for every 0.1 of an inch, like your connector, you've got a 32-bit core and kind of eight pins dedicated to that 0.1 of an inch. So it's an impressive density, but we still have to have means of dealing with heat and power and this kind of thing.
How many millimeters across is it?
Just under 18.
Do you have a high-res pictures on the forum on this?
No, we won't post the high-res picture of the back, because there's some sneaky stuff we do on the back, but on the front, what I can do, we can't post into here, but I will post up an SVG file of the front on the forum, like the top layer, and that's a little bit clearer than the photos. So it sort of shows where the breakouts, what happens with the pins and the pads. And we'll probably do some custom breakouts where we just take this core. So now that we know we've got a core which is 0.7 of an inch square, we can break that out different ways. So I think breaking it out and having those 0.1 inch connections at either end is sort of useful. I worked years ago with the Intel, or I started working with the Intel Edison years ago, and it was a pain because you had no option other than the high density connector. And of course that product, even with the might of Intel behind it, kind of disappeared from the marketplace. But in my opinion, one of the fatal mistakes I made was just to have not even any 0.1 inch connections on it. So
have you tried overclocking it?
No, we haven't as yet. We're still powering it up. We're going to talk about this in a few weeks' time, and then I think Johnny Mack was busy this week or something, so we filled in a slot for Ken. I had a phone call with Ken, and he said, Johnny Mack is sort of rearranging what he's doing, so we're happy to sort of talk it off. But it's a little bit premature. Probably in the next week or two, we'll get some figures on temperature rise versus clocking speed, and just confirm what it can go to. I don't want to sort of preempt that. We'll just test it and see what we can achieve. I'd be happy anything over 280 megahertz or thereabouts.
Yeah, that'd be interesting to see. I think, doesn't yours go to like 360 megahertz rate? Something like that?
380.
380, wow. That's way above spec. Well, I don't know what the data sheet says, but I think originally we were talking 200 megahertz as the goal.
180.
180?
180.
That's pretty cool.
Oh, it came out quite faster, yeah.
Well, it was intended 160, and we creeped it up to 180.
Now you can run stable at 360. That's pretty cool. Hey Chip, did you see that wafer offer on the forum for 130 nanometer? You're muted still. We can't hear you, Chip. You got your mic muted.
It seemed to be for digital stuff, like, placed and routed. And I don't know who does the place and route, but I remember looking at it and thinking you couldn't really do like the analog design because it was all geared towards digital. I mean, I think they gave you the IO pins that you were going to use, which means that they probably want to take like a Verilog file or something and compile it for you to make your logic. So it would be good for logic, but it wouldn't be good for just full custom design for like DACs and ADCs and all that.
Yeah, I think their IO was completely fixed.
Yeah, in certain pins were ins and outs, and yeah.
Can we do a P1 with it?
Yeah, probably.
You can do, according to that post. Was that your post, Douglas?
No, it's not mine. I'm HINV on the forum.
Oh, okay. Yeah, it was saying you can have it for free if you do a public, an open source project. So P1V, P1 Verilog would be the way to go.
Maybe even a port B, P1.
Yeah.
Cool.
Yeah.
No, there's a fixed number of pins. I think it's 36.
Yeah.
Oh.
Well, one port plus 4 extra. We'll get to port B eventually. 4 pins, one nibble at a time. But the thing that would be interesting is just to know, just to put a P1V, even if you can't have, analog or say counters or PLLs, just to find out how fast that core runs in 130 nanometers.
Yeah, a simple P1 should go quite fast because it hasn't got the logic in it.
But do you know, do those guys offer RAMs and things? I didn't know.
Yes.
Okay.
Yeah, sort of thing, Brian worked, and Roger as well, have synthesized P1Vs in had them up and running on those DD0 nano boards. And in Roger's case, it was either a Lattice or a Xilinx board. And it's just a shame, like you kind of lose that knowledge. If you don't use it, you kind of, forget it a bit. And so, I don't think we could get something together in a week for the deadline, but it would be interesting to do, if there wasn't other pressures.
Yeah, that would be interesting. See how fast that thing can go.
Yeah, there's another one going in 3 months. It's got a different pin, a different chip carrier. Apparently, they're using 2 different size carriers, one each 3 months.
Well, one thing, Brian posted a P1V generator. It was kind of a script code for generating custom P1Vs in the P1 forum somewhere. So if anyone feels like having a play, that might take you halfway. But the thought of diving back into Altera right at the moment doesn't appeal. But that did yield working P1V systems.
I remember he had kind of different kind of configuration options. I couldn't play with it because I don't have an FPGA, so I just followed it, but it was kind of neat. And number of cores and
there was an interesting post from Gerald, just posted that Intel had the Pentium 2 on the 130 nanometer at 1.4 gigahertz.
Yeah, they probably did a lot of optimization to push it to 1.4 gig, with what's executing and pipelining and all the rest of it. But,
we might get to, even 800 would be interesting.
I don't know. I think it gets expensive on the test tools. You have to upgrade your Crow and your logic analyzer and everything. So, yeah.
Yeah, the main change I would like to have on a P1 would be that the ROM is also soft loaded, like it is on the P2. That would be really a nice, because then you could kind of overwrite it and use it for other stuff, you know.
Yeah, 64K of RAM and load on power up, just load the 32K.
Yeah.
Well, you don't even have to load 32K. You can get away with 16 or even 4 for that matter, but 16 will get dump out the font because a lot of people don't use the font. You can always load it.
I wonder how much memory it actually has and whether you can't, no, not for P1B. I was going to say MicroPython, but no, we can't run it on a P1B. So, no.
Question MicroPython. How about the Edge with 32 megabytes of hyper RAM or whatever PS RAM? Any plans to support that out of Python?
Yeah, I'd rate it as a good chance over a period of time. You know, it's not the Roger Rodgelow has been working with both the RAM driving side of it, and of course he worked on the MicroPython port. You know, the compilation of MicroPython. So at some point, if we bring those two things together, you know, it's entirely possible that we'll get, you know, start combining these things.
Is Rodgelow the Roger you talked about with the P1B?
Yep. Yeah, he's local. He's here in Australia, and you know, he doesn't do these videos, but we catch up regularly. And you know, Brian and Roger and myself are all here in Melbourne, and Ray's up in Sydney. So yeah.
I'm just looking at DigiKey because, you know, things have really slowed down with what was Altera and became Intel. Intel bought them. I'm looking at all the new FPGAs. Well, not any, I'm just looking at whatever FPGAs you can buy. And it's still, the highest value is still the Cyclone 5A9 that we were last using for P2. Like, they don't have anything better yet. Nothing new has come out that's, you know, has any density improvement or anything. And what happens is these are 301,000 logic elements. As soon as you go above that to 320, let's see now, if I say apply all, the price goes from $209 for the cheapest chip to $764. That's just going from 301,000 logic elements, or 310 to 320. No, it's 301 to 320. So they've had the same best value now for probably like, what, 5 years?
Yeah, because they're concentrating on the top end.
Yeah. Yeah, the top end. Yeah, let's see, if we look at the top end.
How many logic elements in a P1B?
In a, wait, in a what?
P1B.
What's it, 8,000, Brian? 1,500 or 8,000, one or the other.
Yeah, I can't remember the figures exactly. The Nano, gee, I'd have to go back and look up all that stuff. I'm rusty.
We were going to fit 3 of them in a 8K Max 10. So 3 cogs. Oh no, sorry, 3 cogs of a P1V in an 8K Max 10. And you needed the 25K Max 10 to fit the whole P1. So I think it was like 20.
Oh, the same meal on Wednesdays. Thank
Every
you.
other.
Yeah, thanks.
20,000 roughly.
I had 5 P1Vs running in a DE2 115.
Is that 5 cogs of a P1? Basically?
No, that's 5 P1s running in the one FPGA.
40 cogs.
Yeah, 40 cogs.
And that took how many logic elements?
So a DE2, that's 115,000, I think. It was full. So yeah, I'm pretty sure the DE2 is 115,000 elements. So yeah, that's all I could pack in was 5 P1Vs or 40 cogs.
Yeah, that makes sense. That's right.
But it took Cordis, I think it was 2.5 hours to compile it, which I had to do multiple times before it worked.
Yep.
What did
That's
you do
better
with
than the
5
P2.
P1s?
I don't know if you followed that, Brian, but there is some shuttle run for free from, I don't know, Intel, Google sponsored with 130 nanometer. There's a post in the forum about it. It has to be open source, and I mean, the P1 is now open source, sort of. Would be nice to kind of apply for one of those 130 nanometer P1s.
Right.
Yeah,
It's
that would
130 nanometers, right?
Yep. Even for 10 grand, you can keep your design to yourself. And you
And
get
they give you like
100,
20 or 30 chips for that price?
it's over 100. I don't know what it, one of them's 100, one of them's 300.
Wow, so you could get like a very fast P1.
Yeah, I think it's something like the Google sponsors some for free, and you can buy in also, if not open source, for, I think, if you take 120 bucks each or something like that, 10,000, something like that. It's the first link.
At 130, I wonder how, see.
The fabless chip Ignite is the one that's the 10 grand.
So we need a quick starter that runs for a week, right? Is that what we need to do?
Yeah, well, what I'm thinking is, you know, depending on how they set the compiler, they can get huge variance of speed out of it. So you want to push it so you're kind of right at that and right at the knee, you know, where you're starting to climb, but not up here. You just want to go until you're here. And I don't know what their policy is on how aggressively, because it costs them more to make a faster chip because they got to run their tools more carefully.
Yeah, I'm not quite sure how their tools and that all work, because they give you the tools to design it. So I don't know whether you can configure it or what. Basically, you've got to do your own testing though.
That would be cool to have an 800 megahertz P1.
Oh, I think of it as a marketing thing, you know. If Google for free puts a P1, or I mean, in that article standing, yeah, Google might do that because they want to build their own processor and looking for ideas. Yeah, sure, we have some. Well, I would like. I don't know much about this. I mean, I never understood Verilog. I looked at it, but. So
I worked my way through the P1, the P1V.
Well, I just love those things. The only thing is missing that my COBOL is running. So do something, please. Please, Ray. Get CPM running again. I have two different COBOLs, both for Z80, and both kind of hang in the P1 emulator with some obscure stack trace. I don't understand what it says to me. So they are using some opcode which is not in there. And my hope is that what Propeller was apparently more complete, and if you take that as a basic, then yours should be more complete. Then maybe one of my cobots runs. Yeah.
How long before it crashes?
Oh.
How long time-wise before it crashes?
When I start the compiler, it ends up with some obscure stack trace number thing from CPM, and I don't know what it means. I mean, maybe you can I can copy you that somewhere in the thread, and
it's probably
maybe you can know what it does. It gives me just a couple of
dump.
numbers, and I don't know what they mean. So I can't even nail it down to an opcode or something because I don't know.
How long does it go for, or is it almost instantaneous?
Yeah, basically you start the compiler itself, it gives out its starting message, and then it crashes.
So it might not be that far down then, because we can trace it.
Ah, okay.
Are you talking the V80 code? CPM?
Yeah, it's on.
It's an emulator on the P1.
It's running on Cluso's RAM blade, which has 512K and has a CPM running pretty nicely. I mean, everything else I tried works nicely. Microsoft Basic, WorldStar, everything is working, but my COBOL is dying on me. Sadly. 2 of them.
Probably we should do it on a P2. So
Yeah.
I got better tracing on the P2 now.
Yeah, but in that thread, that long winding CPM thread, there was something like if you have CPM running, you could kind of upgrade it from CPM to MPM. Bank switching wouldn't be a problem anymore in the P2. Then we have lots of terminals. And networking.
Yeah, I never use CPM or MPM or CPM3.
You have basic networking. You can basically pip files from one client to another one, which is already cool. No, I really would like to have that running.
I was looking here at for the biggest FPGA now, and it turns out it's a Xilinx part. It's $73,000. DigiKey has one stock.
Wow.
And it has 79.589, or 586, basically 80 megabits, 10 megabytes of RAM. And it has 8.9 million logic elements. Now, the one that we were last using, the Cyclone 5A9, had 301,000. So this is like 30 times that. And it runs at 0.825 to 0.876 volts.
8 volts.
No, 0.825.
0.8 volts.
Yep. Oh, and it comes in a 65 by 65 BGA package with 3,824 pads.
That's a lot of pads.
Yep. And you won't be able to buy it unless you tell them exactly what you want to do with it.
Probably not.
And if they decide that that's a good purpose, they'll sell it to you. Which is why DigiKey don't have stock.
Well, they have one part, they say.
So we can't use it for crypto
Really?
mining, huh?
So Chip, if we had one of those FPGA, how many P2 files we could put on that? 3,000 pins?
You could run about 30 P2s in there.
30.
Well,
There you are, Lachlan.
not with that. Actually, there's about 15 or 16 because it doesn't have the RAM to support everything.
Okay.
It has about 8 megabytes of RAM.
You said that the one that you used last was like 301,000 gates or logic elements. Does a P2 fit in that?
Yep. Mm-hmm.
Yep, with
Well,
a megabyte.
we had to get rid of, we had to like not compile smart pins in every pin, but we did like smart pins in half the pins.
But
No,
1
wait.
megabyte of
I
RAM.
think it did fit because we went from 16 cores to 8 cores. So the whole thing fit again. So yeah, it all fit.
Yeah, that was the biggest mistake in my opinion, but it didn't fit else. But I think the P2 is still kind of 16 cogs would be way better.
What? Way better?
Yeah, way better. Easier to handle.
Well, I think with the way it seems to work for me is with smart pins, they do so much stuff that you actually wind up needing fewer cogs. So 8 seems to be enough.
Yeah, no, I think about that thing with objects and programming, and you just load some stupid object in and it takes a cog and good that you don't care about it because you have enough of them and now you have to care about it. And said, no, we have to run that inline, and I enjoyed on the P1 the ability to just give a task to a cog and done. You know, it's out of my mind, and I know it's there, and I can talk to it in good co-processors. You know, that is what I like on the smart pins. It's the same thing. You know, you kind of set them and go, and that's why I look at you after a couple of days, hours, minutes, whatever. And now you basically have to cramp stuff like Arglo does here with Roger with this video driver. He is cramping all the drivers into one. Oh, you have to fill a cog to use it, really, you know.
Well, you also have the balance of cogs versus RAM, and we used to talk 128K of RAM. 512 is really nice.
Yeah, if we had stuck with 16 cogs, we could have only had 128K bytes of RAM.
Yeah, that wouldn't be nice, no.
No, we need that RAM is really important.
Yep.
But if we could get to a smaller process, we could put a lot of RAM in. I mean, several megabytes.
Yeah, we just need to sell 10 million P1, P2s right now.
Right.
Around 10 million of them, and then we can think about 90 millimeter nanometer.
Oh yeah, if we sold 1 million, we'd be there.
No. Don't tell that kid again.
Well, he knows. He knows better than I.
Yeah, probably.
Yeah, the question is 1 million over what time period, Chip? You know, over 20 years or over 5?
The next 12 months.
Before we're dead.
2022.
2022, yeah.
Yeah, just over 2022. Now, what's that killer app with all these IOs, Lachlan?
Well, it seems like things have gone to like more distributed and fewer pins.
I reckon that's all the problem with the FPGAs of what we want to do with it. We don't need all those pins. We just want an easy to use chip with a with a decent number of I/O pins.
Yeah, but we have that. I mean, I'm pretty happy with which came out after those 10 years show. I mean, it was kind of my weekly, daily, my soap opera.
I think Michael's right. I think if you were able to put the P1 together and get it in that shuttle run, it could get you some
attention,
notoriety, especially if the thing clocks at 800 megahertz and works completely. That would just.
You'd have to kind of know. You'd have to send them the file and then have them synthesize it in their system and tell you what the clock speed could be. Without that knowledge, it may not be worth it.
If it's free, it doesn't matter.
I think so. Yeah. I mean, somebody who knows how to do that should try it. I mean, I don't even know. I wouldn't know how to do that. But I find the idea very fascinating.
I don't know whether they've got dual port or quad port RAM, but that's one way to boost it up in speed. The other thing that was interesting in the P1 was to reduce the 16 clock cycle down to 8 for the hub RAM.
Mm.
And one instruction to do the emulation when you run LMM.
Mm-hmm. Yep.
And I think we got that working.
Yeah, Brian has some kind of configuration. Tubular told me, and I remember reading that also. Somewhere deep down in this thread is that configuration to how to build the FPGA image out of number of cogs, number of RAM, number of. Was pretty neat. Kind of couldn't use it because I hadn't had the money for it, but it was very nice.
It was ahead of its time. I think they use this MeGen or MyGen language now, for scripting stuff like this together. But for Brian, it probably just brings back headaches. I think Altera. He used to have more hair. I remember. Yeah, that's right.
Yeah.
But yeah.
Yeah, I still have nightmares about Quartus.
Sort of like a 3-hour lottery. It'll sit there for 3 hours, and it might. The worst thing is it might actually spit out a design which mostly works or partly works, and you sort of have to test it properly. It's not good enough just to yeah. Because I remember a few times, I think we had a login prompt or something, or there was a what came up. There was like it seemed to, and then it froze. Oh no, that was MicroPython. Yeah.
Yeah, Quartus does some weird things sometimes with the allocation of the I/O pins. And you get weird things that half the I/O pins would work and other ones wouldn't work properly. And sometimes,
you got to nail down. You got to tell it what you want where.
Yeah, yeah. And if you weren't specific enough, it would do some weird things sometimes.
I remember one trick. Yeah, sorry.
There was a lot of switches and things in the background that you had to make sure you had right. Yeah, and the difference in compiles, sometimes you might add half an hour just by turning one switch on.
But that was old hardware too, right? Nowadays on Horizon, you could do it in half an hour maybe.
The problem is they don't take advantage of the extra cores. I fell into that trap. I put in extra RAM and got a new laptop that was faster. And I think if you pay the big bucks, the $3,000 license a year, it does unlock some of that facility. But the free one, I think it doesn't really take advantage of any of the good stuff. But it's quite an intensive thing, FPGA compilation. I don't know many systems that are very fast. You walk away and have a coffee or a beer and come back. And I don't know whether things have changed now with AMD's bought Xilinx. So, and there's a lot of questions as well, what are they up to? Why are they jumping into the FPGA world? So Intel didn't do anything with Altera, so who knows what AMD are up to.
Yeah, it was so weird that Stratix 10 was talked about for literally like 6 years before it seemed to be available. And they were using Intel's process, and the whole thing was so clustered up and they couldn't get it fixed. And eventually Intel bought Altera for, we're hearing 16 billion. And then they have these chips now, but they're like at least 20,000 bucks.
Yeah.
And I'm looking still. Turns out Microchip is making high density FPGAs now.
I think they bought Actel or someone like that, or Micro.
Oh, lots of consolidation.
I remember laying out using the first FPGA back in the 80s, and I configured every logic block by hand, and I routed the pins by hand all through the gate array so I could get my timing right.
Well, yeah, that was like assembly language for FPGAs.
Oh no, it was clicking on the different pins in the FPGA, and then you could print the whole thing out.
Yeah.
Was it an FPGA proper, or were they called GALs back then?
No, it was proper to the XC2018.
That's a Xilinx.
I had to interface to a mini computer motherboard, and I decided to use an FPGA because the motherboard bus signals were not specified. So I knew roughly what speed they were running at, but the logic wasn't completely specified.
Hey, Brian.
So I did it. Sorry.
Didn't mean to interrupt. Go ahead.
Go ahead.
Hey, Brian, did you ever play with any port B stuff on the P1V that you worked on?
Yeah, that was the first thing that I think everybody added in, was adding port B. That was a fairly easy addition. Yeah, and then from that point on, then we just started going crazy and adding extra hub RAM and tweaking things. In fact, I think Roger, he found that in the some of the hidden cycles, he was doing some extra video stuff. He added some extra logic in. I can't remember exactly what he was doing, but yeah, he was playing with things in the background as well. Well, we all sort of got very excited and we all went different ways. But yeah, port B was probably the first thing that most of us did.
Then the P2 hot hit the scene, and we stopped.
Yeah.
That would be cool. With 36 pins, you could have 4 pins on port B, and you can do BowNet over those to connect a whole slew of them together. You guys ever play with BowNet? That's what I call it anyway. It's Bo Schwartz or Bo Schwab made a protocol to talk propeller to propeller.
Oh yeah.
By unwinding a loop and sending 32 bits. I think he was able to get 14 megabits on 2 wires on a P1.
Wow.
Yeah.
Bo had that. Am I muted or not? I don't know.
No,
Bo had
we can
that
hear.
nice thing, hyper fast transfer, and his basic idea is to transfer one buffer of half entering from P2 to P2 and then back to the first one. And in that buffer can be data or mailboxes or whatever, and on the end you basically can use a mailbox of a cock in another prop because they all share the same hub RAM. You just have to make sure that just certain right in certain positions to not kind of. I'm trying to build something like that for the people too, but I'm kind of stuck with other stuff right now. But the basic idea is that on top of hub RAM is kind of an area of RAM which gets circulated through all connected propellers at very high speed, and each propeller has a short time where it can take a lock, change something, and release a lock and release a buffer to the next one. And the buffer is circling around at fast as possible, but for the programs, they can write into the hub location, and that hub location is shared between all other props, sort of. And so you can connect lots of them in a ring.
Yeah,
basically the idea of Bobo's high-speed driver.
They didn't have to have the same clock either. The protocol was specified to have like 5 parts per million typical.
Yeah, it is pretty. Bobo did a pretty nice thing there, and I'm trying to. I failed to do that with them streamers on the A board, and the B board now doesn't want to talk to the A board because they have different commands on the streamer commands, and I'm kind of stuck right now. I need a couple of edges. But I wait for the edges with RAM.
That might be something you want to look into, Lachlan. If you've not seen BowNet, it's pretty slick protocol. He unwraps the loop and just runs it at full speed. I think it's like 7.3 megabits per second
On the
per
P1,
wire.
yeah.
And yeah, twisted pair. He does differential signaling on twisted pair in like 30, 40 feet, I think is what he tested. So if you got a real tight stack, you could run your packet length up. You're running the same clock, so you don't have to have your packet short so that you're.
On the P2, I could go to this clock 2 with the screamer, and this clock 1, it failed. But this clock /2, I was able to transfer with the screamer, and that was before Chip put in that there is one streamer mode using external clock. I haven't figured it out yet, but he put it in for ADC with external clock. But if you switch,
Oh yeah, that's just a smart pin mode.
right, and if you switch off the ADC bit, then it takes the pins directly, and then you can basically stream in data with an external clock.
Yeah,
But I haven't figured out that yet. But you told me that it will work in one discussion. So, but I haven't tried it out yet. But basically, the external clock ADC mode with ADC off should stream in from the pins. And that is basically what I try to yeah, if I have some RefC chips. But it should work, in my opinion.
Yeah. Talking about that kind of problem, I'm not sure, but into the synchronous transmission mode, each pin can be clocked by its own bit at out register. Is that true?
You mean so?
Because the B pin can be routed to the out pin that comes from the cog.
Yeah. So you could do that.
Okay,
Yep.
so you can hide completely the clock for each pin and clock as many synchronous channels that you want. The limit will be half the system clock or a third to transfer.
I think it's, well, in the synchronous modes, I think it's a third.
Yeah.
I'm
A
not, I don't
third for
remember.
transmission, a third for transmission, and a quarter for reception, or
Yeah.
a third for both.
Let me look. I don't remember.
Neither I couldn't understand all the implications.
Yeah, let's see. Let me go read that. I did figure this out when I documented it.
So the normal serial asynchronous communication I could run up to this clock 3 with and then I got errors.
In fact, you can send as many synchronous communication channels as you want, using the outbit from the cogs for each channel to control the clock, to then simultaneously. So you can use the cog or a streamer to do the clocking, and the cog to load the 32 bits transfer register. And you replicate the clock you want in only one pin, just to be synchronized to the other, to the peer, to the reception peer, for example.
Yeah, but what Tubular is talking about is kind of the possibility to give all them propellers in the same stack, also the same clock.
Yes,
Which would make some things like asynchronous transfer way more easy, because you don't have to have that phase shift problem, or not as much, say, because I mean you have still the PLL and you have still kind of jitter in between those chips, but you probably sit pretty in with short wires. I think then you might can go with a streamer or with to this clock one transfer per this clock, which is possible in theory. You know, the Aglo is doing that with a hyper RAM already. I think writing he can, but reading not. One is one. This clock.
Yes,
one,
because
one
the hyper.
two. And it's to hyper RAM, you know, and so one of them you can push up to this clock one to this clock, and the other one half of it. I don't know which is what reading or writing. One of them is lower. And if you prop to prop and the same clock, you should not run into that phase shift problem, I guess. I mean, I'm working on
in fact, to be sure you can transfer from one P2 port to the other, the best arrangement for the clocks is one clock is inverted in relation to the other. Yes, because you can be sure for the hold time and the setup time of the data before the clock edge. It's way better. It's way better than you try to transfer.
I have to think about that one, yeah. Putting an inverter in between. And I mean, it also pushes the clock. Yeah, I mean, you don't have so much load on one clock pin. You have an inverter in between, which pushes it up again.
I've been looking.
Please go ahead.
I've been looking at the asynchronous transmit and receive, and there's no word in here about what the maximum bit rates are.
The asynchronous, the asynchronous.
No, I was looking at synchronous.
Synchronous. I believe it was 150. Oh, no. This is USB. The synchronous is limited by the propagation of the signals through the flops until they reach the cog.
Because right, you have those delays. You have those delays.
Signal.
You have those delays.
The clock signal to propagate. So you need, I believe, you need to limit to a half or a 1/3 to the transfer. But the reception, I believe it cannot be synced to a hub. So 1/3 or 1/4 of the clock rate of the processor would be feasible.
Also I did run serial up to this clock half, but just without any wire. I mean, pin to pin internal. I'm reading my neighbor. So in one chip, one clock transferring, one clock sending, and I'm reading the same pin. I could go up to this clock through divided by 2 for I think for normal serial, and two stop bits. I needed 2 stop bits. And the other stuff I got running on the A version, and then Parallax sent me 2 B versions, and then none of my code run again anymore.
Well, yeah, the A is the old stuff. It doesn't work with any of the new tools or anything.
Yeah, the A boards are now, I don't know, I have to find a job for them. With FlexBin version, with one of the FlexBin versions I have, I still can program the A board.
It's a collector's item.
I have 3 of them. 3.
In 40
B's.
The A's will be a collector's item in 40 years' time. You might be worth $1 million.
When I'm in my grave, I don't even have children. My cat can throw them.
You should probably send them to Chip and have him sign them.
Yeah, I should have brought them with me when I got all the stupid wood. Sign this. I need an autograph, Chip.
We made the mistake, Chip. We should have had your signature on the bottom in silkscreen like the Johnny Mac.
They actually Chip made the mistake because he wanted $15,000 for the wood and not that nice Chevrolet Le Baron.
You mean one of your cars?
And that one you saw the pictures of. The
Chrysler LeBaron.
The white LeBaron, yeah. I mean, that would also, we can switch.
Yeah, let's see.
That's too late. You already spent, probably you don't have access to that money anymore. You gave the check to your wife. It's done.
I think we deposited the check.
Yeah, you got it. It's worked out and no problem.
Hey, Lachlan, I got a question on your 8 board or 8 board array. Yeah, that one.
Yeah.
So you said you boot them sequentially. Do you boot one from the next, or do you have a master prop that you use for that, or how do you boot them?
Brian can explain. He's written the code to load it up, so it's really since Brian's back, he can answer the.
Yeah, so there's one prop plug or USB converter on there, and that's connected right across to all the boards, and they all just listen in, and each board's got a unique ID number, which is just a combination of pins tied high or low. And when I've got a special loader that I can send out individual files to each board, or they can all get the same code. It doesn't really matter, and I can flash them as well. And yeah, so basically the protocol's already there, built into the chip for individual loading, and all I've done is just made a loader that that does that. So there's the one communication channel into all the boards, and because they have a unique ID, they just listen in and they respond when it comes to programming them. And when it comes to the software that they're going to run, well, that's another thing again as to whether they talk to each other or not. But it's that sort of thing. It's fairly easy. And once again, because each board knows its own ID, you can.
How do they talk once they're booted?
Well, once they're booted, it depends on what software they're running, because they may not all be running the same software. But if they did want to talk to each other, simple serial protocols is another way of doing it. It depends on how much data you want to send. Like in what Michael's case, where he's talking about a buffer that's sort of common to them all, a circular buffer, you could do that. But there's other ways that you can make them talk. But once again, it just depends on how much you want to share between them. Some of them may be independent and just doing their own thing. But the idea was that if this system, for example, if it was in a rack and each item you had in the rack was running a P2, rather than individually pulling them out and having to program them to update their firmware, if you just had a single channel on there, then you can update whichever ones you want and leave the other ones alone. And that was the idea behind the loading side of things. So,
oh, I see.
Yeah.
So
It just means that
to put Brian's words a little bit shorter, in the boot ROM, there is basically a setting that you can send a mask out of 4 bytes, and then just that propeller, which pins are tied low or high to that mask, will react on that boot signal. So if you send the 000, all props will react, and if you send the mask first in the boot protocol, just one of those chips in the chain will kind of load that program. I mean mask, so you can basically say 2 of them get that program and the other don't or so. And you have to leave out the lower 2 bits because they are not they are changed in the boot process. But basically, when the processor boots and gets the serial data, the data contains the first 4 bytes, say it's for you or not. That's built into the ROM in the booting process. So you can address each chip by pulling some of the pins down and some of the pins high and say, okay, this is your base address. Don't react on anything else.
So since you're doing 4 bits, I'm guessing your goal is to hit 16 of them?
No, all 64 pins. It's no, I think.
Yeah.
Yeah, it's all 64 pins. Yeah, you should leave out one.
I mean, have 16 different props boot off the same bus.
Oh, there's way more. You can put way more. I mean, you have 64 pins. The mask is what?
Yeah, well, you would have
1, 2, 3, 4 bytes. It's too long. 32 bits.
Yeah.
So you can.
Ryan, what'd you say?
You're limited by the physical hardware. The software is capable of using the 60 or 58 bits as a mask. So, you know, if you could have 1,000 P2s physically and electrically, well, the ROM booter can handle that.
Yeah.
And your design is to maximize on usable cogs and usable pins after it's booted, I'm guessing?
Yeah. Okay. Yeah, well, in the application, that's also a not so much a limitation of the pins. It's also maximizing the grunt we've got in each P2, so that the task can be split up, basically. So, yeah.
I've thought of a design of booting one prop off the next, and the prop plug would go on the prop 0, it would boot prop 1, prop 1 would boot prop 2, so each prop would have its 2 pins talking to the prop plug and the reset pin on the prop plug, but 3 out to the next prop 3 out.
And the problem, basically, you don't need that because you can address on the P2. When you are sending your boot file, you are addressing a certain prop. If you do 000, you address all of them. But if you take a certain number, you address just a group of them. The problem is basically that you have to reset all of them at the same time, because or you have to run a reset line to every prop. But basically the prop can, out of 2 serial lines, each of them can say, okay, I'm number 127 and I take this package and boot from it, and the other ones ignore it.
There's arguments for both, Doug. Douglas, you can have that, that sort of parallel bus for the transmission for debug and stuff like that, but also have individual P2s talking to their neighbors locally, and you might have like an 8 wide bus or two pins across to it or whatever for the neighbors. Are you able to talk more about what you're doing with the CubeSat? Is that your own project, or?
It's just a project in my head right now. I was planning on doing it on the P1 and never got around to it. Now the P2 means that I kind of want to implement something similar to BowNet, or similar speeds at least, and with the streamers, which I have not figured out yet. It's kind of something I need to learn. With that kind of bandwidth, if your props have to communicate anyways, you're going to use some percent of a core or a cog to do it. And if you want to maximize pins, you got to boot off of 2 pins anyways. 3 more pins to boot to the neighbor in a ripple fashion. Once it's up, you've got a high-speed ring, and you don't have dedicated pins for booting at that point. You change protocol on the 2 pins you boot off of, and now you've got your high speed.
Yeah, sure. You can kind of daisy chain them like this, that you have 2 pins coming in, 2 pins coming out, and that will then sort of boot the next one. And then you have kind of dedicated communication between neighboring chips. But the protocol chip did for the boot is that you have just 2 lines connecting all of them, and you pull up or pull down pins on the and send while booting, if he gets a boot message with a code in there, it checks its own pins and boots or doesn't. And if you send a 0, all of them take it, So that's built in the protocol, and you can boot all the processors, but you have to reset them all also. So that's kind of stupid in my opinion. I haven't found a solution for that, but basically maybe a shift register where you select the chip, and then this one gets reset while sending the file for it,
You need to have like some kind of out of band thing, Michael, like modems used to have +++, to get into the escape kind of mode, and then you could hang up the modem or do whatever you needed to do. And so you can do it over serial and just
sending a break or a serial to, but in that point you have to have software running already on them. No, what I think is maybe, say your 8 propeller board here, you put a shift register there and you shift in the one you want to reset. The other one can run perfectly. And you just reset one of them and send him his software.
The other thing is, if you've already tied up the SPI pins, like with a local flash or whatever, after that flash is read and booted from, your serial out can connect to the next props serial in, and as long as you're holding the chip select high, you're not going to get the flash memories affecting things. So.
Okay. The flash memory is sitting there also. Oh, yeah, I see it. Yeah.
So you could share. Effectively it's just an SPI bus, but instead of having a slave device, you've got a slave neighboring P2 or 2 slave P2s or whatever.
Yeah, my intention is also like yours, to have not just 2 of them connected. I want to have more than 2 connected, kind of.
Yeah, if you could run, if you did use, if you imagine SPI signals, the serial out around a ring going clockwise and just connecting and looping through all the, you could loop the thing around a ring in a clockwise direction, and it's just the serial out of one connects to the serial in of the next one. And
yeah, the basic idea with that ring buffer is that basically you have a part of hub RAM which you dedicate to that transfer, and one cog receives it, unlocks a lock, and allows kind of programs to write in it in the time where they want to write, and then he locks it again and sends it to the next one. And programs who want to write in that common hook buffer have to kind of acquire a lock. If they can get it, they can write and they can release their lock. So that you have a clean buffer basically, but it's running from chip to chip in a, like token ring. I don't know. It's and it works pretty good. You just have to lock every write access to the common buffers, or say, okay, you guy can just write from this address to this, you guy write from this to this, and then you don't need any locks. But even if it's completely shared, you just move it around in the ring, And that allows basically to have, I don't know, Kai's fat driver sitting on Propeller 4, running on a mailbox in that, and you can from Propeller 1 just write in your hub address, get me a sector command. I mean, it's like having the same mailboxes on this, it's like having all the cogs in one. They have one common mailbox, sort of, mailbox area, data transfer, and it runs around. Works pretty nice, and this is what it's not my idea. Bo did that. Bo Schwabe, kind of brilliant. It was working on P1, and I'm trying to get it running on P2 with a streamer at this clock 2 or something. It doesn't want, not yet. But it's a basic brilliant concept. What Bo Schwabe had there, that you have that circling area of hook buffer, which is a common mailbox for all of them, and each of them gets it, unlocks his lock, that other tasks can get their lock and write into it and release, and then he locks it again and gives it to the next one. That one locks it, unlocks his local lock. All processes can write, which need to write, then it locks it again and sends it farther. So it's one buffer circling around, not a constant stream. But that one is pretty solid as a concept. Reading is not a problem at all. You don't need to wait for a lock. You have the last thing sitting there. But every time you write, you have to get a lock. So you write in the current transferred buffer. That can run with 2 bytes, 3 bytes, 4 bytes, whatever the streamer gives, and however lines you give it, you send that stupid buffer around.
In the case you need to reboot one of them in the middle, you just talk to its master, which should be like counterclockwise.
If you have that ring buffer, you can maybe issue a reboot command.
Well, you would talk to its master, right? Which would be like one clockwise or counterclockwise in the ring. Tell it to throw the reset line and boot it new code, right? If one boots the next, I mean, at the end, you take the end one and make it talk to the first one, but obviously not set the reset on the first one. But each, you don't need to tie up pins.
That's a
and pin
completely
IDs.
stupid idea. One byte in the buffer is kind of the reset bit. If you see that bit set, reset yourself. Yeah, I don't know. I was thinking about one master prop giving kind of the reset signals to all the other ones, something or a shift register. Yeah, but basically, I also want to kind of get in groups of P2s talk to each other, because I think if you get something in there, that is why I posture. No, kind of poke him. I poke him so as to get at least that CPM running. Then we can have, maybe you can install bank switching and NPM, and then we have a real network running on P2. Yeah. The other thing is this Plan 9 file system, which Eric is using in FlexBin to connect to the host. If we could kind of build a Plan 9 file system server on a P2, we could set up kind of a file server. SD card, Plan 9, everybody can access it. Everybody has a different serial line and they connect to that thing and can use the Plan 9 support in FlexBin, mount host. That would be also nice. A file server in P2 for the Plan 9 file system. I'm looking at it, but I'm not good at C. I don't understand much of it.
We're kind of just watching the space. MicroPython, the developer of MicroPython, Damien George, he's working on this MicroPython remote sort of thing, which is a little bit similar to what Plan 9 does. Yeah. And we're just waiting to see whether it, gains some traction or whatever, because maybe it makes sense to adopt that, or maybe it makes sense to adopt Plan 9. Or for the moment, we've got what Brian wrote with his sort of file system, which makes it easy to work with flash chip, nice lightweight kind of solution. But long term, I think we're just watching what happens with both LittleFS and the MicroPython remote kind of thing, which gives you access to your PC's file system somehow.
Yeah, what Eric is doing is he is using the serial channel to access host, but in his software he just said mount host file, a kind of folder, or mount SD. And the rest of the software is basically, it's not working in Spin, but it's doing it in BASIC and in C. So it's not a problem to use. Brian is doing that Flash file system in the Flash, which I also already like. And it would be nice if we could kind of integrate it that in MitoPython and in Python also, that Flash would be one device, host would be a second device, and SD card would be a third device, but everything is kind of used after that with the same syntax, sort of.
It's not necessarily an either or thing, Michael, because Brian's file system lives entirely at the P2 end and with the flash chip there, and you kind of send the commands over the serial. The Plan 9 thing is also done over the serial, but it's back up to the host, and so it's your host that's recognizing a command sent to it, and so you've kind of got one, you're sending commands one way down the serial pipe, and the other one is sending commands the opposite direction. And you can have both, of course. You could do we'll write a copy utility so you can copy files back and forth or something, but that might not be stupid to be able to just copy stuff. Use Eric's Plan 9 system, which is obviously based on a formal system, documented system.
Right. Yeah.
I'm not.
Basically, I think it's kind of he has had some C implementation and took that, and since his multi-language compiler is able to handle, he basically adapted it that BASIC is doing it also, and he hasn't had any plan for Spin now how to integrate it there, because the Spin language doesn't provide any file access,
That's fine, but it's just a cog. I mean, you just have to have one cog running Spin and one running.
You have to put an object in or what,
Yeah.
Yeah, but what I would really like is that the way people store things, that file system of Brian he did for the Flash, which is actually that what Python is using. That thing should be available as an object for Spin or something, so that I could access out of Spin the same files like you can do out of MicroPython. So we need some sort of a Spin driver for the file system for Python.
What we need is really the killer application.
Allow I start that Python thing and I boot back into my, like he was closes up. I mean, we can start MicroPython, run MicroPython, get back to the OS, get back to the Spin, whatever. So,
But Michael, you have 8 cogs, you have 8 cores, and they can all be doing whatever suits at the moment. And so, you can have the MicroPython plus a couple of extra cogs looking after the services. In other cogs, you can call from MicroPython, you can load up other cogs which might be running, Spin or C or whatever it is that
you can do that?
Yeah, so we can load inside MicroPython. We can start up an additional cog. There are spare cogs, and so you can just have another cog which is running.
So I can start out of MicroPython. I can start a Spin binary.
Yep.
Oh, cool.
Yeah, Spin binary. So at least at this stage, just the Eric's Spin binary compiled code.
Yeah.
But yeah, you can do that. And Eric put this feature in, and Roger, Eric and Roger discussed this ability to package up a binary and spin up an additional cog, from inside MicroPython, both on Eric's MicroPython and the TeamOz one. And so it's in both those flavors. And you can just set a cog running. It's more, we've used it more for maybe assembly, some kind of peanut compiled kind of cog. But you can do it from Eric. In theory, you can do it from Eric's software,
Oh, cool.
So if you want, you could combine, the best of both worlds, and you can have Eric's and Plan 9.
I'm doing that. I'm doing that currently. I'm currently delving into that BASIC he put in there. So that is so cool. This BASIC is absolutely cool.
How many cogs are used up by MicroPython itself?
It depends on how you look at it, but sort of 1 to 3. It's one main cog, but it needs some support, or benefits from having some supporting cogs. So I'd say 1 to 3, Brian, 5 if you want kind of video and keyboard and everything. That kind of range. But if we really had to, we could probably compress things down.
Yeah, in its bare form, it just uses 1. But if you want to use USB keyboard and have video and Flash, I think it's 4 at the moment, but you've still got at least 3 spare anyway that you could fire off to do something else. And in its raw serial format, it's just 1 cog.
And does the editor and everything fit in 3 to 5 cogs?
Yeah.
Oh.
Yeah, this editor is cool, Brian, what you did there. That the editor which is run, and I'm talking about Moo or whatever, I'm talking about that one you showed, which is running on the P2. That's honestly already a nice editor. I was impressed of that demonstration.
Yeah, I must admit I haven't looked at it for a while because I've been busy doing other stuff. But
yeah,
Yeah, that
Yeah,
was
but you
quite
came pretty far there. I mean, with block marking and copy and all that. I mean, it looks pretty nice. I was impressed that I mean, being said kind of something like Eplin, I mean, it was not really great. It's really a nice editor already. Yeah.
I can't wait till Chip gets going on whatever he's got planned for system
Yeah,
containment.
we have to get Chip to accept that he needs to accept software of other people, which he doesn't like usually. So probably when he will build some debug driver on a P2, he will build an own video driver instead of using Rogers, which is the best we have and which is really nice. Chip is not really good, and he wants to do everything by himself, which I also appreciate. I mean, it's it's I appreciate it. On the other hand, it's wasted time, but it's like
Yeah, except that when you do things yourself, you know what's going on and you can trust it.
Yeah, if you reinvent a wheel, you know why it is round.
That's why I don't use Microsoft hardly at all, right?
Yeah, I mean that VS Codium thing is not bad. That open source. I mean, I'm bound to Microsoft since I don't know 30 years. And if you have a full version of Visual Studio and work with that since decades, you have a perfect programming environment. And that VS Codium is the only thing what barely, what is called Visual Studio Code, that is almost as nice as a really Visual Studio, I mean, I could go for that. But else, Visual Studio is kind of my bread and butter environment. And it has so much nice features daily use. If you have one thing where your family, it's with your wife, you don't kind of exchange it against some Codium. God, I'm here. Look at this. I have one stupid cat sitting on me all the time. 8 weeks old, and I kill it pretty soon. Pretty soon I will kill it. It doesn't leave me alone.
Hey Chip.
Yeah.
Have you done anything on? Let's see what we were talking about. Building a standalone, Peanut, I think in on the P2 or
I started it, but I didn't continue it. I mean, I know it's viable, and it would grow the spin language in some ways because as you write a compiler, you start to need other stuff, extra things you wouldn't think of. So I kind of want to do that. I mean, I really want to do that, but the plan hasn't congealed in my head yet. But I'm thinking that just working on the chip without it being connected to the internet actually would be a huge benefit because you wouldn't constantly be distracted by all kinds of things. You'd focus on what you're trying to do.
Yeah, that's my biggest problem as well. Distractions. I've got too many things to handle as it is. It's nice to be able to shut off everything else and step away.
Right.
Power up a system and you got a ready prompt. Even if you don't like BASIC, you can do something right in seconds.
Yes. Yeah, we're drowning in distraction these days, so it'd be good to get something that kind of works, and stands alone. And anyway, yeah, I'm thinking about it. I'd like to do it. I'm also kind of bouncing around lots of ideas about how to integrate graphics into the programming so that it's powerful but not binding, or like it's not constraining. And you know, once you make your own tools on the chip, you can use ASCII and color and shapes however you want. You know, you're
And
not
that's
bound.
the reason. That's the reason, Chip, why I think that you should start with them debug screens on the P2 using
Yeah.
iGross driver. I mean, you don't have Windows; you have just Tribes. But basically, you could do all the things there, and then you have kind of a feeling for it, how to put in kind of a development. But putting the debug first, all the debug output. I mean, it would also help all those Linux guys that just need another P2 Edge and
Yeah.
a prop plug. Parallax has to sell some stuff for, I don't know, $50. Prop
Right.
plug and
Yeah.
extended prop plug with debug.
Yeah, Chip was in the middle of a thought that I kind of wanted to hear.
Oh, I just need things to kind of, I've been waiting for years for the picture to congeal. I mean, if it suddenly came into focus, I would drop everything and just do that. But it's like I've been feeling around the exterior of it for a long time, but I can't get into the middle of it. And I don't know what I'm looking for exactly, but I'll know when I find it. It just has to occur to my brain.
Do you? I have a real hard problem when I program in other languages. I forget the syntax of other ones. And I have a hard time switching between languages. Do you have that problem as well? Like if you're doing Delphi or x86 code, do you have?
Not really. I spend so much time in each one that they're kind of like their own little sandboxes, you know? So I don't really, but I know what you're saying. I mean, if I was, but I don't know. I haven't had that problem.
Okay.
But I do notice, you know, I'm getting a little older. My brain isn't as fresh as it once was. So it takes more effort to get things done. And I kind of like temper my ambition with that.
Yeah, I'm probably about the same age. And I'm having
Yeah, I'm 53.
Similar disappointments.
Yep. But I'm waiting for the idea to settle so I'll know what to do. But the thing that bugs me a lot is, I mean, the world's becoming about interconnectedness as far as like everything being networkable. And I understand why you'd want that, but I've never really liked that. From the first time I got into computers when I was 11, I liked the computer to do and control things. I didn't really care about bulletin board systems. I had a whole bunch of friends that were into computers. In fact, every other computer friend I had, they were all about BBSs. And to me, that whole communication thing was never that interesting. And I think, and now that we're older, I see all that communication does is it like pollutes and compromises a lot of stuff and just it lays traps. And I don't have the enthusiasm for it that I should have in order to be able to integrate it.
Right. Yeah.
Yeah, I value the internet a lot, but I like to be able to disconnect as well and still have computing power. I mean, I don't understand how people can put their development environments, their calendar, their contact list on the internet, and then what? They just totally become a fish out of water when they can't get to the internet.
Yeah, I know. It's like building a house on sand, you know, and yeah, but on the other hand, I don't know. Sometimes, who knows? Maybe if it all just got deleted, life would be better.
Yeah, and another thing, Chip, you're always talking about a separate development environment would need another screen. I mean, all those screens I have multiple HDMI entry plugs. So I could plug in a Propeller and my normal computer, and I could switch in between them with a button on my screen. It's not that complicated.
No, you'd have to get some A/B switches to go.
Or yeah, I mean, yeah, maybe there are still those K4M thingies. Keyboard, video, monitor. What was it? K4M. The massive switches where you can switch computers between your only set of keyboard and mouse and.
Yeah.
So another thing would be that on that on that new prop plug with development, that there is a plug for USB mouse and keyboard, and on the other hand is a USB out and keyboard out for the original, and you can switch between your screen and just. We basically need the opposite. We need a mouse and keyboard which we can reach through to the computer.
Right.
Didn't Plan 9 did that as well? I think, Michael, it's just not something Eric's tackled. Doesn't it have like that kind of functionality? I think they envisage doing that kind of stuff over Plan 9 as well.
I'm not sure about that one, but that would be nice. And this
Or maybe that's what became
really good.
Maybe that was what became X Windows or something. I'm trying to remember the.
X Windows came out of MIT back in 88, 87. I used it in 89. I used X10 before X11 was out on a Sun workstation.
Okay.
It was just starting to replace, or we were just starting to replace Sunlook, I think it was called, with X Windows. And those were 68020 machines with 4 to 8 megabytes of RAM. So
Okay. At the time, yeah.
Chips 32-bit or 32 meg Edge that hopefully be out soon.
Yeah, and you know, with good practice, you can get a lot of use out of 32 megabytes. I mean, these days,
definitely,
kind of squandered.
As long as
it's just weird. When I was a kid, I looked at computers and I imagined where they'd go, and they basically turned into like a TV or something, you know, with all kinds of controls that you don't control. And it's not as fun as I was thinking it would be. But, and then the weirder part to me is it seems like there aren't that many people that desire anything fun. They just want more of what they already got. So I think I need to go to like another planet or back in time.
Yeah, we are preaching to the core again.
You get along well with 8-bit guy in his group. I agree. I like to be able to get on a Zoom call and watch videos, but at the same time, I don't trust it. I'm booted off of a Xubuntu thumb drive just because I'm not going to install just some company's.
And that is exactly the reason why we need that, what Chip is thinking about, getting away from those, I need to protect my computer because I don't know what is running on it, and having something which you know what it will work in 20 years also. And that is, in my opinion, the most important point on that self-development system thing. It is independent of Windows updates, Linux updates, Mac updates, new browsers. If it works, it works. Okay, it needs a monitor, and well, they stopped doing VGA, then we have to do HDMI. They stopped it. We can do, but it will still work. And that is, in my opinion, the main point for even if I have to disagree with Johnny Mac there.
Yeah, certainly industrial customers need stability. I mean, what they pay to maintain all these things they're using is astronomical.
Right, but we need that on top of multi-platform development, which we basically have with Eric. I mean, it's there. It's not parallax, and that is what customers kind of complain. John said, "Oh, well, should be by parallax," and it is not. It's somebody, which I really like, but anyways, it's somebody, you know. And parallax tool are not running a multi-platform, so maybe you should check in the new Delphi, because the newest version of Delphi is multi-platform. And so maybe you can run your Delphi code on a newer version of Delphi. Spend those couple
The
of...
trouble is we've got all kinds of x86 code.
Newest
that
version
works
of Delphi runs on Windows, Linux, and Mac. The actual, not the newest, they are doing it for a while now. So if you maybe upgrade to a newer version of Delphi, then maybe Prop Tool would run under Linux. I mean, I'm just asking. Give it a try.
Why not, instead of, you know, diving deeper into the dependency, why not just go for a development environment on a Edge 32?
Well, yeah, that's
You know, a light front end, like a terminal.
Yeah, it's capable of handling.
Yeah.
all that.
And then you could do a light front end on all the platforms, whether it be a cell phone, a tablet, a Windows, Linux, Mac. You could just have a light front end that knows how to colorize the fonts, has the parallax fonts, has the F.
No. Wrong. The editor has to run on the P2, not on a PC.
No, but he's saying
the problem is that
but some people are tied to the
rid of
PC. You can have multi-platform and have it all on the P2. You can have your interface on the P2 too, but you know, a lot of people are like have to run it on the desktop in front of them.
Basically we need
I'd rather have it on a P2.
What we
But I still would
basically
like to be
need
able
is
to
a command line compiler running on a P2. So you are copying a file or whatever material, you are copying a file over, it gets compiled and runs. That's the first step. The next step would be an editor and IDE. But first we need a compiler running on a P2. And any Windows program, any Linux program can send files over to that compiler thing, and it gets compiled and run.
You know,
they are sending text files instead of
I've been thinking, Michael and Douglas, about this, that, you know, as we add things to like Spin, we grow the language, we add in more stuff, it's all helpful, right? It's a shortcut. But it's also more that the user has to know about in order to use. So we keep expanding this wavefront and it becomes more and more complex. It'd be interesting to do something for the P2 that actually is like backwards in some senses, so that it's more distilled. There are fewer things you have to know in order to use it. And it's more, so it's easier to learn. It's easier to get a handle on, because when someone can use something with confidence, they can use it to its limit. You know, and people can't even barely scrape what a PC can do because it's all obfuscated by too many things. But if we could make some kind of tool system that presents what's possible in kind of a geometric fashion, so you can build upon what you've already built and what other people have built, without things running, you know, without anything ever getting unknowable, then that might have value. And it might even mean, you know, simplifying some things, getting rid of some features that the bigger tools have. But the point is to get things down to like what set of concepts are most valuable and most learnable and then most leverageable without needing to know too much, because everything requires a lot of, well, I shouldn't say that. A lot of stuff requires no knowledge these days, but like in the case of some of these email programs I use, it's like, or some other programs, every time I go to them, they act different. You know, that's not good. We need something consistent that can instill confidence that people can build on.
Right, and that is what the computer industry doesn't do right now. You get updates all the time and you don't know what works, and that is what P2 and P1 should avoid.
Yes. Yeah. I was telling.
agree.
Yeah.
I thought Raspberry Pi was going to be doing that. The Raspberry Pi Foundation.
Yeah,
But they came out with a Raspberry Pi OS. I've been struggling with these things. There's all sorts of tutorials on how to use Raspberry Pis of all flavors. Like I was trying to do a headless Raspberry Pi Zero. The problem is all the examples I found on YouTube and on the internet how to do it, they're all older revs of the OS, which doesn't even configure the internet or the Ethernet and the USB port the same. So you've got constant revving going on, and that I think that was one of the wonderful things about the Commodore era, is we all had the same ROM. We powered it on, and we got a ready prompt. If we pirated a copy of whatever game from our neighbor, we knew it was going to work on our computer without having to reload anything because it was just the ROM and the program.
Right. Yeah, and today it's so ambiguous and it doesn't work consistently. And plus everything is spying on you. Everything's using its opportunity to interface with you to collect data on you. And that's
exactly.
And you don't even know the extent of it. I mean, here I have my phone, right? This thing, and I can talk, I can make text messages by speaking, but every single day, if I say period within the same day, it might print a period or it might spell out PERIOD or COMMA.
Or throw you up a commercial for maxi pads.
Yeah.
Anything. It's just, so it's like, it's horrendously inconsistent. I mean, I know they're like dynamically, they probably have some kind of like machine learning thing. I mean, I'll start to say something and it will finish my sentence with some like ghetto verbiage that's not even proper English, but it's what most people are saying today.
Obviously.
Because that's all it knows. It's just machine learning, it learns what's going on and it supposes you want to do that. And it capitalizes words that have no need for capitalization because at some point there was a movie or a song called that or a product, a trademark. And so it's like, I want to get in there and figure out how to turn all that autocomplete back off because it's become a net headache now.
Yeah, I've got a Google Nexus 6 phone, and I didn't buy it because it was Google. I bought it because it had secure boot, and it was the only one at the time. The thing, I run CyanogenMod on it, which is an old ROM that was from the open source Android project, AOSP or something like that. And it worked quite well. It worked with Bluetooth and worked with other stuff. And it didn't give away my privacy. I don't have any Google apps. I go to fdroid.org to get my apps if I want them. But the most important thing is it doesn't do things I don't want it to do.
Yeah, that's how things should be. I mean, we have no control over anything. We just are kind of like, we just have to take it or reject it altogether almost.
Right. Well, even if you built your own computer with an Intel or an AMD processor, you still don't have control because there's cores in there that you can't get access to.
Yeah.
It's just crazy unless you go all the way back to the original core architecture for Intel. I'm not sure what it is for AMD. That's why I've got an old IBM X60 because it's got a dual core 1.6 gigahertz processor. I know nobody's going to be controlling some other core in it because they don't exist. But I would rather have a system a little bit more simplified, like a P2 based system, even if I have to have 5 of them. On a board.
I mean, thinking about what the TeamOz does with kind of multiple P2s. I mean, 3 or 4. I mean, if you have those hyper RAM ones, then we even have RAM. A couple of them could definitely do a nice working computer. I mean, we need to No, Catalina is able to access external RAM. GCC is was, but they cancelled it somehow. Eric said, not yet. Maybe no. Maybe use that hyper-RAM for something, you know. But in my opinion, a couple of P2s could all really replace. I mean, a nice database, you can do that without any problem.
Yeah. So, Michael, that you know how I showed the cascaded modules, like where you have two of those in a series. You know, you can have one of them running whatever the application is, maybe running MicroPython, and then when we do the translation, you know, because you can just hook these across. So there's your prop plug coming in, and then that hooks onto the next one, you know, and so we can have the debug renderer in the second board, which, you know, which shows you what's going on, or it can be whatever you want in the second. Like if you can cascade things easily.
Exactly.
As you point out, using, you know, we're using 7 pins because we've got 2 for power plus a prop plug and 1 kind of user pin. Then you can make these things happen. It's if you haven't already, it's worth playing with the MicroPython environment on the P2, because it does give you that world which is kind of self-contained but powerful. You know, you don't get any interruptions. You can save stuff to the flash. It's got a nice editor. And it works with your favorite keyboard, you know, so you get a nice gaming keyboard or whatever, and you plug it in, and away you go. And it just feels like a kind of sort of a heavenly environment that we haven't had in the PC land for quite some time. In between 11 o'clock last night and 6 a.m. this morning, when I'm presenting, Windows decided to reboot this computer, which had everything set up overnight. Nice. And so when I came in this morning and thought, oh, surely not, you wouldn't do updates now. And it had rebooted, and not all my programs recover. You know, Microsoft products, they go back and they load up the files again and all that kind of thing. So the PowerPoint presentation was okay, but I had other stuff on other things. I was just going to tab to show other aspects of what we were doing, but you know, it's that kind of thing which drives you mad, and it just seems to happen when you're under pressure. You know, when you.
Oh yeah, I've been on a couple of tech calls with companies, and their computer reboots while we're talking.
Yeah.
They don't have any control.
Is it just me, or does it seem like big tech is trying to keep us off balance?
Yep.
Off filter, yeah, it feels like it.
Yep. I think if you don't respond with fury to these things, they know that maybe you should be, you know, considering, you know, getting into a retirement home or something, you know, but so because it makes everyone, you know, drives everyone slightly nutty, but it reminds you that there's more to life than a working computer. But yeah. Hey Chip, did you see, this is, I think Adafruit actually posted this up in one of the Slack channels, but it's one of these Gartner hype cycle graphs.
What is that a graph of?
It's a graph of stuff which achieves peak hype, which is up here. And at the moment they're talking about like edge AI being, you know, overhyped. Risk 5 is somewhere around here.
So it's coming down.
Risk 5. So what happens is we get all our hopes up, and then we kind of get disillusioned with how long it takes for it to appear and make the mainstream. And then here they're talking about getting, you know, and what they call over here is like the plateau of productivity, where your stuff is actually working for you rather than vice versa.
Oh, interesting.
Yeah, and so they just have different technologies, and it's really just keywords which people, you know, associate with things that are happening or they want to happen.
What's interesting that again?
It's a Gartner Gartner review document. They publish them regularly, and you got to take it with a grain of salt, grain of sand, because it's kind of I mean, Arduino's in here. It says it's not yet achieved, you know, maturity. MicroPython is sitting in here, so it's about to embark on its what they call
productivity.
The slope of enlightenment, which is where it sort of makes some progress, and then eventually, you know, it hits kind of the mainstream and where it's productive, what they call the plateau of productivity. So I'm sure, I mean, this will be online somewhere as well, if not, you know.
Yeah, I'm looking it up. That's pretty interesting.
Oh, here you go, 441495. I'll see if I can find a link online. But it just kind of shows, and for the most part, it seems to agree with what people think or where it's at. And interestingly, although MicroPython you'd think is almost there, it sort of says that it could be 2 to 5 years away. And one of the interesting challenges with MicroPython and all the work that they've done, it's still pretty much just a few core people who are working on it, and it doesn't at this stage. It's not looking like suddenly growing away from that and into a larger organization. And that probably means that, yeah, it might take a few years, even though you've got big companies like Lego investing in it and stuff, or using it in their Mindstorms.
Oh, I see how this hype cycle works now. I'm looking at a page. You have the innovation trigger, then the peak of inflated expectation down into the trough of disillusionment, then the slope of enlightenment, and then the plateau of productivity.
That's it.
Yeah.
Yeah, it's cruel. It's cruel.
It's cruel because do you really want to know where your technology you're heavily emotionally invested in is at on the map, But
well, I don't think we're anywhere. We're like the kid in high school that nobody knew.
But we're not like a small minority of people that would rather just disconnect from the nonsense that is all this revving in Microsoft and Apple and Linux. I mean, there's lots of frustrated people out there. If you build a platform that solves that issue.
Well, yeah, I would think there would be, but you know what? All of the discussion of that reality seems engineered out of the discourse that occurs. It's like, exactly. Yeah, they make you feel like you must be the only guy that has this problem, where really maybe everybody's experiencing it. And there's this thing called, I think I mentioned it here once before. It's called the Delphi technique. Let's say that you want to steer a group of people's thinking and you approach them and say, okay, I want to know, or here's what we kind of want to do. And now I want some feedback from you. So they write their questions down, fold them up, put them in a thing, you get them, but you don't use those questions. You use questions that are like copacetic to what your goals are, so that everybody would write you like, why in the hell are we doing this? This doesn't make any sense. I don't like this at all, blah, blah, blah. And then you answer questions like, how can I best leverage this new thing for my company's benefit? And then you answer these questions, which were completely manufactured, right? So everybody then is thinking, oh my gosh, I hope they don't draw my name, my question. I'm going to be so embarrassed if they ask that. Because you've been now told that you are like a disappeared minority, that you don't, exactly. Nobody shares your thinking.
Yeah.
Everything seems like that these days.
You just have to find your tribe, and it doesn't matter if whether you're relevant or not. If you've got a tribe or a community you can work in where that's relevant,
yes,
that's all that actually matters. It's kind of.
Well, that's all we got. So that's what we have.
But we're all still attached to Microsoft, Apple, and Linux, right?
Say that again.
We're all still attached to Microsoft, Apple, and Linux.
Well, yeah, unfortunately, yeah. I mean, I kind of wonder, like, if we got off of that.
We have to build an alternative. We have to build the P2 running CPM and kind of fuck all of them out of the world.
It'd be fun to like get way away from all that stuff and then become really strident about the fact that you don't play their game with them anymore. They'd probably like do something to make whatever you're doing illegal.
Did you guys hear about this great big sting operation that happened on all the top in Australia recently? They basically, this anom that's called AN0M handset. So they made these special encrypted handsets, which are made by the federal police here and the FBI over in the US. And then they persuaded the criminal gangs to use this for all their communications. And
so
they've just reeled. That's right. So I think at the start, they didn't quite have the way to decrypt the communications, but then they worked it out or whatever. It was planned. It was like planned that they'd be able to listen in. And they distributed these special handsets. And the only way you could get one is if you're like a criminal mastermind or whatever. And so they distributed these around to all the gangs, and they've just reeled in something like 4,000 criminals who are using this system, and they've been sort of watching and listening for about 3 years.
Wow.
3 or 4 years.
So they just wanted to take out the competition.
Well,
That's right. It's these people think they have more rights than us, those that claim to be government.
Yeah.
But sure as heck, right now there'll be a lot of criminal organisations in housing their development of encrypted phones. You know, it's going to be, you know, they've got the money to do this stuff. Obviously, they've been burnt once. They're not going to make that mistake again. So this is one trick you can play once. You know.
Right.
Well, Bitcoin's encryption hasn't been hacked yet. We could use that. There's SHA-256 hashing algorithm, and the public key encryption hasn't been broken. There's trillions, billions, hundreds of billions of dollars on it.
Yeah.
Well, if it had been broken, you may not hear about it. You know, it's kind of the thing that.
Yeah, they might try to bury it, depending on how vested they are and how much they're in love with it. Yeah, they might try to, but I think it would come out at some point. It would be held down for a while, and eventually it would become known.
I since the world is bankster run, I think they would have killed it by now. At the same time, OpenSSL, that all the secure websites are quote unquote secure, that thing's been cracked for a long time. But yet we're all doing commerce on it.
Wow. Wow. You know, it's something about, if you have a group of trusted people, you could actually have commerce among them and everybody could benefit, because it's like my wife and I, this morning we got on, here in America, we have this thing called workman's comp insurance that you have to pay for any employee. And we got Marco who works here, right? He only works here like 2 hours to 3 hours a day. He takes care of stuff. And we have to have workman's comp for him in case he gets hurt. Well, they just decided to audit us, which happens to everybody in time. And now they're holding on to our old escrow account, but they want us to put money into another escrow account. So now we'll have like $2,000 locked up for a guy that makes $5,000 a year. You know, and so all this stuff, it's like, now this is why people hire their family members, because you can kind of, you know, if one of your family members gets hurt, they're not going to run off and say they were injured at so-and-so's property. You're just going to deal with it as a family. So it's like they've made normal life so expensive and so unprofitable that it's hard. I mean, unless only the big guys can survive with those kind of cost structures, because they can amortize it out and do things. But little guys, that's hard to do. It's hard to make it.
And that's the plan, Chip. They want to kill all the small businesses, whoever they are. I don't know why. I mean, for me, it doesn't make sense, but I see it happening here in the Oaks a lot. That, you know, they give up. The last hairdresser in town has now a sign for sale for a house. You know, now everybody runs around like a hippie because we don't have a hairdresser anymore. No, they want to kill the small businesses. I don't know why.
Well, I think it is true. They do want to get rid of them. And I think it's because they want everybody. They don't like independent people, because independent people aren't inclined to like do what they want. And so they want to bring everybody into dependence.
No, they will not get me.
They've already got you for 30 plus years, Michael. You've been using Microsoft.
Yeah, you're right.
You're addicted. I had this thought yesterday. What if I could just simplify my computing life to just a single Raspberry Pi Zero and never update?
You have to simplify your computer life to just a P2 or a couple of them.
That would be fine by me.
Yeah, I mean, honestly, what computers are there to solve problems you wouldn't have without computers. I'm doing that job since 45 whatever years. I hate it right now. That's the reason why I bought all that walnut stuff. I'm opening a wood shop and a car shop. And
A wood
Michael,
shop.
did you ever count up about how many board feet you have?
I just kind of counted the stacks. So we have around 308 boards, which are around 8 or 10 board feet. So it's at least 3,000 or 4,000 board feet. Just the big stacks and not those other, there was kind of more. So it's about 4,000 board feet, I think.
Okay, that's what I thought it was. But then when I pulled it all out, it looked like more than that.
No, I haven't measured it yet, honestly, but there are pretty nice big chunks in there also, which kind of would be a table like there are, you know.
Hey, would you mind if I showed these guys pictures?
No, I don't mind. Put them
Here.
over.
You can see Mike's new boss is a bunch of wood. Let's see here. So here's.
I got wood and tools.
Yeah, let's see here.
That
Here's
was
some of
after
it.
delivery, yeah.
There were 5 more pallets.
Second row, yeah.
Oh, look at that battery.
That is a battery which is
you were talking
replaced
about.
through. That is a battery which we replaced through that thing which I showed you. In the
Oh my goodness. Let's see. Yeah, here's the
the jointer and the planer, yeah.
bandsaw. And there's the planer. So you're moving it all in.
It's all under the roof now, yeah.
And here's Mike's. Mike has some of these he bought. Here's a picture of one. He said they have a Harley engine in the front and 1 wheel in back.
That are those Corbin. They are called Merlin. I think that's a Merlin, yeah.
Yeah. Let's see here.
Completely useless car, but it makes fun.
Yeah, here's the bandsaw.
Yeah, that sucker is big, yeah.
And then here's Mike's pride and joy.
What? Yeah, this one.
Right here.
Oh, I got that last month, so.
White wall tires and all.
Isn't it a fucking ugly, nice car?
So who did the wood on the outside?
It's not even wood, it's plastic. All of it is plastic. It's not really wood.
Is it going to become walnut?
Maybe, yeah, I'm thinking about it, yeah, because I have way too much of that stuff and I cut it probably. I tried, I can cut it at least over 5 millimeters without breaking. So I could maybe replace those panels. Yeah, that is what Chip lured me to.
Yeah, well, this was the start. I had about 20% of it left when Michael wanted it. Here's what it looks like.
Wow.
Yeah, it's nice wood, and very good, in very good shape. I mean, it was stacked nicely, like you can see, with wood in between, and cut nice. No, it's even if it's pretty dry now, because it's, I don't know, 2-3 years at least.
Oh, no, it was 13. It was 2009 we cut that.
2009. Okay.
Yeah.
It's pretty dried out, but it's dried out nicely. I mean, it is pretty plain. No, I like it. I just don't know what to do with it yet, but I will find out some reason.
Does that stuff harden as it gets older, as it ages?
Yes, yeah. Walnut is pretty hard. It's getting pretty hard, so you need serious tools to work on it.
Yeah, there's that big bandsaw, but since Mike was buying the wood, the bandsaw and the planer I threw in, and I gave him this jointer, which needs a V-belt. But with those 3 tools, you can completely take that wood, plane it, cut it down to size. You could cut bulb lengths and sell them to wood turners. You could, you could do all kinds of stuff with that wood.
How big were those pallets? What were the dimensions on the pallets?
About 4 by 4 feet.
So all
the boards are basically 3 feet by 10 inches by 3 inches, something like that. They are basically cut for gun stocks, sort of.
Yep.
So that's the problem. Basically, they are pretty short with 3 feet, so you have to, they're good for stairs or, I don't know, maybe kitchen counters when I cut them and run them through a planer.
Beautiful railing.
Yeah, railing, stuff like that. Yeah, it's wonderful wood. I mean, it has unbelievably nice colors. No, I will do something with it. And I thought it's better. I don't trust the money market right now, so I took money out of stock. I mean, half of it probably. Things are going down right now. Inflation. I think it's better to have walnut wood than money. I can over the next years I can make more money out of that wood as I can do out of money with, I don't know, 0.2% on the account, and what we have inflation of 2.3 something. No.
My grandfather, the father of my mother, used to drive the haw trees against a saw, a rotary saw moved by water.
Yeah.
At one side of the tree, pushing or pulling with a piece of steel, while another man double his height and weight pushed and they need to move the trees against the saw at the exactly same time, so the cuts hold straight during the whole operation. So my grandfather needs to exert a lot of pressure in his hands, and his muscles he grow higher than Popeye ones. Yes.
That will not happen to me.
He had enormous arms and hands compared to his height, because he uses to exert a lot of force of pressure against the muscles to keep the trees straight against the saw.
Yeah. I mean, I was sweating pretty much by moving that stuff in, because the forklift didn't fit. We could unload with that forklift, but I couldn't really put the stuff inside my carports because the forklift was too high for the carports, so I had to muscle it, sort of. No, Chip gave me a lot of work, but now I have it basically under shelter, and I will find out what to do with it. And if one of you wants to have a cat about 8 weeks old,
can you hold your cat up, Mike?
Yeah, I even would put it in a package and kind of the thing is not giving up. it's constantly throwing things from my desk, climbing on my shoulders, climbing on my desk, climbing. Whatever I do, that cat is after me and biting and fighting and
Well,
yeah, about 8 weeks now, something like that, you know.
our little kittens are 10 weeks now.
Just doing bullshit, that thing. Playing with my oscilloscope, sending text messages because I have Skype open because I talk to my company and he is walking over the keyboard and sending my company text messages.
Wow.
Which they don't understand.
Speaking of scopes, I just happen to, do you know who Ben Eater is on YouTube?
Mm-hmm.
Well, he's a very good teacher, and he built up a computer from scratch from chips. He made his own processor and stuff on breadboards, and then he built a 6502 based computer, interfaced everything through breadboards and a whole stack of them. He even made a video card out of level shift registers and such. Anyways, he had a video out recently that talked about how the USB protocol works, which was pretty doggone interesting, I thought. And he had gotten a scope from Insight that analyzes the USB packets for his USB 2.0 keyboard, because the old one, or maybe it was on both of them. Anyways, I was thinking, you know, the P2 could do all that. Even the touch screen, the decoding of the packets, everything. The P2 could just do it all and just run the screen and have way more than 4 inputs. I thought of the P2 when I was watching that video, but it's an interesting video. He goes into detail on how the USB protocol works.
Yeah, I see the video. I pulled it up. Ben Eater is his name.
Yeah, he's a really good educator.
Neat.
He needs a P2.
Yeah.
He built this 6502 base computer, and at one point he brought in a Atmega board with a lot of IOs on it to analyze what was going on his 6502 base computer. I thought, that's an excellent opportunity to put a P2 in there instead of a Atmega. But I'm guessing he's heard of Parallax since he's into education, obviously.
Yeah.
Oh, and he does sell that Atmega board on his website, eater.net.
Okay.
I think. But the P2 could, if you scroll through the latest video, it's near the end where he gets out the USB analyzer. I'm thinking the P2 could do all that.
Yeah.
All by itself. Just the P2, a clock chip, a boot chip, and a processor. I mean a power supply.
Wow.
And that's full. I think the P2 is like going to be built into a bunch of bench tools, because it's got everything. It's got all that analog. It's got the processor cores. It'll do fast data acquisition. It's got everything you need in a bench tool. It just doesn't. You just need calibration for voltage metering and stuff.
Right.
But it would need, you would need low latency, like either prop to prop communication or just all within a single prop, where you both your measurement and your video display done in the single prop.
Maybe we could find ways to build things with multiple prop chips. I mean, as kind of just a standard approach. Like, you could always make one chip do a lot of stuff, but I wonder if we could come up with some, like, if we put the tools on the P2 edge, we make them so you could target multiple systems, and you could write code that, you know, when you hit download, it downloads different things to different chips. And you could break apart, because really wiring is quite an expensive and effort-laden issue, right? So putting smaller things out at distal points, sometimes where they need to be, is better than having a whole bunch of wires going into one central place. I wonder what we could do, kind of like what Lachlan did with that little board. You know, if we could kind of standardize like an approach to design where we use, it would help us sell chips maybe.
Yeah.
But
that could be.
Yeah, well, Chip, we come back to what I talked before about that. You might not like it, but it's from Bo Schwab. But it's a brilliant idea because it puts a layer of shared hub RAM over a couple of propellers. It's just another layer. You have COG RAM, hub RAM, and shared hub RAM, which is, you have that one you have to access with lock. You have every write operation has to be pretended by a lock, and then it's shared and it's transparent and it's perfectly working. It's a so stupid concept, and you can do that with 2 wires, 4 wires, 6 wires, doesn't matter. Streamer, shoot it over to the next one. Get it from one, unlock it, processes can write, lock it again, and go ahead.
Yeah.
Next one. And then we have shared hub RAM over a couple of propeller chips. And you can use them like mailboxes and buffers, kind of 512 bytes for the sector. And you say, COG 174, please read that sector from your disk. And it comes around in the buffer in, I don't know, a couple of milliseconds. Basically you can use a mailbox principle over more than one more than one propeller. That's the basic idea of that ring buffer, which I tried to build on P2 and failed, and Bo did with that high-speed serial and some code around. It's a pretty nice principle. And then you can basically treat a couple of propellers as if they were one, just farther away, take a little bit longer to react on the mailbox. But you can write in the mailbox and you wait for the answer and you get your answer back. And it's kind of the same principle like talking to COGs with mailboxes is talking to COGs to different props with mailboxes. Same thing. Just we are running, I don't know, 20K of buffer running around for transporting.
You could come up with a standard protocol and start with serial and just add bits, you know, kind of like PCIe does. So if
I have that running already with two wires, 3 wires, 4 wires, 5 wires, 6, 8, 12. The streamer is easy there. You just need to change the. I mean, the streamer is pretty nice. My problem is I have 3 A boards and 2 B boards, and the streamer commands changed between them boards. And now my software doesn't work anymore.
Hey, Lachlan, do each of your little boards, do they have their own clock?
Yeah, sure. I have. That's all eval boards.
I was talking to Tubular.
So that's the reason why I just can go to this clock 2 is reliable. This clock /3 is better. 2 is reliable. One doesn't. Even if the streamer is, but they have too much shift in between.
Yeah, Douglas, they all have their own crystal. but there's an isolating, like a tiny resistor or link, which can disconnect their crystal in preference for the like one of the corner pins on that 60 pin connector. And so the idea was, like, if you're going to stack these things vertically, you know, so they're 2.6 millimeters up, then just having that one corner, which is kind of closest to the XI pin on the P2, hopefully we can do like a fairly compact. We don't end up with a distributed clock tree, but just a compact, you know, it's like a vertical kind of line.
5 in a stack, 1.5 millimeters apart, and providing with the same clock source. Oh. Yeah, but that here, Yanomani said that's maybe not wrong also, putting in an inverter in between each for the clock. It would kind of power the clock a little bit better again, and having inverted clock between those layers might be not wrong also. I like that idea.
We could possibly do that. When you make a stack, you've got to have like a male connector on one side and a female on the opposite side of the board. And then you've got to have these vias to connect everything through. And that's kind of a challenge, but I've had a go at doing it. And what you end up with is something which is about 6 millimeters wide instead of the connector being 2 millimeters wide. And you kind of have to squeeze everything in, but you can do it. Now, that's important because you can do kind of stack-based. With the P1, I tried to make like a stack-based system with the quick start modules where you'd sort of plug in, take how many pins you need for whatever board it was, and then you'd shuffle all the other pins down on the output. And so each board would kind of always be using, like, you know, what it thinks of P0, P1 or whatever, the low pin numbers, and all the other pin numbers would kind of cascade down on the other side of the board. Yeah, so that's in the forum somewhere under the P1 forums, and it goes back about 10 years. So we're trying to do that with the quick start. But with the P2, you've got more pins, and it makes sense to it makes more sense to have a really good go at this. So with the stack arrangement, you can do that kind of shuffle pins down, or, you know, you can have some pins which are global, just connected all the way through for communications, but have other pins which are kind of consumed as you go down the stack. But you don't waste them, you know, you just have, if you need 2 pins for USB, that's what you take. And if you need 8 pins for DVI or HDMI, then that's what you take there. So you end up with and I don't know of any other architecture other than FPGAs which could deal with that kind of requirement, where you just take what you need off the stack.
Right. I mean, that's a funny thing that all the pins are equal, you know. I mean, except those couple of up top there, you know. But else, I mean, you can really make things easier.
That sounds pretty. Are you actually going to produce these to sell, or is this just for in-house projects?
I think this will be the 3rd attempt at producing them for sale. In fact, the 4th attempt. I started with the Propeller 1, and then I changed it, looked at using the Intel Edison, and then finally like the Raspberry Pi. And so I've got hardware, like I've designed boards and kind of tested out the theory on each kind of platform. But I know, I mean, it's not rocket science. It's just it's a discipline, you know, of putting the pins you need where you need them, so that you can pull them off the stack and replace them with pins from further up the chain. So yeah, it'll work okay, but it does make sense with the P2. It's a good match really for the Propeller, more so than say the Raspberry Pi, where those GPIO pins are distributed all over the place on the header. Like they go in some kind of sequence, but they're you know, they skip a few numbers and things. It's just a mess.
It is.
Yeah, so this will be probably, I think, the 4th hardware attempt to do it over a period of a decade. But every time I look at other systems, like you look at when they stack Arduino boards, and you have to have like jumpers, so you can choose which pins you kind of talk to a particular shield on. There's this kind of, you know, it's one of those lesser unsolved problems that Chip was referring to, along with how to name things. You know, whenever you have a stack with kind of rigid or dedicated pins, you end up with this same problem, and you end up having to switch or jumper or multiplex everything. And it's kind of more efficient just to have them so that each board can pull off the stack what it needs and shuffle the remaining pins down. So all the previous designs are all designed around DIL, like 0.1 inch style connectors, 40 pin connectors, other than the Edison, which had a fairly tight board. But this thing we're doing now, where the connector is about the same size as the prop plug, this should make it kind of shine. If you're not really taking up much real estate to do it, it should work out well. And the other challenge with it is just the capacitance of long lines. Like if you do it in 0.1 inch, you have these long traces. But if you do it with a 0.35 millimeter connector, the capacitances and things are quite, it's kind of tight and compact. So hopefully it works out and sort of matches the kind of speeds that P2 can drive, but I guess we'll find out.
My fear would be that I just look at it and some sheetrock piece falls out of my hair and the whole connector is kind of fucked up.
Yeah.
Another style is like how XMOS did it, right? You just stack the modules one after another, and they've got mailbox in between them.
Yeah, I never really looked that closely at XMOS. I think we bought a development kit or something, with the intent to look at it. But the P2 was always going to be a better for analog, which is what we sort of want to use it for. So, yeah.
Are you doing Python over the net? Like you could launch a cog on another P2?
Not as yet. No.
But it's planned.
That would be quite nice, right?
Yeah.
Then you've got a fully expandable system.
Yeah, a bit like Chip. We're developing stuff which ultimately will have to be network connected, but we're putting off all the networking stuff because that side of it is developing and evolving, the IoT space. And so we figure we, solve all the other stuff first, and then we'll get around to hooking stuff up on networks. But that'll be kind of the last stage of what we do. But for now, it sort of complicates your world as soon as you start interconnecting everything on a network. We're happy just to sit in the kind of serial domain or, at the moment. But yeah, obviously we've compiled MicroPython, we've got that ready to go. And as that becomes more network connected, we can kind of ride that wave.
Yeah, and you proved that the multi-connection from in the boot ROM, that boot stuff, that works. I mean, nobody tested it before, so thank you for doing it. Now we know that it works.
Right.
It's a nice feature, in my opinion, a very nice feature.
Yeah, look, everything we've thrown at the P2, like the P1 before it, we've managed to get to work. There's just been a few little, very minor kind of things along the way, like that P0 and P1 thing you can't use for ID. And as long as you know that and document it, there's no issue.
Yeah.
We haven't found any showstoppers at all.
Cool.
Were you the guy that did the big boy bunch of propellers booting at the same time on breadboards back on the P1?
Yeah.
It was Clock Loop.
That was who?
Clock Loop. Forum name Clock Loop.
Yep. Sorry, Humanoido. Humanoido or Clock Loop?
No, Humanoido was into the
Humanoid was just talking, but Clock Loop really did. Yeah. Clock Loop really did, or is doing, but he had 100 P1s booting in one. From one.
I thought you were talking about this, Douglas. This is like the P1 collection stuff we did, but that was the smorgasbord from years ago.
Smorgasbord, yeah.
But you're talking about putting all the same, like rather than one of everything. You're talking about like where you had homogeneity.
Yeah, I need one of everything.
Yeah, Clock Loop. He had like 2 feet square of breadboard with a whole bunch of propellers, and he booted them all off the same 2 pins, which is kind of what I forgot what he called. It was like big boy. He referenced a picture of a multi-engine train It was pretty cool. I thought of that when you were.
Yeah, but he didn't figure it out how to program them and do something useful, and that is basically the thing. What connecting them is one. The second thing is support of the software, that you kind of can use mailboxes in another propeller, which is what basically both driver kind of that thing could provide. You know, you need probably dedicated lines back for communication, because you can't use those two serials for you know, the boot lines are basically after that not really useful except for commands, I think. I don't know.
You know what we need to program, Michael, is a real life game of life where every propeller can reboot and reprogram every other propeller. And you have like one propeller and it decides, you know, my time on here is coming to an end, and it goes and programs off.
Oh, I didn't thought about that one. You are right. Basically, if you can establish kind of a reset thing with a break over serial, kind of 10 times low bit or something, the classical break. No, I mean the ID followed by the break, and then you could soft reset one single propeller, and you can basically program everyone from everyone. Oh wow, yeah, sure. You don't need a PC. Oh, that's a nice idea. I like it.
Anyway.
To get back to what you were saying, Chip, I think you're right. I think a multi-prop environment would well, for one, it makes the cog programming paradigm even more, because you never run out of cogs. You just add more chips, and it would also make the make for better sales.
Maybe, yeah.
Yeah, and basically the transfer between the chips can run over serial, or even here we have that Johnny Mac, you're just building those RS432. They can do a little bit more distance because different signal.
We need some kind of like messaging protocol that would be really like deeply integrated into the whole thing, so processes could communicate. Not necessarily cogs, but processes.
Yeah, the thing is, what I just followed both thing, which is having a kind of 20K buffer, and you sending it around with locking, and everybody can it comes in, it gets unlocked for a certain time. Some programs waiting for their lock can now kind of write their shit, and then it gets locked again and shooting out to the next one. That is both principle. Simple but works. Arglo with this driver for video did that display thing, list thing, which in my opinion would be even nicer, that your each cog has kind of that networking cog thing, each chip, which gets the frame at his getting some longs from here, getting some kind of working up a display list of things he wants to put in the buffer, and then shoots it out again. So you don't need to change all the drivers. They have some buffer address, whatever. You just go there. And so I think it's just but basically what we need to do is transfer that mailbox system, which we have now, to communicate with cogs, to communicate with cogs on different props. But the same principle. You are shooting around a small buffer of hip up or whatever, and everybody has a chance to change it, and everybody can read whenever he wants to because he has a last copy. So basically, that the whole concept should work. and it would just shoot around the buffer of hub with whatever screamers, 2 pins, 3 pins, 5 pins, whatever you have open. Same thing.
If you make a standard protocol and have it well defined and well tuned for performance, that would be helpful for the whole community for building props. And you got to make it expandable, whether you're doing serial or
Right.
4 parallel or 8 parallel or.
No, I think that Chip, you never confirmed that again, but you told me that the new C version has some streamer mode which can be external clock for ADC.
Wait, no, the streamer doesn't have, the streamer cannot clock externally, but there's one mode, Sync 2 and Sync 3 can clock externally.
You have some ADC mode which is clocking externally.
Right, and then we have the.
And you told me that if I switch off that ADC bit, it will clock in pins externally.
Right.
And that is basically what we need for the transfer thing. One of them sends out, and the other one, and we don't need I mean, if we can use an external clock to import data, we can do that, run that ring buffer with any pin weight we want. 2 pins, 1 pin, 3 pins, 7, doesn't matter. Streamer does it. But one has to send out the clock that the other one gets that clock. Then we can transfer with this clock instead of half of it or third.
And you could even just standardize it at like 20 megahertz or something, and everybody can generate 20 megahertz on their own. That's not a problem if they're all running way faster. So you wouldn't have to even be using external clocking. You could just have it asynchronous, but at some fixed rate.
Yeah, I tried that, but I had a lot of trouble with going fast. Also after this clock 3, asynchron kind of got fucked up. So that's the reason why I would like to try that external clocking, because I think that might be the more solid solution.
Yeah, and I wonder if doing differential signaling, and you could do that by having pins,
Yeah, could use another smart pin to kind of do the opposite.
Yeah, the low-level smart pin can output the opposite of its neighbor.
Exactly, and then we have differential, which is nicer for longer distance, and still fast. I mean, good, with Nachland, we don't need longer. We have 1.5 millimeters. That's pretty short.
Right.
But I mean, connecting 3 eval boards, we are talking about 1.5 inch or so on wiring, and that's already fucking up with me at this clock too. As a half of divided by 2. Yeah.
There is another way. You can use a central propeller for each group of 6 other propellers, and yet had a channel to connect to the next cluster, and so on. So you can make a ring with clusters, each cluster running 6 propellers. So you can keep the whole structure of the central hub in the central propeller to connect and switch on.
Yeah.
It's really fast.
And our connection node, yes.
And you can use the 6 pins with a central 7, in fact, with the central one as a clock, to the 3 from the left and 3 from the right, using synchronous serial. So you can have 2 channels, one for out and one for in if you want, or 2 outs or 2 ins at the same time, and only needs to craft a protocol.
Right.
Each cluster, the central one will control the protocol, and in a group of 8 pins, you have a spare one to communicate with the central to
Yeah, but
match
I
for the
think
messages.
that gets too complicated. I mean, I'm fine with kind of like daisy chaining them and said I want 1, 4, and 5 to run this one. And that is the boot protocol gives that you if you leave out the lower 2 pins, you can basically even select groups. So all odd even odd ones get this program and all even ones get that. I mean, Chip did a nice job with that mask thing there.
There's
The
lots of topologies.
the central one would just be one basically to have a hard reset, you know. I mean, Tumulon's idea that we can do that with a serial break might work when there is already work, but if that thing is fucked up, you need to hard reset it and get it booting. So you basically need a reset line for all nodes, and then they can sit on the same. So you need, I don't know, one master P2 who is booting, able to boot each of them in the chain and send them the needed program.
Are there P2s booting off the P2s yet?
And please, what?
Are there P2s booting off of P2s?
I
know we got P1.
Shouldn't be that problematic. That hex booter hex I haven't done it yet, but basically it shouldn't be that hex booter the text hex, what is it?
Prop text. Prop underscore text.
Prop text or whatever. That thing is pretty solid for everything. You can send it, adjust baud rates and everything. It's solid. I tried it out. It worked pretty nice.
Yeah, we've programmed. Look, in effect, Brian's done P2 to P2 kind of booting in effect for something else. But you can also, I mean, it's easier to just test it on a PC because you can just send. And so one of the tests we did was just, can we send MicroPython and get it running just from a DOS command line, you know, copy com1 and then the file. And you can. You've got to get the baud rate right, and you've got to use prop hex instead of prop text so it gets in within the 1 minute. But yeah, it's just a serial stream combined with a reset. And but the reset could just be like a power on or something like that or whatever, you know, you just got to
the reset is, in my opinion, the problem currently with them different. When you have 8 of them, you want to program number 4. Either you have to reset all of them, send the program, they are rebooting from flash, and one of them takes it. Or you have to be able to kind of reset them each. So kind of a shift register where you kind of select number 5 and then reset it, and then so you need 2 more pins for resetting the slaves, sort of.
If you have them chained, like you could have, if you need to reset prop number 3, it knows it's 3 because it was booted by 2. 3 boots 4. 4 needs to get reset.
Yeah,
you gotta tell 3 to boot 4.
You need 4 pins per chip.
Well, right now they're using 4 pins just for ID.
Per chip, and 1 reset line we need to handle somehow.
You need 5 pins, 2 in, 2 out, and a reset out.
Yeah, see, I think that's wasteful. And you have basically to have one chip has to have the ability to boot the other one and load it from card or whatever. Or I think that's too complicated. And the current boot thing which chip provides is that, I mean, if you can reset the right processor, you send it down even if you reset all of them and you send down for 005, it will just 005 will load that, the other ones will load from Flash. But we have to reset all of them to do it. If you can get around that reset thing with, I don't know, one shift register and one reset.
Lachlan, how are
how
are you resetting the chips?
We've got an ID. We are using the reset line.
Who runs it?
So from the PC end, like Brian's got a multi-loader which just sort of sends down all the images, and so it does the initial reset, followed by loading each one in turn using a prop text or prop hex. Each board's got this ID, like that BCD encoder wheel on the top there. That sets the ID, and you can see like there's 4 pull-ups there. So this is like a 16 address kind of rotary encoder.
Right.
And so that's how, like, each prop, in effect, that's sitting on P44 through to 47, and that just sets the ID. And so when you send down a prop check, you know, it's looking for this particular combination on P44 to 47 before it matches, and it'll accept the code. And that's all been proven to work. As I said, just more, there's physical limits on the baud rates and things like that, but you know, fundamentally it works, and so you can do that.
You need to reset that one. I mean, or you reset all of them, they reload from Flash, and just one gets programmed.
Do they all get reset at the same time?
Reset them, each of them singularly. Because there is a check 1.5 will not kind of reset the chip.
Yeah, if you want to just reset individual ones, my suggestion is to just look, like, to have a cog looking for the text, like prop_check or prop_text, and just synthesize.
That means you already have to have a driver in one cog sitting and watching the communication lines. But if it's fucked up,
but it can just be. I mean, you've got to start somewhere. You can either start from Flash on the boards, or you can start from the ID. But you can also start from just powering on everything, and so you don't need the reset party line necessarily, because you can just power on everything and then send serial out combined with those address things, and that will just load up the propellers.
Kind of just having some driver running there watching. I mean, we have to watch one cog. Okay, we have one cog has to communicate anyways, and then can kind of watch for reset 00757.
Yeah, you
it
can.
tests itself, and then it gets the data sent and loads itself. That would work. That would work.
You can do it. Yeah. So one project we'll get to eventually, but we've sort of trying to do the thought experiment with, if you imagine a prop plug, and instead of putting out a reset signal, it just puts out 3.3 volts on that same pin. So, you know, your 4-pin prop plug, if you drive 3.3 volts out on the reset thing, obviously, you know, nothing stops until you have to have a prop plug which has a switch on its 3.3 volt line and interprets that, okay? Then you've got a 4-wire system for powering up the PC. Okay. So it's a driven...
You're thinking around corners.
Well, it's a driven reset, but do you know what the advantage of this is?
Yeah.
So, like SparkFun and Adafruit, they use this Stemma QT or SparkFun call it quick format. Okay, and what it is, it's a standard which defines 4 pins, and they're ground, 3.3 volts, and then your 2 data pins, which for Propeller normally that's receive and transmit serial. But in SparkFun and Adafruit, this is SDA and SCL. So it's an I2C based system. Okay. but it's compatible. Like the ordering of the pins is exactly the same as what we do in the prop plug.
Nice.
But the 3.3 volts replies the reset. And of course, if you design this, any system that's designed, which receives like a heavy power 3.3 volts on its reset, it doesn't care. It's just going to pull it high anyway. So, so in theory, we can make a special prop plug which has the ability to power down what it's connected to, and in effect, it just causes effectively a reset anyway. But it reduces the pin count.
Cool. Yeah.
It takes your pin count down, and if we program some code in to receive I2C commands as well as serial commands, which is possible, takes some development time, then you'd have something which is compatible with Quick, Stemmer, and Grove. These kind of I2C based systems. Okay.
Yeah, I mean, you told me in the presentation that you are thinking about using the same serial chip Peter uses supposedly in the P2D2s if they ever show up in life.
Yeah. Subject to there's real supply issues at the moment on some of these chips. So.
Yeah, but couldn't they maybe do some decodation of the transfer between multiple connected props on the same line?
Yeah, it's a part. I mean, these are party line.
When send that thing string to them, sort of.
Yeah.
Because that would solve the reset line problem. Currently, I mean, I love the idea. I have two lines running through all of them and can teach them. But when I need not 28 reset lines, it's bullshit, But if that chip maybe could also learn reset on. That would make things pretty easy to program any of them in the chain without disturbing the other ones, which would be the goal, in my opinion. Programming one of them in the chain without resetting all the other ones. That might be possible with that chip of Peter.
So, from what I can see, with that, not the chip, not the CPU Peter was using, but the CP2102, which is what it's designed to replace.
Yeah.
I'm just looking like at Mouser, they've got 80, 170, 210, and 60, 270. They've got 300,000 of those chips on order, but not in stock. So it's blown out. I think last time I looked, it was getting up towards 200,000, and now it's 300,000.
They're back ordered?
Yeah, in effect, they're saying, this is how many we've got ordered. Some of them will come in and go out the door, but basically, if you want to join the queue now, there's 300,000 ahead of you.
That's but you're talking about one of them for each propeller?
No, this is the Scilab's UART chip, which Peter on his P2D2 was using a Scilab CPU, which has got the same footprint as that CP2102.
Oh, okay. So the CP2102 is actually available.
No, it's actually on a huge back order, but the FTDI chips are available. So the things that chip can use, at least you can still get them.
If you still have to pay through the nose for them still, right?
And, yeah, they're more expensive, but some of them aren't too bad. The FT231, which they've used with the P2 successfully, that's $2. It's similar. It's not that much more than the Scilab's parts. So it's kind of interesting. But even on that, it is kind of, at least, they've got stock, but they got 50,000 on order, 100,000 on order on the FTDI part. So this whole landscape is really becoming a major headache. And at least with the P2, we're really just dependent on having a flash chip and, some kind of regulator and quite a few capacitors. You know, it'll be one of the last CPUs to be heavily affected, I guess, by what's going on. And Chip, you were producing, the fabs were produced on semi, not TSMC anyway, weren't they? Is that correct?
The what? The what's were produced at on semi?
The dies, were they made by Taiwan Semiconductor? Or
No,
they made...
on semi manufactures them in Gresham, Oregon.
Yeah, so I mean, you wouldn't be as affected. All these, I was reading somewhere that Taiwan Semiconductor, they use 156 million liters of water per day to make their chips.
Wow.
And they didn't get monsoonal rains this year, so.
You know what's funny? It's raining really hard out here. The whole shop is making a lot of racket. I mean, we're in a drought now, but it's really raining out there. It's been raining for like the last hour. That's unusual. And it's been cold the last couple of days. I kind of got like a little bit sick.
Same here. It's cold, yeah.
Anyway, hey guys, I'm gonna have to go. It's 1 o'clock. Time to.
I thought we've been
do
going
some
over
real
for
work.
7 hours.
Well, I can't wait to see your full presentation, Lachlan, because it sounds pretty cool.
Yeah,
Well,
we're just
that
gonna
was fun with that.
finish what we started, and then we'll share it all. So yeah.
Cool.
All right. Okay, we
All
can
right.
shut this thing down then.
Chip, there's one thing. Half of the presentation you did with those brushless motor thingies.
Wait, what about presentation of what? Woodworking?
Those brushless, those motors for the hoverboard, and your half of that presentation is on YouTube, but the other half is not.
Oh,
So
I don't
you
know
had
why.
basically 20 minutes where you started with that, how to you building that hoverboard and why. And so I watched it in live and I enjoyed it all. But on the YouTube video, it stopped after an hour or something, and there's not, the rest is not there. Where you explain why you do those waveforms and what all of that is not in YouTube.
You're talking about the
over
motor control?
to switch over to Steven, and he never posted it, or I don't know, but the recording in YouTube stopped after 20 minutes or something.
So you're talking about the motor control thing?
Right, yeah. So if you could do another presentation about it, it would be nice.
Well, when we get this new board built, we'll have something to demonstrate that can do impressive stuff. Yeah, so we'll put something else. I don't know what happened to the old one. Maybe the recording stopped, or who knows what happened.
Yeah, we split. Ken had to go to some other meet, and then it switched over to Steven, and then the recording on YouTube stopped somehow, so you can't recall it. It's not there. The other half is not there.
That's too bad. I have no idea.
Yeah, but do another, because I think that motor controller is a really neat, nice product. I like what I already saw about it.
All right.
Quite usable. So
We'll
make
do
another
when we get this board built.
presentation. Yeah. I'm tired. Oh God, it's already 8 o'clock here. Wow, 7 hours. Come on, we are breaking the record.
I think 7 hours is pretty, maybe it's about the limit. Oh my goodness, I've been sitting in this chair for 7 hours.
Yeah.
Yeah,
okay, guys, but basically it was a very nice, very useful conversation, I think.
Always is, yeah.
It's nice to finally get on. I was kind of thinking that it was going to be a nightmare, and I'd have to actually go get a laptop with Windows on it, because I've got some of those around here somewhere. But it loaded on Linux, and I had to load a bunch of dependencies, but I got it working. So that's kind of cool. Good to finally get on and chat with you. You guys have a good night.
Okay, you too. We'll see
all of you, and Chip. first floating point, then bye.
All right, guys, I'll talk to you. Talk to you later. Thanks for coming today. Enrique, I sent you a little message.
You are welcome always. I didn't want
watched
I
some
didn't
videos.
want anyone hurt. When my knowledge says me, warning, 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 I'm like a robot. I cannot shut my mouth.
No,
When I
that's
see
fine because
something.
I can totally perceive the danger there. I mean, all that thing would have to do is crack, and it would like move 3 feet in a millisecond and tear me in half.
No, Chip, you have to understand this. If you come down to Brazil and you meet Yanomami, he will not eat you, he will hug you.
I know. I figure.
Because Yanomamis are man eaters. They do. It's
Maybe
a
we
pride.
make a video where we take that thing out into the field, pump it up really high, and then shoot it with a big caliber rifle right at that weak point.
Yeah, you don't like to know, but please, yes, you need a rifle because you need to stay very far from that point.
We're probably like 100 feet or so.
I believe 100 feet is about 30 meters.
Yeah.
No. It's too close. The tunnel, yes, the tunnel where we tested the oxygen tank for the jet fighter from Brazil is about 100 meters long and fully illuminated by, at the time we are using some kind of mercury lights because it was in the 70s. And the particles blows away. So the gun machine, the machine gun was behind a huge concrete wall to protect the shooter. It's not kidding. It's very, very dangerous, please. Yeah, I locked before. There is nothing more I can do other than if you immerse that tank into a pool 10 meter deep, you'll be safe, but stay away from the jets, from the spray jets, because the water will blow like a dynamite.
Immer.
Like fishing with dynamite.
Musste mal lecken. Ja, das musste, da musste mal lecken.
Okay, thank you.
Okay, guys, very good. Thanks a lot.
Thanks a lot
Thanks a lot.
too. Have a
See you in a
wonderful. See you next week. Yeah.
Okay.
I
Bye-bye.
enjoy this.
Bye bye.
Have a nice day.
It's the
all of
best
you.
part. It's the best part.
All right. Good night. Good morning.
Good night.
Good morning.